article detail component look like? Let's also take a look there. So when you click on it, you see here is also a server.js file where we are passing the ID. So like when you click on an article, we just want to fetch the details for that particular article and rendering it here. What interesting here you note, if you can note here, is we are importing a client component here. The clap button thing, like it's a client component. So the good thing about React Server Components is both the server components as well as the client components can coexist together seamlessly, as we are seeing here, that the client component is rendered into the, is imported in the server component, and it just works as expected. And this is how the clap button component would look like.
You see the client directive here that would indicate that this component should be rendered on the client and should not be rendered on the server. One important caveat that we should take care of is like in your client-side component, you cannot import your server-side component. Like, because if you import it directly, it would throw an error. Because as we mentioned, server components are never rendered on the client, so it would throw an error. But there's an interesting pattern where you can pass it as a props, and that would work. So this is a sample clap button component. You could see that because this is client-side component, we are able to do all the state hooks and all the things that come with the client-side rendering. And we just have this function, the on-click handler, that just updates the number of claps. So this is just a normal component. So what benefit do we get when we use React Server components? So essentially for apps that rely a lot on data fetching, so the applications that are reliant on fetching a lot of data, it shines. Server components shines on those kind of use cases. Now, if you would have used a single page application for fully client-side rendered app, you would need to have an API layer. You would need to create your own backend to fetch the data. And then you would also need to take care of when do I call the API. You would need to pass the use effect to invoke the API and render the content. You would need to take care of the loading states and all those sort of things. But if you're using a server component, it's directly accessible, right? Because it's on a server, you can directly access your database and render the data. So that's one of the essential benefits that we get from server components. So in our application, let's see what benefits did we get by this approach. Faster initial page load. So because the data fetching responsibility is offloaded to the server, right? It would ideally your server would be closer to your database location, so your page would load a lot faster. And the next is reduce client-side JavaScript. As we mentioned, because the components that are rendered on the server, they are never shipped to the client, your final bundle size would be a lot lower, right? Which would make like a snappy experience for your users. So that would be one of the main benefits. Simplified data fetching. As we saw, like you could just make a normal fetch call and get data from your database or get data from any API. It's just a normal fetch call. And once you get your data, you could stream it directly to the client and it just works. For SEO-friendly content, it's like a huge deal because the component is a server-side component, the search engine crawlers would be able to see the rendered content, right? So the SEO, so if your components need SEO optimization, then it totally makes sense that you use React Server components. And it also provides seamless integration of server-side and client logic, as we saw in the example, that you could, both the client components as well as server components can coexist. All right. This comes to our next question. How do you decide like whether my component should be a server component or should it be a client component, right? So there are some guidelines which we could use to define which components should be a server one and which one should be client. So for server components, if you are doing any kind of data fetching, then it makes sense to use it as a server component, right? It could be your database or any API calls. So for that, it makes sense. For SEO critical pages, as we saw, like if your pages need to be SEO friendly, then it makes sense that you go with React Server components. For sensitive operations, right? Because React Server components are rendered on the server, it provides an additional layer of security to you. You cannot accidentally ship your API keys or any sensitive information to the client because it would never be rendered on the client. So it gives you an additional layer of security. one of the most core benefits. If there are some large dependencies which you don't need on the client, you could use it on a server, and it would never be shipped, right? So in our example, if Prisma is just used on the server side, it doesn't need to be included on the client side at all, because client components are not using it. So large dependencies, you can take care, you can make sure that you don't include it in the client components. So when client components could be helpful for interactive UI elements. So still, like if your components need some interactive behavior, right? So for example, a button or a drop down, where you need to immediately pass the feedback to the user. In those cases, it still makes sense to use client components. For real-time features, so if your component is like a stock ticker or a chat kind of interface, it would make sense to use it as a client component. Then if you need access to the browser APIs, so for example, if your component needs to use local storage or geolocation, you can't use it on a server component because the browser APIs would not be available there, right? So if you need access to the browser APIs, no, you cannot use the server component. And if you want to do any kind of transitions or animations kind of libraries, it still needs DOM access. So for those kind of things, it still makes sense to use client components. Right? So what are some of the real world use cases and considerations where the companies who adopted React Server components, what kind of benefits do they get? So we'll be looking at some of the real world use cases. So the first one is Mux. Mux is a video streaming platform. So it allows you the capabilities to do live streams, it provides analytics for your video streaming. So they implemented React Server components, and they wrote a blog about it as well, which you should check out, where they mentioned that their documentation and their marketing side, there was like a 20% reduction in page load time when they moved from client-side rendering to server-side rendering. And due to that, their sales increased, and the experience that was provided to their users was snappy. So that was great. Dexter is a data orchestration platform which allows you to build data pipelines. So for data pipelines, it allows data engineers to make sure that their pipelines are working as expected, the analytics are working. They had a complaint from their developers that their doc site was so slow. So they've even demonstrated it here that initially their docs site used to take like 5 seconds to load. It was on Angular 1, and they rewrote it to Next.js. They used Next.js and used React Server components, and the time went from 5 seconds to like 200 milliseconds. So it was like 20 times improvement for them when they moved from client-side rendering to React Server components, and their build times were also reduced. Formidable is one of the software development agencies which specializes in front-end development. So they also wrote a blog post on how using React Server components saw a 15% increase in user engagement for their websites. All right, but so from a quote from Spider-Man, like with great power comes great responsibility. This is Uncle Ben, which says that with great flexibility also comes great complexity. So we've been looking at the benefits of React Server components, right? But there are some trade-offs, there are some considerations. Like it's not an ideal world, so there will be some trade-offs. So what are some of the considerations that you should take in mind before you adopt React Server components? First is application architecture and data flow. Now, for building your apps, you would need to give it a thought whether the component should be a server rendered or a client rendered. It also affects how the data flows through your application. Like, how would your data flow from your server component to a client component? Because once you are into the client side, once your React tree goes into client component, it cannot go back. So there are some considerations, and you need to consider how the data would flow like in your applications. Performance trade-offs and server load. So because now you are offloading the data fetching responsibilities to the server, obviously there will be a bit of more load on your server. So you also need to take care and make sure that you have sufficient monitoring and more debugging softwares in place so that you could make sure that your application is performing as expected. This is another one, like tooling and ecosystem. Most of the React packages that we use were built with a concept in mind that the React would be client-side rendered. But now as we are moving to server-side rendering, they may not be compatible. There might be some testing libraries that are not compatible. Some of the CSS and JS solutions are not compatible. So any CSS framework which is on runtime, like you would need to make sure that you could replace it with something which is more like a static or CSS components that allows you to render CSS at build time. So like Tailwind could be one of this. So what we can expect from the future of React Server components and how it's going to evolve over time. The ecosystem would grow. So as it's now considered more stable, more and more companies are going to adopt React Server components. So we would definitely see the ecosystem growing and more better packages, more tooling support for server components. Improved developer experience, yes. So the React team is also planning on how to improve the experience of using React Server components. So it could work on how to better stream data from server components to client components. So the developer experience would become better. Cross-platform adoption. Right now, React Server components is just on the web, but for React Native, for desktop applications, I just saw that last month Expo in the React conference they announced universal React Server components for their router. So now React Native is also adopting React Server components. So we would see much more adoption for cross-platform frameworks. And performance optimization, as we mentioned, that React team would work on optimizing how data is being rendered from server side to client side. It would provide more debugging tools for the for the server and client boundaries. So what are we concluding here? So traditionally, when React Server components were not in picture, front end was scoped to just front end, just looking at how the UI would look like, managing the interactivity. But with the advent of React Server components, now front-end developers can take on the task, like as we saw in the example, like traditional tasks like data fetching, which are generally associated with backend. Front-end developers can do that. So this is a new technology. Let's embrace this technology and make sure that we use the best out of it. Right? Thank you.
Keep it going, keep it going. Yes? Can we have one more huge round of applause for Nurul Sandrani? Yes. So coming to our next speaker. So our next speaker is an innovative builder and a perfectionist by nature. He spends countless hours to meticulously improve even the smallest of things. Is there anyone here who can relate to and who actually spends so many hours to improve even the smallest of things and make it perfect? Does anyone? I see one hand there. Nice. Okay. So our next speaker is from Razorpay, and he's also creator of Slanted, and he has many open source projects like Untab, Blaze, Diode. Any of you have used these projects? Yes, I can see a couple of hands. Great. And so in the last talk, we actually learned how you can use the RSEs and improve your code on the server by moving the logic on the server. In this talk, how many of you actually think that we really need to run the code on the cloud to actually render the UI when using the React Server components? Okay. How many of you have actually used React Server components? And from the last talk, how many of you are actually inspired to use React Server components to actually split the code and, efficiently take the advantage of RSEs to improve the applications? Okay, awesome. So in this talk, our next speaker is going to break the myth that you don't really need to move render the code on the server to actually render the UI. You don't need to have the code on the server. So he's going to break this myth. So let's welcome our next speaker, Akash Hamirwasia. Let's have a huge round of applause.
Which is fine.
Set it up. How many of you, okay, let's talk about this, okay. I have been speaker at a couple of conferences, and I have also faced technical glitches at most of the conferences. How many of you have actually faced technical glitches? Very less. I think some, if there are people who have actually spoken at conferences and not raising their hands, I'm pretty sure they are lying. Because I cannot believe it that if you have spoken at conferences and you have not faced even a single technical glitch. These are computers, like, it's expected to have a technical glitch. So let's
just use this.
set it up. Yeah?
Yeah.
Okay, all set. Let's go. All the best.
So everyone's a full stack dev by now. 2 talks in, and we know everything about React Server Components. Not really. So my talk is centered around React Server Components, and the agenda of this talk is to explain React Server Components from the perspective of static sites. We have built static sites in the past, but React Server Components has been introduced, and we can't really relate where React Server Components fit in the static sites model. So by the end of this talk, hopefully I'll break some myths, misconceptions about what React Server Components are, and eventually together grow a better understanding of what this new technology is. My name is Akash Amirwasya. I work as a software engineer at Razorpay. I love building products on the web. My latest product is slanted.app. It's a video creation tool to create stunning-looking product videos from simple screen recordings. You can follow me on Twitter, GitHub, and I also have a website. So how many of you remember static sites? Okay, I can see a lot of hands, that's good. So a lot of popular sites use static sites. Most of the documentation sites for React, for Vue, they are built on static sites. Some unpopular sites, like my personal website, is also built on static sites. If you don't really recall what static sites are, well, you start with source code, something like this, a framework like Gatsby or Next.js. You create your components for each of the pages. You use some fancy styling library like Tailwind. You use state-of-the-art programming language like TypeScript. And you build your source code to produce HTML, CSS, and JavaScript that the browser understands. And then you upload it on a file server. Now what happens is, when a client comes to your file server and requests for your website, your file server simply returns all the files that it has about your website, the HTML, the CSS, the JavaScript. Let's say another client comes in. That client also receives the same set of files. So in a way, the client 1 and the client 2 is seeing the same website because the files are the same for both of them. Now let's say a different kind of client comes in, which is a web crawler. Well, it can't really understand JavaScript, right? So it will only request the HTML and CSS file to get a sense of what the content of your site is to perform its search rankings. Now what's interesting in this is that this file server is not really a smart server. You can think of it as like a disk whose job is to simply return the files it was requested for. It does not know how to generate those HTML, CSS, or JavaScript files. It just knows that I have these files. If someone asks for it, I'll return it to them. Now, this is fine, but most of our sites usually have some dynamic content as well, right? Take my personal site, for example. I have a blog section where I write some technical blogs, and most of these blogs come from a third-party CMS service that I'm using. How do I fetch this dynamic data from that third-party source? So that's the question. How do we show dynamic data on a static site UI? Well, we can simply use APIs and fetch, right? That's what we have been doing since the dawn of fetch. So this is what the code looks like. I'm sure we have seen this multiple times, and we have written this thousands of times, I guess. So we insert a simple use effect, call the API, set the state, and our postcard show as we expect it to. Now let's try to understand this from a waterfall model. So we have server and client. The server returns the HTML and the JavaScript to the client. And the client realizes that, OK, there's a use effect hook which calls an API. So it makes the fetch request to the server, fetches the blog post. And once the blog post is received, it again runs the JavaScript and renders all your blog posts on the UI. Now, the problem with this setup is that it provides a poor initial performance and poor user experience. The user sees a spinning loading page, and after some time, the posts come in. Imagine what if you open a documentation site and the docs actually come in after like 10 seconds after you wait. Really bad experience, right? The other downside is that the search engines cannot really crawl the content. Because the main content of our page is actually those posts that are shown, the search engine does not get those juicy content to actually perform its ranking. So it only sees navigation, footer, that's it. Not really a lot of data to get a sense of what your site is. So this is not really a good approach. Can we do something better? Can we fetch data before the UI is sent to the client? Notice the word before UI is sent. So let's try to understand this better. UI rendering in your application is handled by React, right? We write React code, we break our UI into components, and React's job is to take those components, the state, everything, to render that UI. Now what I'm saying is the data fetching should happen before the UI is sent. That means before UI rendering. So how do we do data fetching when the UI rendering happens after data fetching? We have to rely on some other tool. What can we use for it? Oh, we can use frameworks, right? That's what frameworks provide. At least one of the features of frameworks is to perform data fetching. Frameworks like Next.js, Gatsby, even Remix have primitives to allow you to fetch data before the UI is sent to the client. For these respective frameworks, this is how the code looks like. For Next.js, you use a function called getStaticProps. And for Gatsby, you simply expose a special variable called query, which includes the GraphQL query of the data that your component needs. So the blog post component that I had earlier, it can simply be updated to something like this. I can add a getStaticProps function, which fetches the data, parses it to JSON, and simply returns it as a prop that my page can accept and render the post component. Now let's try to see what happens in the waterfall. So during build, the JavaScript is parsed, the data is fetched, and the output artifact is simply HTML and JavaScript files that is pushed on the file server. Now when the client requests for the file, it gets the HTML, JavaScript, and all the static files that are there. And notice how the UI is partially ready as soon as the HTML is received. The client does not really have to wait for the JavaScript to load. The JavaScript loads for hydrating and making your UI interactive. So in a way, the user is getting value just by loading the HTML of your page. So this is great, right? This is exactly what we need. Why am I giving this talk? The problem is these two primitives, and even the primitive exposed by Remix, those are at route level only. So you need to create special pages component, and only in those components you can expose these functions where the data fetching can happen. This sort of setup works fine for the blog posts page that I have, because again, it's a page, I can perform data fetching over there itself. Let's try to take a bit more of a complex example. Say I have this simple component which shows all the GitHub sponsors I have, and I use this component throughout my website. I show it on my projects page, I show it on the blog post as well. So how can I use this component throughout my website and ensure that the data is still passed to it from GitHub, which is again a dynamic data? This is what the component looks like. Really simple, takes a single prop, which is sponsors, and it renders that in the JSX markup. Now let's say I update the projects page to include this component. And notice how I have to put my data fetching logic inside the getStaticProps function. And this code, the data fetching code that I've written, is already mixed with the other data fetching logic that I might have for this page. So for the projects page, I might be reading a YAML file or calling another GitHub API to get all the projects, and then I have to fetch for the sponsors and ensure everything is returned from that single function so that my page gets all the data it needs. Now let's say I want to render the same component in the blog post page. So this is the blog post page. I can move the JSX itself inside the blog post, but that's not it. I also have to remember to copy the fetch function from the getStaticProps method and paste it in my blog post page. So notice how I need to remember two things. One is the JSX component itself. I need to copy and paste that. And then I have to remember, OK, this needs the data. So I need to get that data also from getStaticProps. So I need to copy paste that code as well. And everything is cluttered in that single getStaticProps. You have things happening. You might be calling ChatGPT or doing fancy stuff. Everything is cluttered in that one single function that is exposed. Can we do better? How many of you know Gatsby? People are still using Gatsby? No, everyone's hands went down. Okay, so the thing is, Gatsby actually had a really smart solution for this. It introduced this smart hook called use static query. And what this hook allowed you to do was perform component level static data fetching. So let's say this is the GitHub sponsor component that I have. Instead of expecting the consumer to pass in that sponsor's data, the component itself can use this use static query hook and write the GraphQL query that it wants. So in this case, I'll be fetching all the GitHub sponsors data within the component itself. I don't expect the client, the consumer to pass it. This use static query will ensure that when your site builds or when the component is rendered, the data will be there for your component to actually render. And notice how the usage of this component becomes in those pages. The projects page, simple JSX. Even in the blog post page, simple JSX. One single component, I can copy, paste, and move around wherever I want. I don't have to think about the data it needs. This looks perfect, right? This is what we need. Well, let's try to, again, take a step back and see what exactly use static query offers and what are the limitations. Well, we just saw that it performs component-level data fetching, and it allows you to co-locate the data fetching logic and the UI in a single component. So your data and the UI stays together, and whenever your component is rendered at some other place, the consumer doesn't have to worry about passing data or doing any of that stuff. So it has a couple of limitations as well. One is that it cannot accept variables. Let's say the GitHub sponsors component I wrote, instead of it fetching sponsors only for me, it also took a username prop and actually fetched the sponsors for that particular user inside that component. I can't really do that because username is a prop, right? And if I pass that in my query, the query is no longer static. It is dynamic because it depends on that username prop. So this is a very quirky limitation. But there's another quirkier limitation, which is there can be only one occurrence of the hook in a file. If the rules of hooks were not enough, this makes it even worse. So you can have one use static query hook in one file, and if you want to use it multiple times, split the file and split the hook into multiple files and then compose everything together. Now, the thing is, if you take a look at these limitations, it's because of the fact that Gatsby performed data fetching by static analysis of your code itself. So it went through your code, it found the use static query hook in all the files, and it performed the data fetching based on that. It did not really have the context of the components that are there, which component gets rendered when, what are the props that are passed. Can we do any better now? The static site community has been building for this for years. Use static query was the best solution that was there for the time. But we can't really go ahead, right? Frameworks don't have the context of what your components are, what the props are. What if React itself handled data fetching before rendering the UI? After all, React knows what the components are, what are the props, which component shows when, etc. So if it handles data fetching, it should solve our problem, right? Can we use React server components? You might be thinking, yeah, that's what the talk is about, right? But wait. If it's React server components, how can I use it in a static site? I'll need server to run the React server component. After all, it's in the name, right? Do static sites not have a server? Think again. When you're building your static site, there is a server running, right? How is it able to build your static site? So I was going down this rabbit hole, and it made me wonder, what exactly is a server in the first place? In the context of React server components, it's actually just a computer that is not the client. To understand this better, let's try to take a look at the waterfall again. So this is the static site waterfall. We build the site, we push the HTML, JavaScript to the server, and the client simply requests those files. Now let's modify this for an on-demand server-rendered UI and see how things change. So this is the waterfall for static site. And this is how it looks like for server-rendered site. If you noticed, the build and the server just collapsed into one, which is simply the server now. The client sends the request. The server's job is not just to serve the files, but also to generate those files by actually fetch the data, rendering your UI, and streaming the output to the client. So what is the takeaway from this? Static site is simply a frozen snapshot of a server-rendered client, server-rendered site. If React server components can be used in a server-rendered site, they can also be used in a static site. Because again, as I mentioned, static site is a frozen snapshot of your server-rendered site. If your client is sending requests and the server is generating outputs for every single request, if you take that one output and put it in a file server, that becomes a static site. So with React server components, this GitHub sponsors component that I had, it looks something like this. So simple fetch call, the component has become async. That's something important to note. And I can write my asynchronous logic here itself, and the data that the component needs is again encapsulated in the component code. Nice. I can also pass a prop, which is username in this case. And because this is in React land, I can call the fetch GitHub sponsors function with that prop. So I don't have the limitation of a static query, one hook per file, all that fancy stuff. I can just write asynchronous code as much as I want. And this is how the usage looks like. I can have multiple occurrences of the same component in a file. I can use it like any other component. I can pass different username. The first instance is my username. The second one is Anthony Fu, a really awesome creator in the open source community. This looks fine on paper. I'm sure you will be thinking, that guy is lying. I don't think so. He's saying the truth. So React server components is server rendered site. Show me the output. Well, I do have the output. Can you make sense of this? This is the minified output after you build your site with the GitHub sponsors component that I showed. If you notice, there are two parts in this output which translates to the component that I defined. The first section is my GitHub sponsors card. The second one is Anthony Fu's GitHub card. It has the data from the GitHub API. It's showing the images of my sponsors. It's showing the number of sponsors I have. React has performed data fetching and has frozen the state of your UI in this single output file. What's interesting is that this entire process or this entire system is not really just limited to data fetching. Once you start using React server components, you can do any sort of build time processing that we don't want the client to do. Now, this is really interesting, right? Because static sites, when you were building, if you wanted to configure the build time itself, you had to dive into framework config files. Things like Gatsby config.js, modify its GraphQL source, or in Next.js, fiddle around with that get static props, drill down the props, all that stuff. But because we are using React server components, we can do any sort of build time processing inside React land. An example of this is code highlighting with Shiki. So in most of the personal sites or blogs, we have code blogs that are shown. And Shiki is one of the popular and accurate libraries to get high-quality syntax highlighting with text-mate grammar, which is supported by VS Code. You can also use your favorite VS Code themes as well. But the downside is this library is sort of heavy to use. If you're shipping this to the client just to render those code blocks, that's actually a huge waste of resources. Even Shiki recommends that you use this library as a build time tool. With React server components, I can write a code block server component. I can get the Shiki highlighter over here. I can create the syntax highlighted HTML and pass it down to my markup over here. React server components will ensure that only the things that are rendered on the UI is actually a part of your bundle. You won't notice Shiki itself in the bundle. You won't notice any other data that is not part of your actual JSX that is shown. This is how the output looks like. Really fancy colors, chef's kiss, right? Finally, let's look at the advantages of React server components in static sites. One that we saw is component-level data fetching. This is why we started the discussion in the first place. Second is co-location of data fetching and UI in a single component. The component is self-aware that it needs this data. It needs these operations. You can do everything in the component and use that component anywhere you want. You can also have dynamic queries. When we were using useStaticQuery, you had to use the useStaticQuery hook, which has to be static query, all that fancy limitations. But with React server components, it just works. You can use any props, any variables, any operation to perform your queries. It's not limited to data fetching alone. You can do any build-time processing. If you're calling ChatGPT, you don't want to do that on the client. You want to do it while building. You can do that inside the server component. Now, this is a really interesting advantage. Just go through this, the last one. So theoretically, if your entire static site is built only with React Server components, you wouldn't require any client-side JS at all. All your interactivity is in client components, and that is where JavaScript is needed. But since you're using only server components, you don't need any client-side JS and no hydration at all. I say this theoretically because most frameworks won't actually do this. They will still bundle some JavaScript to make the user experience better. The last advantage is this whole system is portable to any other React framework that supports React Server components. As React devs, we like switching frameworks every other day. So it's important that we make minimal changes throughout our transition. And if your site uses React Server components and you move that source to another framework, you don't have to worry about data fetching and moving that logic. React Server components works the same in every other framework. Now you might be wondering, really good stuff, right? How can I use React Server components for my static site? Well, I'm glad to announce that on this stage, I'm announcing my own first JavaScript. Nah, it's just Next.js. Just use Next.js. So it's interesting how you can opt into static site rendering really easily with Next.js. You just have to change one line in the next config. Output, export. That's it. Don't ask me what it does. It does what I expect it to do. So it will actually just freeze everything into static files, and you can just host it on any server. Even Next.js recommends that you start as a static site and opt into server-side features as and when you need them. I'm not just saying this, it's actually in the docs, you can read it. So start as a static site if you need features like middlewares, things that are on the server, headers, cookie function, all those things, once you use them, then you can become a server-rendered application. Hopefully this makes sense to you by now. Finally, I would like to leave 2 references. If you're more interested to understand React Server components, these are amazing 2 resources that I've found. The first one is a blog article by Josh, Making Sense of React Server Components. The second one is a talk by the legend himself, Dan, called React for 2 Computers. That brings me to the end of this talk. Thank you for listening. You can connect with me on my Twitter and check out my website.
Keep it going, folks. Let's give a huge round of applause for Akash Amirwasya. I can still see that the people at the back are not really participating, which is not good. I would like to say that it takes a lot of courage and adds on a lot of pressure to come on the stage and speak in front of such a huge audience. So let's appreciate the effort. Let's respect the speakers and appreciate the effort. Let's give them a huge round of applause again. Yes? And I want this energy till the end of the conference. Because it's you folks, it's the audience which brings in the energy for the people who are on the stage, right? So it's on you how we take the conference, right? So keep up the energy high till the end of the conference. So thank you, Akash, once again. And I would like to appreciate that I was just checking out the projects of open source projects by Akash, and the velocity at which he has been pushing the projects, it makes me feel like that he has a side project almost every weekend, which is crazy. So I really appreciate the open source efforts Akash has been doing. So let's give him one more huge round of applause. Yeah? Okay. One request, please don't use the front door. It's actually distracting the speakers. So if you want to move out, please use the back door instead. So coming back to the next speaker, the last speaker before the first break of the event. So our next speaker is again a travel freak like Nurul. And she's from the Coro R&D team. She will be diving into Coro and how you can build secure React apps and also elevate your development experience. Now, I was just checking out yesterday the product Coro, and I came across this awesome line which really attracted my attention. Stop building platforms and just start adding developers. This makes a lot of sense. Like, let's not build platforms for every single thing and, let the developers handle it. So I'll not reveal the talk. Let's welcome our next speaker, and let's have a huge round of applause for our next speaker, Stephanie Fernando.
Hi all. Hope you all can hear me at the back. Yeah. Today I'll be talking about building secure React apps with Coro internal developer platform. Now, on our agenda today, so we will first see at a high level what is Coro, and then we will see some of the security challenges that we face in single-page applications, and then we'll see how Coro's managed authentication feature can help you to build authentication into your React single-page applications easily, and we'll finally see a live demo on how you can do this. So now to start with, when it comes to taking your React applications to production, there's a whole lot of complexities that we need to think about beyond our code itself. So for an example, how are we going to scale our application in the production environment? Then the CI/CD pipeline, security, monitoring and observability, insights, and so on. So what we normally do is, now we have different tools and platforms which provide services in these areas. So if I want to have a CI/CD pipeline for my application, so I'll evaluate few different tools and choose the best tool that suits my use case. So similarly, if I want to enable monitoring and observability, I'll do the same, and it goes on like that. But wouldn't it be much easier if you have all these things that you need to take your application to production under one platform? So that is where Coro comes in. Coro is an internal developer platform that simplifies the deployment, monitoring, and management of your cloud-native applications, allowing you to focus on what is more important, which is coding and innovating. With Coro, you can simplify tedious and time-consuming workflows and get your applications to production faster. So the diagram that I have over here pretty much gives the high-level idea what Coro does. So we as developers can write our application in whatever the language that we prefer, using our familiar IDEs and tools, and then push our source code to the repository and plug it into Coro. So Coro will take it from there. With Coro, you can build, deploy, test, manage, and observe your application. So that's right. That's the whole software development lifecycle under one platform. So now that you have an idea at a high level, what is Coro, let me take you to Coro console to explore a bit around to see what it is like. Now, so I'm currently in Coro console. I'm in my hotel reservation project. So what is a project in Coro? So a project is basically a grouping of one or more components. And I have 2 components already created under my project, so which I will be using for the demo in the latter part of this talk. So I have 2 applications here. One is my hotel reservation service, which is a backend application written using Node.js, and then I have my hotel reservation front-end application in React. So let me just show you how easily you can plug in your code and create a component in Coro. So I'll click on the create button over here. So I have a bunch of component types here, which don't need to worry at this moment. So we'll just talk about services and web applications, since that is what we use the most. So services are mainly, the microservices such as, REST APIs, GraphQL APIs, gRPC, and so on. And then we have the web applications, so basically our React applications, static applications, and so on. So I'll click on web application. And then I have a bunch of fields to fill here, so I can give my component a name. So I'll just quickly give a name, and then, so I have two options here. So I said earlier that you can connect your code to Choreo. So if you already have a source code in hand, you can connect your repository to Choreo. Or else, if you just want to try things out, you can go ahead with our samples repository. So for this demo, I'll just try it with the samples repository. And then we can choose the build pack. So since I'm going to create a React application, I'll choose my React build pack. Now, having a build pack takes a burden out of our heads as developers. Because, we don't have to worry about how we're going to build our application or how we are going to create the image from our source code. So that will be handled by the build pack. And then I'll choose my project directory. So the samples repo that we have is actually a mono repository with many projects. So I'll search for my hotel reservation front-end project and click on continue. And then I can give my build command and the build path, and then give the node version. So, and then simply create. So this will create a application for you. But I won't create it now because I already have my application created. So let me go back to my project overview and back to our slides. So so from the different features that Choreo offers, I'll be talking a bit about one of the features that makes it easier for you to implement authentication in your single-page applications. So React single-page applications are a common use case, but there are certain challenges that we face when building single-page applications. And security is one such main challenge. And this is mainly because, in single-page applications, we have the source code fully running on browser side. So when it comes to handling authentication and working with tokens, it becomes pretty much difficult because our code is vulnerable to attacks such as XSS and CSRF attacks. And nowadays we use protocols like auth and OpenID Connect widely to implement these additional security measures to our single-page applications. And how we normally do is, the React ecosystem supports different SDKs and libraries that we can use to simplify our implementation. Like, we don't have to implement it all by manually. But Choreo has a perfect solution which makes it much easier for us as developers. So with Choreo's managed authentication feature, it provides a secure backend for your single-page applications to handle access tokens. Now, this is more like a token handling proxy sitting in between your front-end application and the back-end application, so which is one of the recommended solutions for these security challenges in single-page applications, and it is really easy to integrate with your React applications. So let's see a demo on how you can do this. So I'm back in Choreo console. So I already have this. This is my backend application. So I'll go to the deploy page. So as you can see, I already have my application deployed and running in both my development and production environments. So I'll switch to my front-end application. So now here in my front-end application, which is my React application, I have two branches in my repository. One has the incomplete code without the authentication logic implemented, and then I have the completed code in the other branch. So I'll just show you first how my incomplete code without the authentication works. So over here, I'll quickly go to the build page. So I have triggered a build from one of my commits. So I just have one commit in this branch. So I have triggered a build out of that, which will create a Docker image, which I have already deployed. So I'll click on the web app URL over here. And let's see. OK, so it loaded. And let's try. So when I click on the search button, ideally it should try to communicate with my backend application that I had and list the set of rooms that are available. So as expected, it doesn't work. it returns a 401 because I have not handled authentication or I haven't passed any access tokens when invoking my backend. So now I'll switch, actually I'll switch the deployment track. So what is a deployment track? So in Choreo, we can create deployment tracks out of the branches that we have in our repository. So in my completed app branch, I have the working application. So before showing you how it works, now let me show you what are the code changes that I have done in order to implement the authentication logic. So I have the code changes over here in this PR. So it looks like a bit of a big PR. But let me quickly go to the slides and explain you what are these codes. So obviously, when implementing authentication, you need to have a login button. And then, so I have changed my getting started button to sign in. And I am redirecting the users to /login. So with this, Choreo will redirect the users to the configured identity provider and handle the authentication there. And then we need to manage the post sign-in functionality. So though I have a big code chunk here, what is actually important is these two lines, because with Choreo managed authentication, it establishes a cookie, a user info cookie, which have all the encoded user information, which you can use. And how you use this information is up to you as the developer. And then we have the logout functionality. So where when I click on the logout button, it will remove the user info session from the session storage and then redirect the users to auth logout URL. So now let me quickly so we are in our completed application branch. So I'll click on this authentication settings. Now I'm going to enable authentication with this toggle. Now here, by default, Choreo will configure Choreo built-in IDP for your applications, but you always have the flexibility to add any external IDPs from the settings page. And you can configure the post login and logout path. So in my application, it's the root path. And then I'll create a test user because we need to try out the login. So this is just a test user. You can always connect your users using a user store file. So I'll copy this password and click on deploy and wait for our application to get deployed. So it's in progress. So let's wait a few seconds until it becomes active and try out our application again. So yeah, my application is loaded. I have the sign in button here. So I got the login. I'll give the username and copy the password. So yeah, I'm in my page. So let me check whether search works now. Yeah, so it does. So that's how easily you can implement authentication into your single page applications with just a few code lines and some button clicks. So as you saw in this talk, you can implement authentication easily into your React single page applications with Choreo, and you don't have to worry about handling tokens in your application code or passing the token implicitly to your backends. So Choreo offers you a lot of features that elevate your development experience. So I encourage you all to try out Choreo and experience how it can elevate your React development experience. So if you have any questions or would like to know about Choreo, head out to our booth. And thank you for listening.
So that was an amazing talk by Stephanie. Again, can we have a huge round of applause, please? Yeah? I really need you people to, bump up your energy. And we have a break. We are going to have a short break now. Go out, keep yourself hydrated, have some coffee, bump up your energy, and then come back to the event and show the. We want to increase the energy to this bar. Right now, it is actually at this. We want to take it up to this level, okay? And after the break, come back in 20 minutes. I think it's now 11:15. So let's meet at 11:35. We have an interesting stand-up comedy by Cheyenne, which you definitely don't want to miss. So please come back and join us in next 20 minutes. Thank you all. Also, I request to do the technical checks for the speakers who have the talks in the next slot starting at 11:30. So please make sure you do the tech checks.
Fine. I can't. Okay, now I can.
It's not working. Okay, people are coming in.
दीदी वो उसमें गलत लिखा है तो इवनिंग में था ना इवनिंग को तो चेंज करो ना
अभी
स्लाइड नहीं है इमेज है
हटा दो then. हटा दो. The way we want to get the order. We can't wait for last time आप थे ना पता है ना नहीं आते. Can we actually close those gates because we are about to start? Let's not keep it open. It will be a distraction for the people. Yeah.
के वायर्स, ठीक है, IoT के चक्कर में। बट काम आ सकता है because it's very last minute.
I am really curious to know who is actually ringing the bell. Is this a signal for the audience to get in because we are about to start? Looks like this is a signal, but yeah, it's an interesting signal. It really catches the attention. Okay, so I hope you all had a nice networking session outside, had a nice coffee break, and you all are hydrated now. Can I get some response from you? Yeah? Some more? How are you feeling now? How is the energy now? Awesome. So we have a really interesting stand-up comedy by Cheyenne. I actually met Cheyenne in one of the FOSS meetups in Bangalore. He actually has his own home lab. I have seen him doing tech talks, but this is the first time I'll be seeing him do a stand-up comedy on stage. So let's give a huge round of applause to our next performer, Cheyenne.
Hey, I'm Cheyenne. Every time I announce my name, people are like, what? Shyam? Shyam? No, I'm Cheyenne, okay, Cheyenne. People are like, what does it mean? Like, so this happened to me when I was pitching my first startup idea. Okay, I went to this head of a certain institution and I'm like, I've got this amazing startup idea, okay, I'm going to revolutionize your institution. He's looking at the floor, he's looking at the ceiling, he's looking at my ID card. He's like, your name, what is the meaning of that one? I'm like, sir, no, I don't know, sir, this is my startup idea, sir, look, sir. He's like, you know the meaning of your name? I'm like, no, I actually don't know, because not a lot of people have told me that. I'm just like, probably a Bengali name, no? Let it be. Nice. He's like, I will tell you the meaning of your name. Cheyenne means someone who sleeps a lot. Like, okay, fine, but sir, startup, sir, funding I need. Like, your name is someone who sleeps a lot, then how am I supposed to trust you with giving you my money and funding you? That is when I realized I should just be called Shyam. Okay? Anytime people ask me, what Shyam? I'm like, Shyam, that only. But yeah, so I applied to React Nexus, and they reached out to me. They're like, do you want to get a chance to be on stage? I'm like, yes, let's do this. They're like, no, but you won't be in any of the speaker schedule and all, but you will be on stage. Like, what is going on? So, I've done a lot of tech talks before, okay? And what I've realized is, after my decades of research, all of the tinkering that I went through, all of the effort I put into the tech talks, the live demos, practicing my slides, you know what these people learned from that? They're like, they looked at all of that, they're like, this fellow, little bit funny, you know? Like, bro, I am disappointed, okay? I am thoroughly disappointed. I am as disappointed as RCB fans on a Tuesday. And it's not even match Tuesday. This is like regular Tuesday, okay? Monday, Tuesday, any day really. But I'm like, fine, take it, it's fine, I'll do it. So, I haven't done a tech stand-up before, okay? I was confused. I went to a few of my friends. I'm like, guys, this is a React meetup where I'm doing a stand-up. Like, what am I supposed to talk about? Like, please help me. One of them is like, Arey, it's a React meetup now. You know what you should do? You should go up on stage and tell bad tech jokes. I'm like, okay. He's like, listen, I'll tell you. He's like, you should go up on stage and you should be like, what is the best way to comfort a JS developer? You console them. God, I did not think that would get so much laughter, bro. Okay, Shubham, if you're watching this, there, I said your bad tech pun. You owe me a donut. And please clear my Spitwise also, no? Okay, so I asked another guy, a second opinion. I'm like, tech stand-up, what do I do? He's like, oh, you know what you should do? He says it with so much intensity. Okay, I listen to him with like full confidence, like he's about to reveal the Bible to me or something. I grab a pen and paper. I'm like, what are you going to say? What are you going to say? Like he's going to reveal like who Jon Snow's father is. Like he had that much intensity. He's like, go there and present your rejected CFP. I'm like, bro, this man has so much revenge in him. Itna revenge kahan se? Like, if this isn't like a Bible revelation, this is Satan handing him the Bible. Like, bro, you take it, you need it more than I do. This man is Ramsey Bolton level revenge. And the weirdest part is, he is not even the one getting rejected. Like, I am the one getting rejected. Okay, I'm getting rejected. I'm like just like, oh, rejection. Ta-ta-ra-ta-ra. He's like, finish the mannequin. I'm like, chill, bro, chill. Yeah, okay. So instead of taking bad advice, you know what? Let's take bad advice. I have my laptop here. I think I'll present something about React server components. Should be nice, no? No, it's fine. So instead of taking bad advice, what I'll do is I'm just going to talk about something that all of us can relate to. I am going to talk about moving to this city, Bangalore. How many of you moved here from Bangalore? Anyone? Nobody? Oh, all of you are from Bangalore. Oh, how many of you have lived in Bangalore? Nobody, huh? Where are you living? Huh? Delhi. Where is the talk happening? Huh, a lot of you, okay. What do you like about Bangalore? What do you like about Bangalore? Traffic, wow, dude, this man is just like, damn, I like the hard stuff. You're the one who looks at Jira tasks and picks the hardest one. You're like, हाँ, यही करेंगे. What about you? What do you like about Bangalore? Weather, oh, okay, fancy. So, I've heard that people really like shopping in Bangalore. Like not like Myntra and all, like physical shopping. Do you guys know like any great places to like physically shop? UB City. Okay. Wow, this man is just casually walking in on a Tuesday. He's like, huh, Louis Vuitton. I'll have that one. Rolex. You have like little more expensive one. Like Rolex is little cheap, no? UB City, it seems. Any better ideas? Chickpete. Oh, good stuff. I also like Chickpete, Majestic, very nice. So in these places, right? So I took recommendations like this. Chickpete, Majestic. People also said like Church Street, KR Market. Wow. Okay. So in these places, okay, I was like, wow, like really nice places. I'm writing these down. Little did I know, you will get all extremes of quality here. Like both extremes, and both extremes of originality as well. So I went to this Church Street, I believe. How many of you have been to Church Street? Oh, okay, fancy. Not for the reasons I went to, I believe. I went there to buy new shoes, okay? Why did you go there? I know. She's laughing already. She's like, I know what I went there. Yeah, but I went there to buy new shoes, okay? And not like fancy shoes, okay? Not like Sparks and all. Sparks and all. It's like, okay. Like I want my previous pair of Adidas had just worn out. And I was like, let me get a really good pair. Like I wanted to splurge again. Okay. They're like, go to Church Street, bro. Very good stuff. I went there. So I found this really nice shop there, okay? So I landed my eyes on this really beautiful pair of Nikes. I could feel like my heart urging to splurge over there. My wallet was quivering already. My bank balance is like empty, but it's still like, bro, please save me. I picked it up. I asked him, Bhaiya, ye original hai kya? He's like, nahi, first copy. I have second copy also. Like, I want original. He's like, no, don't take first copy. He removes the first copy from my hand. He gives me second copy. I look at it a little closer. Nitke. I'm like, bro, what? Then I look below, okay, the entire shelf. Adidas, Adivas, Pune, Apple. Apple, what is Apple doing in a shoe shop? That too in like what, Brigade Road, or was it Church Street or something? I don't know, okay, I honestly don't know. That one circle, like Brigade Road, MG Road, Church Street, that area is like, it's like pinpointing Kare Park in Sambar. Okay? Like you know that you're in one of those areas, but you can't really pinpoint like which of those streets you're in. It's such a mess. God. Yeah, like there was Apple over there. I don't know what Apple is doing there in Church Street. Timmy Hilfiger. Like, God, who is coming up with these? Oh, God. And so I was going to be like, whatever they're having when they come up with that, I want it. Okay, because that's the good stuff. But no, I don't think humans are coming up with these. Like, I don't know what it is, okay? So I am convinced there is just one guy sitting in these factories. His whole job is backspace a letter, wait for a cat to just like plop over it like this. Something will type up over there, autocorrect will fix it to something else. Pune. Adigas. Where are you getting this from? Damn. That cat is going to become very rich. You just plop up some random strings and they're just like, 1800, madam. Last 1600. 1600 it seems. So, how many of you have experienced haggling with Bangalore shopkeepers? How many of you have done that? Okay. How much percentage have you gotten down to? 20%, right? Bangalore shopkeepers, like, they won't bargain much. Oh, your mom, then 20%. If we guys go, no. Oh, your mom, 50%. Yeah, they have a way of doing it. I don't know how it is. 20%. 70%. You only did or your mom did? Oh, okay. Okay. He's Marwadi. He knows. He's like, भैया मैं खरीदता हूँ, ठीक है, मुझे बता रहा हूँ 70% markup. Yeah, it's tough, okay? Like, unless you have your mom there to do it, like, it's really tough. I try bargaining with one of these people. These guys are like, sir, 1800, last 1600. I'm like, bhaiya, 1400 little. Like, no, sir. The blackmail, dude, the emotional blackmail that they start you with, no. It's like one of those desi moms trying to blackmail their daughter out of caste marriage. They're just like, बच्चों का सोचिए सर, हमको कुछ खाना का नहीं मिलता है. I'm like, bro, I just asked for 200 rupees less. Why are you emotionally blackmailing me like this? They're like, sir, 1400 last, sir, 1600 last, sir. बच्चों को खाना नहीं मिलता, हमको loss होता है, sir. I'm like, bro, chill. I've seen it on Amazon for like, 400 rupees, okay? What is this? But here's the thing. You can spend 20 minutes trying to bring it down like 20%, they won't budge. The moment you step away, okay, they're like, sir, 1600, sir, 1600, sir, 800, last, 800. Suddenly, they were just like bungee jumped off of it. Like, where did this come from? If you could have done 800 before only, you're emotionally blackmailing me for 1400. Wow. And so here's the thing, okay? The moment they've done their final price, when you like slowly step behind, they don't budge after that. Like, they're so persistent. They're already putting it in the cover. They're like, scanner that side. I'm like, I didn't want it. I was just looking, okay? The first thing I looked on, I just asked the price. This guy is like putting it in cover. He's giving it to me. One hand he's holding cover like this. One hand he's pointing at scanner. And I'm socially awkward, okay? I'm very socially awkward. I don't know what to do. I'm so nervous, okay? I don't want to say no to him. I have trouble saying no to people. So my one hand is already like scanning it like this. Is like going for scanner. My other hand is like pulling it back. Oh, yeah, but no, I ended up actually paying for 800 bucks for a pair of knit case that I didn't even want. I'm not even wearing it today. Yeah, it's it's intense. Okay, that's all the time we have for today, but I've got a lot more content, so I might come back.
Hello, check. All right, everyone. A round of applause for that amazing performance. All right. Let's change the gears, everyone. How's the Josh? Let's try that again. How's the Josh? We need that. So everyone, after that break, I hope you had some good conversations. How many of you met someone new, which you didn't know before you added them to your professional network? Amazing. A round of applause for each one of them. For each one of you for doing that, right? So it takes a while, it takes a courage to do that, and you have done that. That means, yeah, hopefully, how many of you are already 5 people you have met? The goal which I gave in the beginning. 1 person. Anyone else? Okay. All right. How many of you are 2 plus? 2 plus new people you have met already. Great, amazing. So 3 more to go. Make sure you have conversations about projects and everything. Have a call to action. That would be my number 1 suggestion. All right, so we have interesting lineup coming up. And begin with, we have our first speaker who can play badminton and TT from both hands. Can anybody else do that in the audience? You, okay, someone, all right. And when I asked him, like, what do you do when you're not coding? So he just said, I code more. So that's a very true, passionate developer, right? And then I could relate, because in the beginning when I started as a Windows Phone app developer, I think Naman in the beginning mentioned about Nokia phones and the older phones, right? But this is like Windows Phone, Lumia phones. Anyone who used those phones, right? I used to build apps for it, even though our market share was less than 3%, but companies wanted that third platform to be covered. And yeah, so seeing problems around us, what can we solve? And someday, yeah, I got this idea that I should build an app to consolidate all the helplines and everything, like all the critical information is published by all these departments. I should keep them up to date, offline, and all those things. And I published it. I used to reach out to my friends who had a Windows Phone. You should download this and you should review this. And then, but yeah, most of other reviews were genuine. And then that was my first app, right? And since then, the journey has been 7 years as developer relations now. So I think all of you, how many of you were accidental developer? You never planned to be a developer, but it happened to you, okay? I see Sumedha's hand and then everyone else. Okay, that's great. So same happened with me, because for me it was, I wanted to build apps for it because I had that phone, I loved it, and I just wanted to do more than just use it. So if we do something out of passion, and similarly, our next speaker, Vamshi, also does coding with a lot of passion. He also plays badminton and TT with a lot of passion. He has a cute 5-year-old daughter. And everyone, please give a huge round of applause for senior software engineer at Intuit, Vamshi Suram.
Thanks a lot, Yash, for the humble introduction. Hey everyone, how are you guys doing? How is the Josh? Okay, I'll start with what Shayan was speaking earlier. So how many of you haven't seen Chickpet? Okay, so if you are buying an apartment in Bangalore, and if you are married, you'll definitely see Chickpet in your life. Okay, and I was learning car driving that time, and once you park your vehicle in that Maharaja complex or something, there is a parking complex. If you can park your vehicle in that complex, you have learned driving, man. Cool. So into the presentation. So I am a senior software engineer at Intuit. I work on accounting software called QuickBooks. It's a flagship product of Intuit. So in this talk, I want to explain about the different problems faced by front-end people and a solution which I built and open sourced, which can help you big time. So let's go into that. Okay, so I'll start with a basic introduction, like what is GraphQL, how GraphQL React applications look like, and typical front-end problems, right? And what is the approach we have taken to solve it, and how you can use it, take advantage of, and decouple the front-end development you have to do. Okay, and any questions we can take later. Quick check, like how many of you work with GraphQL? Cool. Apollo client. This is for all of you. Okay. Anybody worked with, okay, there is no API or the API is very slow or doesn't work sometimes, missing data and all? Have you faced these situations? Okay, cool. Okay, let's start with a small introduction into like how this application flow will be there. So what is GraphQL? Typically in a REST endpoint, basically we call the endpoint and get the data. Like if you are having a user profile endpoint, no matter what information you want, it will give all the information that it is designed for, right? Now in GraphQL, basically you are requesting a graph, part of the graph of the data. So you query what attributes you need, and then in the response, you basically get that data only. And why is this great? Obviously, like the payload size and the interaction is like minimal. And it is like a progressive API. It can go from 0 to 1, right? Like that. So this is typically called as operation name. Okay. So what are the different systems involved in a typical web application? You have UI, the browser the client interacts with, sorry, the user interacts with, and then there is a backend which will fetch the data from the database and give it back to the UI. Now, one level down, in the browser, you basically, okay, we are in React conference, so let's talk in the context of React application, right? So we have components talking to Apollo client, and Apollo client magically gets the data from the backend. How does this wire-up look like? So if you look at the code, so you mention what is the endpoint, and you create an Apollo client instance, and you pass it to the React application. On the right side, you have the React component. Basically, it is querying the graph, the data that it needs to render, and it is using that. Okay, so in this whole code, do you see like where exactly the data coming in, how the data is actually getting into the application? We don't, because the Apollo client has such a nice abstraction that it removed all of that. But with that, so what is the problem with that? It is such a nice abstraction, but what is the problem? So you will not have the control on data. So Apollo client is like a magic box. You give it takes the query, it will query the backend and gets the response, and your React application will render that data. So why would you need control on the data? So I worked when the React was not there. It was typical MVC architecture. You have controllers, service layers. And we used to have all these methods which will make the API call, get the data. You can tweak that to return mock response. Okay? But coming to the React world and with GraphQL, you don't have all that flexibility. Why do you need that flexibility? First thing, API not ready. So many times I have seen this happen. Like you are working on a new feature development and the backend is working parallelly to the front end. Probably you will have the schema or contract of the API. And also many times when you are working in with the stage servers, right? It's highly likely that there are constant deployments happening on the stage servers and the API may not respond. And the stage servers are also not like a high-end CPU servers, so you will obviously have high latency on the responses. So how do we avoid all these problems and enjoy the front end? Like decouple yourself from the dependencies, all of them, and truly enjoy the fun coding, right? And also, there are some scenarios where you need to, like, many companies nowadays adapt like GraphQL as the backend for front end. What do you mean by that? So you have actual backend, then there is a GraphQL server, and then your UI will be there. So UI will talk to the GraphQL server that will aggregate that information from different endpoints, REST endpoints, and give it back. Now, in these kind of scenarios, what if one server is down? So you will have partial data, like there is some missing chunks of the data. How do you ensure that your application is designed for handling all of this missing data? And how do you, first of all, okay, when you say the application program, the front-end development is done, if you want to demo it, how do you do that? And when you want to raise a pull request, right? Obviously, you cannot have mock data in that and all that stuff. You have to write production code. And how do you ensure that it works? Let's say you mock the data here and there, you put it, and you work with that application, but again, end of the day, you have to remove all that. Now, how can you ensure that the application will work? You have so many floating points, you are adding data here and there are so many floating points. How will you take care of that? The application is still reliable. And this is one very silly thing. Let's say you are working on a delete employee API, delete employee feature. And I work on QuickBooks. So adding an employee to a company in that software, it will involve you have to add profile information, tax information, work location information, pay types, bunch of setup will be there. Now, if you just want to trigger that API and see if the workflow is working, now you have to go through the very expensive resetup, right? So how can you avoid all this? So this is where, obviously, we mock the data, but how can we do that in a scalable manner? How can you decouple that front-end development? So to do that, we have seen that Apollo client is the one getting the data. Now let's see what happens inside that Apollo client. So this is like a magical box getting the data. So what happens? What is this Apollo client? How does it look like? So Apollo client is basically a set of links. Think about this as on the back end you have middleware layers, right? So when a request comes, it will go through some logging, authentication, cookie parsing, and bunch of other stuff, and then the response will come. In the similar manner, think of it like a set of middlewares. So any request from the UI, from the components, they go through all these links. And then there is the last link in the Apollo client is called HTTP link. That is the one which actually makes a call to the backend and returns the response. And then again, the response will go through all the links and come back to the components. So this is like a very high-level overview of what's happening in the Apollo client. Now, how can I solve the problem of mocking the data in a scalable, maintainable manner? So that is the goal. How about replace that HTTP link with a dummy link? Because after all, I want some mock data to come up, right? Mocking the data in the view layer is not good choice because think about the loading experience. Okay, how will you give the loading experience? How will you test it is loading and then it is rendering the data or error? How will you do that? So mocking the data in the view layers is not the correct choice. And also when you undo all the data, it will be unreliable. So the best way to mock the data is near network layer. You go as far as possible from the application near the network layer and return the dummy response. Now there are other frameworks like MSW and other things which can be used as a mock response server. But the problem is there is a lot of overhead. Now to start a server and then you need to understand what is the framework, how is the framework designed, what are the methods, how you need to respond to different status codes, and so many things. There is a lot of overhead. After all, you want just mock the data. But there's a lot of overhead in learning the frameworks. So I was thinking okay, I will remove this HTTP link and then place a dummy link. Any request, it will come. I will intercept and return mock response. Okay, this is good approach. But the problem is the backend is completely disconnected, right? So definitely mocking has become easy. You are doing the mocking completely on the client side. It will be all the mock data is at that single link So it's near network. So you remove the mock data, then your application is like production code only. 1 point maintenance. This is better, but in order to make the now the application, it's not a small thing, right? Like you have bunch of other calls happening. You may be interested only in 1 or 2 calls. Okay, you don't need all the calls to be mocked. And it's a pretty tedious job to mock all the responses also. So this was my initial approach. Now, how can we make this scalable? So a better approach is like, okay, instead of removing that HTTP link completely, how about place the dummy link just before the last one? Now with this approach, basically we intercept the response, the queries which we are interested in, and we return the dummy responses for that. And any response, any query that happens which we are not interested in for the rest of the application, let it go through. So now this approach is more scalable. You don't need to mock all of the stuff. Definitely the complete client-side thing. So you are directly interacting within your JavaScript code only on the front end. Like I said, it's 1 point maintenance. You just need to update that link. And you can work with the actual code, actual calls, and the mocking calls. So this is very scalable. How? I will show you. So the API is very, very simple for working with this. It's completely declarative. So you just need to import the library and inject mock. So you provide me what are the links you have in your Apollo client. Because after all, I need to inject that mock link in that set. What are the queries you are interested in? Okay, so that we can mock only that. The rest of them we can be like transparent, let them go through. And what is a mock data configuration? So earlier I mentioned there is an operation name. So in the mock data you can see like for what operation name, what response you want to give. That's it. So this is the simple configuration, and the libraries I will show you in the next slide. That's very small snippet itself. Now with this, most of the problems are solved. Like no API, solved. High latency, solved. Missing data, solved. Any other, even automation testing, you can actually, like how we have, when we run the React code base, right, local server, there is an environment check that happens and it will inject the dev tools and all that stuff, right? So you can actually add those checks and actually use this internally also, so that your entire server itself can be used, automation tests, you can write all of them. Let me show you a small demo of that. Okay, so here, this is a simple GraphQL React application. So I am injecting the links, and my target operation is country, which is on the right side of the application, if you see here, using mock data. Okay. So the right side component is using the mock data. The left side component is the actual data. So I can show you here. One second. My hotspot got disconnected. 1 second. Okay. So the documentation of the library also has the link to the code sandbox. You can personally try it out. So you see here, actually it is using the mock data, but you saw the application, how it is working. It has the loading experience. So if I reload, so they have loading experience. There is no difference between the real and the mock data component. So if I check GraphQL, So there is only get continents, which is the query made by the left side component. Now, I modify the data. So right now I'm giving an error response. Okay, now I modify the data to send a proper response. See, that's it. So it is using the data that I am injecting. So I can do n number of combinations, like, because this is completely under your control. Okay, so let me detail you like what is happening internally with the mocking library I built. So every link has this kind of structure. So in order to understand how to build this, I had to go through the Apollo client and understand how the links internally work. Essentially, it is like another kind of Apollo HTTP link only. But what do? We look at the operation. You basically see if that operation is mocked and return the mock data. So that is inside a observable. I gave a default timeout of like 2 seconds so that it will, you see the loading experience. Otherwise, it will forward that operation. That's it. Now, this thought process actually started 6 years back, like when there is Apollo link state. So I solved the problem only for myself, and I gave demo of the product without backend, and it went live behind a feature flag. And after 3 months, the backend was ready. And so you look at the pace you can develop the front end. Like with this library, I could push the UI just 3 months before. Okay, so after 4 years, I came to a similar problem, but I saw people are not using this approach. Then I thought, okay, maybe it's time to build it as a proper open source project and share it across. So then this project I open sourced in February last year. So I hope you guys understand the impact it is creating for you in decoupling that front-end development and take full advantage of it. And if you see any issue with that, please kindly reach out, and happy to see any contributions. Yeah, thank you so much for your time. Any questions?
All right. Anyone has any questions? Speak up.
Either you understood completely or like you didn't understand.
It's 1 or 0, right? So, all right, if not now, 1. Okay. So I was just saying that it's a beginner-friendly zone. Don't worry, there's no judgment. And we are all here for learning, right? So don't worry. We do not want you to go home with your questions still unanswered. Yeah.
Yeah, actually, one question is about we have built as a large enterprise kind of an application. But it went on a fast phase where we didn't consider much on the unit testing or something like that. Okay. So in this phase, if I want to, and it is not implemented with GraphQL also. So in this case, how can I able to implement this and get it incrementally applied with a mock test and something like that?
You mean it's not GraphQL? It's a regular
it is not
application.
Implemented via GraphQL.
Sorry?
It is not implemented using the GraphQL. It just used then Axios REST API calls and things like that. So
okay, I'm actually thinking of one approach. Basically, you can hack into the fetch API of browser. I'm planning to build something around that, actually. So maybe using that, you intercept at the network level and then return the responses.
Yeah.
Yeah, I'm thinking about it, actually.
Round of applause for Vamsi. That great talk.
Thank you.
Everyone. So, yeah, I think that was a genuine use case, right? How many of you would be able to utilize that in your projects? Amazing. That's great. So even if you don't have a use case, I would recommend to start those projects, side projects, which you are eventually going to see them die. But it would be good to learn those concepts by implementing those in your side projects, because that would be helpful. So we have an interesting impromptu segment, which is who wants to win some prizes? Can I see some hands? We are going to give away prizes by showing up hands. No? All right, no. So, okay, so this is an interesting. How many of you do not have a GitHub profile? Anyone who does not have a GitHub profile? It's like nobody wants to admit. All right. Everyone has a GitHub profile. Okay, so we are doing something like IPL auction, but not calling it an auction, but something like a developer appreciation, right? And we are doing it in an incremental way, number of repositories you have on GitHub, right? And how it's going to be, incrementally we'll increase the number, and if you are still in that segment till the end, you would get some prizes. Is that clear? All right? All right, how many of you has 1+ repository? 1+ repository on GitHub. Okay, everyone has 1+ repository. 10+, we will cross-check it. On your phones, you need to open your GitHub account, and we'll cross-check. 10+ repositories, all right? 50+ repositories. Who have 50+ repositories? Okay, I still see some hands, amazing. Okay, now things are getting tensed. Let's go 75+ repositories. Okay? Okay, amazing. 100+ repositories. Everyone, can you all stand up? Can you all stand up? 100+ repositories. A round of applause for all these individuals who are not only learning new skills, but also making sure that it's visible. That's great. So everyone, please make sure to connect with them during the breaks. So yeah, you can all sit down. 100+ repositories, right? How many of you have 125+ repositories? 125. Okay. Still we have 1, 2, 3, 4. 1, 2, 3, 4, and 5. Okay, please stand up. All of them. A round of applause for each one of them for getting the prizes. Can I have help from the volunteers? Yeah, all of you get a nice notebook, React Nexus branded notebook, and a pen. That's great, yeah. So others, please, volunteers, if you can just mark yourself and volunteers will reach you. All right, so that is, okay. Anyone else has any interesting project, fun project ideas they would like to talk about? Now is the time for you to showcase yourself that, you are doing something apart from your job. You are learning skills by just doing fun projects. Any fun project, it has to be fun. And people need to laugh, all right? So that has to be the parameter. Anyone has any fun project they have built just for fun? You have a fun project. How many goodies you want? just kidding. I'll come to you. Anyone else has any fun project to share? Anyone else? This is your time to shine, everyone. All right, so the template is your name, where do you work, and what problem you saw. It doesn't have to be actual problem, but yeah. And what is your solution, all right? Talk about the technical aspects. All right, everyone, what's your name? Rahul Kishan. A round of applause for Rahul for taking the spotlight.
Yeah, I'm Rahul Kishan. I'm from Salesforce. And one of the problem I saw was like we use ChatGPT a lot these days, right? And I had used multiple times of ChatGPT on to review PR, to write unit tests, and to send reply to LinkedIn and everything. I had to open a new tab and query in ChatGPT and to send the response. So currently I built a Chrome extension, and that Chrome extension, what it can do is like we can add the prompts and save it. And whenever we need a similar autonomous way, like just select the text, right-click it, and you can choose the prompt. It will automatically call the ChatGPT and give the response in the sidebar. So it doesn't read the web pages. That is the main problem. The main benefit, like the things like Grammarly and all, like reads the web pages, and so it is not secure. So here, I actually don't read the web pages. I don't read the user information, anything. It just opens a sidebar and it opens a website and you can give the response. So it will be just 2 click and it's called as Secure Genie AI. And I just launched it 3 days back in product end. Yeah.
Round of applause for that. That's amazing. All right. Anyone has created a tool to auto-close issues created by junior developers? Just kidding. All right, so everyone, that's the end of the segment. A round of applause for everyone for showing that sport, and everyone who has a 1+ repository on GitHub. Everyone, round of applause for showing that energy. And now we are back to our speakers. So next speaker is also an accidental developer, like me and like many of you. She didn't want to go into banking or any other non-tech role, so she chose, C++, or what was his first programming languages, which was not ideally, I would say, the easiest option, but yes, eventually that helps us to become a developer. And something which happened actually last night when we were doing the tech checks, and one of my fellow MCs was continuously telling me that you have to tell this in Shweta's introduction, that she can make your eyes blind because she uses the light mode in the IDE. All right, just kidding. So with a huge round of applause, please welcome Shweta Tanwar. Can we have those claps louder? Yeah.
Hello, everyone. I hope you all are having a very good time over here. And I'm thrilled to be here at React Nexus, last year as an MC and this time as a speaker. A bit about me. I am currently working as a senior software engineer at Rippling. And in brackets, we are hiring. And I love to travel. I love trekking. I have a deep love for animals. And in free time, I love to doodle as well. These hobbies of mine have helped me explore and get into new opportunities and find solutions to the problems, both in my personal and professional life. So today, I am going to talk about defensive development, a thing which I learned in my career as a mobile application developer, that how to build a robust mobile application, and in doing that, what actually you face through, and will share some of my insights while working on that. In this session, I'll be covering defensive development. What exactly is it? Some overview of React Native and the challenges which is being faced in it, the defensive development strategies, and at the end, we'll conclude. Now to begin with, let's understand what defensive development is. Let's say you are planning for a trek or a hike. So defensive development will be to prepare for all the gears, gather all of them, plan a route, take into consideration what all issues can come into that journey of yours, so that at the end, your journey is successful. That's what defensive development is. And in code, this is writing a piece of code in a way that you're able to anticipate what the problems could arise and preemptively add and manage the solution so that it can be handled very gracefully. Now, why is it essential? Because let's say you are on a trek and you forgot to take the raincoat or the rain gears, and it suddenly started raining. Now what will happen? You're definitely going to get wet, or you'll catch cold. So that's why defensive development is important, so that you can be prepared for the unforeseen situations which can arise. So let's have a brief overview of what React Native is. So this is a framework which allows you to develop mobile applications, that is for Android and iOS, using JavaScript and the React. Some of the key features are that just with a single code base, you can write the code for both Android and iOS. That is, you don't have to learn Kotlin or Swift for iOS, but just with JavaScript and React, you'll be able to make a mobile application and then deploy it to the respective stores. Along with it, the hot reloading feature, that is just write it and immediately you'll be able to see all those changes, makes it very fun and a easy and smooth way to work on it. And the most important, it has a very large community support, and that's why all of you are gathered here today, because you all are part of that community. Despite being so awesome, it still has some of its challenges. They introduced a new architecture, which helped improving the performance, which was arising due to the bridging. But still, apart from that, there are other few issues which we usually face. Some of them are, when you are building a complex UI interaction in a mobile application, a lot of times performance issues might come. Let's say you have a list of, I'll say, 5,000 or 6,000 elements. At that time, this is such a complex UI interaction. Now, scrolling it will make some performance degradation. You'll have to optimize that. Then there are a lot of platform inconsistencies. Something might work in Android and not work in iOS and vice versa. Now, debugging them is a major challenge because you might have checked on one of the emulator or one of the device. Let's say you tested in OnePlus device and it worked fine. Now when you tested in Samsung device, it failed. So debugging those issues is actually a headache because you have to find out where exactly it is coming from. And another one is third-party libraries. We all are dependent on a lot of community-managed libraries. Now a lot of them are updated. So this is a challenge that to find the library which is updated and well-maintained. Now, what can be the impact of these challenges? You can have a negative user experience because for a mobile, everything is your user experience. It should feel smooth. It should feel that, okay, you're actually using a premium app. The scrolls are good, the gestures are good, everything is super smooth. Now there comes defensive development. Now we know that mobile application development, user experience is such important. So how can we ensure that your application is built robust enough to handle all such cases? So we'll talk about the core practices, then we have the testing strategies, and then the CI/CD practices. We can think of them like when we are preparing for a trip, we plan a route, we take into consideration what all things are we requiring. Then come the testing strategies, that is, we test all the gears which we have bought, that whether this thing is working fine or not, this thing is working fine or not. And then, at the end, the CI/CD practices, that is, to make the journey fulfill, you need a planned way to get things done. Then let's say, at 3 o'clock, we'll stop for lunch. At this time, we'll do that. At this time, we'll do that. A proper scheduled way to make it actually successful. To begin with, the core practices. So, having a good code quality is the first line of defense for any good project or any good application, which means writing a well-maintained, clean code, which is properly documented and with proper comments, makes it easier for everyone who is working on it, easy to debug and manage. Plus, making it go through multiple code reviews from your peers or from your seniors gets an extra eye for things which you might have missed while developing and working on it. Now, in order to handle these things, one way we can use is, we can use the pre-built tools, the ESLint or the Prettier, to make at least the code style consistent so that you can easily find and debug what exactly the issue is. Sometimes it's just a semicolon, sometimes it's just a brace, sometimes just a bracket. So at least these tools, the static analysis tools, these things can be integrated firsthand so that at least we'll have a first line of defense covered. Then let's talk about the comprehensive way of error handling. The implementation of the error handling, it should be such that even if something fails, we have a very graceful way of handling it. And even after the crash, our app is still usable, our app is still functional. It's not like that your app closed abruptly. This sort of error handling should be there so that the user, although it might have felt that, okay, a jerk came or an issue came, but you're still able to reuse it. You're still able to perform whatever action you were performing. And at the last, the component isolation. Every component which is being made, it should be responsible to work on its own independently. Plus, there should be no repetition of the code. Make sure to reuse the components as much as you can. Rather than defining the same code in 5 files, why not have it at a single place and use it? So that let's say I have to tweak some logic of that particular function, I can go at that one place and make it work. Then comes the testing part. Now we have got all the gears which we need for to go for a trek or for a hike. We have tents, we have rain gears, we have all the tools which are ready for us. But now we'll have to test them because that is how we'll be sure that all those gears are in proper working condition. And that's what testing is. We have written the code, our code is ready, but you will have to test whether it will actually work in all the circumstances which we might make it go through. Now we'll talk about all of these testing strategies. First is unit testing. Now this is testing all those individual components one by one. That is, I'll check whether this raincoat is properly fine or not. It's not broken or it's not like getting leaked somewhere. Then I'll pick another gear of mine and see whether it is working fine. So individually, I'll take all those gears and will verify whether each of them is working fine or not. Similarly, in our code base, if I'm testing the individual components or the functions, that is what unit testing is. And how do we get that done? Using the tools like Jest or the React Native testing library. So as seen in this image, we have like these single chunk of boxes, which represents that these are the individual components or the functions. Now let's see an example. So in the first example, here's a function where I'm testing that whether this function gives me the expected result. That is, if you add 1 plus 2, it should actually give me 3. And that's what the test does. I also said checking the components as well. So the second one does that. So I have a button. And this button function should expect and should work as expected. That is, if you tap or like if you press on it, it should actually be pressed. It's not like that it is not accessible. So that is unit testing of this component. Now then we have the integration testing. So we bought those gears, like as we said. Now let's see if I combine them, whether they're working fine or not. That is, I want to set up a tent. For a tent, what do all I need? I need poles. I need the combiners to join them, and then I need the sheet. So individually, I tested all of them. The poles are fine, the poles are sturdy, and the connectors, they are fine. Now let's see if combine them, are they like able to work or not? If I combine both of the poles, whether they combine, if I like add the sheet on top of it, whether my tent will actually work or not. So that is integration testing. You combine the parts of the application. So here, those individual chunk boxes, which were in the unit testing, we combine them and see whether they're working fine in that combination or not. And the tools which we use can be Enzyme and the React Native testing library. Now the code could be here. So here, in the first example, I am checking that a component I made. So a component is a mixture of like all the individual components. It can have like a button, it can have like text box, scroll view, multiple components, multiple individual blocks of code. Those have made my component. So in the first case, I'm just verifying and seeing whether that component of mine is actually rendering the way it should, that all the components are actually working in the combination or not. In the second, I'm testing that if I pass some prop to my child component, does it actually get those prop or not? So from the parent component, I passed a prop named John, and I'm verifying whether my child component was able to get that prop. Now at the last, so now we have all the gears bought with us. All of them are working fine in combination. But now we actually have to see whether they'll be able to like make my use case work. And that is, you have to simulate the real world experience. You have to like set it in like, I'll say, outside of your place in the ground and see whether it's is able to like set properly on like the mud or whatever the place is. Or try making food outside to see whether you will be able to make it or not, or what all things you'll require. So this is simulating the real-world experience. That is, testing the complete application workflow. You'll actually test that based on so-and-so scenarios, your component, your lifecycle worked as expected. And the tools could be Detox, Appium. Now the example is, you all know a lot of applications have that user authentication flow. So that could be one thing, where like I'm checking in the first example that if I input a username, if I input a password, and then I press on a login button, the ideal workflow should be your welcome screen should be visible. And that's what we are checking over here, that based on the interaction which we did, we entered the values, we inputted the name and password, and then we tapped on the interaction button, the CTA, and voila, our welcome screen was visible. Another example is the form submissions. Here, what we are checking is you inputted a name, whatever name you want, then you pressed a submit button. The expected workflow is that your submission successful screen or the message should be visible. So this is the integration testing, sorry, the E2E testing, where you are verifying the actual use case in the real world scenario. Now, talking about the testing pyramid. So this is a testing pyramid where we highlight and show that how testing should be done and how testing is important, where it is expected, and it's a good practice, to have as much unit test you should. so that your codes could be tested in the small pieces. Then integration test comes on top of that, so that your units are combined and they're tested in like multiple ways. And at the top resides the E2E test to test the real world scenario. So here is just a diagram which shows that it's a mobile application, a React Native mobile application. I'm writing tests, all these tests are here, and the tools which we use like APM, Jest, Detox, RNTL, and the enzyme. Now we are done with testing of all the gears and everything. Now we are ready to actually go on a trek or the hike. So there comes your CI/CD. So why is it important? Because if you have like set everything, until and unless you go on that trip, it doesn't make sense. So you actually have to deploy it. You actually have to like go out and make those things work. So what you're going to do? Now why this is important? First of all, it automates your testing and the deployments, which helps us in like early detection of the bugs. And at the end, it streamlines the development. Some of the tools which we are using is like, you can use Circle CI, Travis, or the Bitrise. Now, what could be the best practices? Have those tests which you wrote to be integrated into a pipelines. That is, in your pipeline, you should have like a script to run the unit test, a script to run the integration test, and a script to run E2E test. Because if those tests are there in your pipeline, with every code change, you can make sure that this code is not breaking those tests of yours. And then you should have frequent deployments so that you can get early feedback from the people, the stakeholders. This is a sample CI job, that how does it work. So here I have wrote like npm install, then we have written the tests. So in this pipeline, after like your dependencies are installed, you are just running those tests, and then you are building it. Now, we talked about all those strategies. Now let's go through them one by one and just give a conclusion. So defensive strategies, these are important because you have to anticipate the issues in order to make sure your application is robust and resilient enough to handle the unexpected errors and issues gracefully and in a well manner. And in order to achieve that, we can have a good code quality, we can have proper error boundaries, and we can have the components isolated so that they can work individually in a well-mannered. Now after that, build is done. We have to test all those things, test it. Write as many tests as you can, because that is the only way you can be sure that everything is working and as expected. And at the last, once your testing is done, you have to automate those testing strategies and those static analysis which you are doing in your code base, so that when the CI/CD is run, you have it in front of you. If there's an error, you'll catch it early, and you'll be able to fix it as well. So yeah, that was all. Thank you so much. I hope you like it, and thank you again.
Amazing talk. Yes. A round of applause for Shweta. How many of you learned something new in that conversation? All right, that's great. So those are the intricacies which sometimes we tend to ignore or we tend to forget, and very well articulated. So for our next discussion, for our next speaker, we have a very interesting topic, which is AI. How many of you have seen that mashup video by someone who, how many times Sundar has said AI in the Google I/O keynote? Yeah? Yeah, so that was fun. And then it has been the center stage for all the conferences which are happening ever since, and there's just a lot happening. How many of you have been playing with some language, large language models, LLMs, or any APIs, OpenAI, anything? Okay, that's great. How many of you want to? You haven't yet, but you have been closely monitoring. Okay, that's great. So maybe this could be your inspiration. As our next speaker, we have experiments with AI-generated tests, and we have Director of Engineering at CERTA. And we'll be discussing how you can automate this process and how you can utilize artificial intelligence. So it seems there is, we will have the speaker coming up very soon. But however, while we were discussing about the fun projects, there is one fun project which I would recommend you all to check out. Probably I'll share the URL sometime later, which is called GitHub Roast. So that you just put your username and it roasts your profile, right? So when I entered my profile, and I would not have won those awards, by the way. I probably have like 50, 60 at max. And that said that, that GitHub Roast, project created by someone, we are actually featuring them in an event tomorrow. So that project, said that maybe one day Yashraj will have more repositories than number of followers he has. Something like that, right? So it can be quite fun. So what kind of things you can do with AI, and it actually scans the profile and it gives you a nice little light-hearted roast, and you should check it out. Do we have?
Yep.
Good to go? All right. So with a huge round of applause, please welcome Director of Engineering, CERTA, Rajat Vijay.
It doesn't work. The green button. That's fine, I can use this. Hi everyone. I'm here to talk about tests, and a lot of people have already done that. So, okay, the system, it's the system, yes. It's fine. My name is Rajat, and I work at this company called CERTA. I'm primarily a front-end developer, but from the last 1 year, I've also been working on the AI initiatives. Let's take a quick poll. How many of you actually write test cases for your React components as part of your day-to-day development lifecycle? Oh, that's interesting. The landscape has changed a lot in the last 5 years. And how many of you like writing test cases? And why is that? Like, I mean, for the people who have raised hands, hats off. But you guys seriously need to get some life. For the rest of them, which is the majority, why do you think you don't like writing test cases? Is it because they are hard? You don't think writing test cases are hard? You're just lazy to not write it? Okay. That's a good thing. Not a lot of people think that writing test cases is hard, which is actually true, because before writing test cases, we write the code. Generally, it should be the opposite, but then it's okay. And while writing the code, we have already thought about all of the edge cases. We have written the code to handle it. Now all we have to do is mock and assert, which is very boring, right? And I'm really sorry for the last speaker who talked a lot about test cases, but now I'm saying the test cases are boring, but they're actually boring, right? So what is the solution? Should we stop writing them? Should we stop writing them? Unfortunately, no, we can't stop writing them, and not just because your manager or your lead says so, but because they are necessary. And they are necessary for a lot of reasons. They bring reliability to your application, quality, consistency, etc., 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 etc. I have a ton of reasons here, which I'm sure you all are aware of. But then what is the other solution? If we can't stop writing them, but they are boring. So I have a very radical and innovative idea here. Let's generate the test cases. And I know a lot of people are thinking, right, it's not innovative. We have been hearing at least one talk about it in all of the tech conferences, thanks to the GitHub folks. And a lot of other people are thinking, right, not another Copilot talk. I'm sick of them. So I promise it's not going to be another Copilot talk. or a tutorial. On the contrary, it's about the challenges that I faced using GitHub Copilot. And I'm pretty sure GitHub is not going to hire me after this, but still, there are challenges, and we'll talk about them. So the first challenge is, every organization has a guidelines around which you write test cases. So for example, you don't want to use fire event, but you want to use user event. How many of you know user event? Awesome. There could be other guidelines like, we don't want to write describe or read blocks, but we want to write test blocks, which is very hard to tell GitHub Copilot or any Copilot about our custom guidelines. It's also hard to write integration test cases, because all the context that GitHub Copilot has is about the currently open editor. It does not have all of the child components code. It also does not give you any control over the AI layer. So how many of you know the AI models that are out there? OpenAI, how many of you have heard about OpenAI? Thank God. So what if you don't want to use the default model for Copilot? What if you want to use the latest model that OpenAI released? What if you want to tune the hyperparameters of the model to get better accuracy? Hyperparameters? Nice. It's very hard to get a streamlined development workflow. So although it's integrated inside my editor, but then every time I have to write a test case, I have to copy-paste the same base instruction, tell it about all of those guidelines, and then keep generating the test case, which is very tedious, and we don't want to do the manual task again. And on top of it, it's very hard to get quality results. So mostly what I've seen, it generates very generic test cases and does not cover a lot of edge cases. So let's ChatGPT do it, right? How many of you actually use ChatGPT to generate test cases? Awesome. There are some challenges with it. So again, there is no streamlined development workflow. You have to go to another application, copy-paste the code, copy-paste the instruction, generate and do all of those things. There's a lot of copy-pasting, repetitive manual task, and on top of it, vendor lock-in. So again, what if you don't want to use ChatGPT or OpenAI models? What if you want to use an open source model? Enter AutoGuardian. And my mic went off. Okay. So I so wanted to have a lightning background noise here that complements the flash, but that's okay. Kiran said no. So AutoGuardian, again, it's not a product that I'm selling. It's just an idea that I'm explaining. But that's a good line. I should write it down, right? So let's see some demo. Okay. Hopefully it will work. Yep. So I have a component hierarchy. There's this parent component inside the blue background, and then there is another child component inside the red background, another child component inside the green background. So if you click on this wedge-only toggle, it filters the list for wedge-only items. The code is pretty straightforward. The parent component, and then there is a parent component has all of the core things inside it: the toggle state, the list, the item state, and then there is a switch child and a list child, which are presentational components. So let's generate test cases for this. I go to my terminal, click back or close it. Is it visible? Not anymore. Okay. So as I said, it's not a product, it's just an idea. So I'm just going to run it through an npm script. npm run, AutoGuardian. It takes the, let me do this. It should be fine now, yeah. AutoGuardian. It takes the path of the file that you want to write test cases for. So it's inside my source hierarchy, parent component, and the name of the component, because you might have multiple components inside it, inside the same file. Thank you. And it generates a test cases for the component, which is pretty straightforward because ChatGPT and all of those things already does that for you. But then the interesting part is, let's just say no for now. You can also provide your custom guidelines. And I'll show you what the guidelines has. I just have two things in my guidelines where I say I prefer get by role over get by text, and I prefer user event over fire event. Do you know why get by role is preferred over get by text? Do you know why get by role is preferred over get by text? The people are not raising hand because they're not confident if accessibility is the right answer? Awesome. Okay, so I've given all of my guidelines, which you cannot see. Can you see the guidelines at the bottom right? Minus G parameter. Here it is. And I press enter. So while it's generating, I'll show you the code that is generated before. So it's using get by text inside the child component, the switch component that I have, which is actually a button. So instead of this, it should have used get by role. So now it's using get by role, and it's also using user event. Now, one could argue that I could just copy paste all of these things inside ChatGPT and make it work, right? That is true, but then it's about the full product. So it has a configuration file where you can just write the name of the model. You can use an open source model. You can use the latest Anthropic or OpenAI model, or you can provide your own custom instruction. You can have another config. We can provide the path of the guidelines instead of passing it through the CLI. And you can have like 100 other configs similar to this. Okay, so let's look at some more interesting examples. So I say this example is interesting, but not enough, because all of the core, all of the crux of the component is already inside the parent component. So if you read this component's code, you can see all of these things. Like you can generate pretty awesome test cases. So let's go to another component. I have a page component, which just renders to another component, a user container and a dishes list. And both of these are Redux connected component. I'm going to show you the UI of it. This is how it looks. So the blue background is the page component, and then there are two child components, user details and dishes list. Both of them are accessing Redux. So the page component is not aware if they're accessing Redux or not. So if you just read the code of the page component, you don't know what the child components are doing. And then there is a very straightforward presentational component inside the user details component. So let's try and generate test cases for it. Using the CLI was a bad idea. Yep. Let's still try it. Clear the console, which you cannot see. Yep. Perfect. So I'm going to run again npm run auto guardian -p source. It's not hierarchy this time, it's Redux connected, page, and -page. So it's the part to the file again, and the name of the component that I'm writing test cases for. And now, it generated test cases, but these are not good quality test cases. It's not mocking any store data. which is bad, and you cannot see the bottom of it. So it asked me if you want to make any changes to the code, which I said no by pressing enter, but I'm going to run it again. So I'm going to say, so if you look at the first test case, it's actually relying on all of the seed data that I have in my store. So it's not mocking the store anywhere, but it's relying on all of the mock data that I have in my store. So I'll show you the mock data that I have in my store. I have the seed data here, which is a pretty bad idea because this data can change. So I'm going to say, it's a bad idea on the data inside the application code. Let's mock the store. Okay. It decided to not do it. Let's mock the store and not, you can't see it, but I'm actually typing and not rely on the data in the application code. I know what I'm doing. Okay. So it asked me, do you want to make some changes to the code? I said yes, and then I can say, let's mock the store and not rely on the application code. And now it's mocking the store. So it has all of that chat, Copilot chat similar capabilities also. And if you look at the config again, at the very end of it, I've written for the edge cases that are not covered by the code, do not generate any test cases. Yeah. For the edge cases that are not covered by the code, do not generate any test cases for it. It only mentioned in the output. So you can provide your own custom instructions as part of the config and roll it out to the whole development team. And that is why it's generating all of the edge cases that I've not covered in the code base. So you can do pretty neat tricks here. And since I have only 5 minutes left, okay. So if this does not seem interesting to you or does not have a lot of value addition, I would like you to take just one takeaway from this talk, which is leverage AI as much as possible. You can treat it as your, leverage AI in your development workflow as much as possible. You can treat it as a buddy whom you can rubber duck with, or you can discuss ideas with, or maybe as a colleague which can help you generate, getting your job done faster and better. But again, it's not a replacement. AI is not a replacement, so you do have to come to these conferences, otherwise who will listen to Kiran and I? And finally, if you think this is interesting, the idea of having a config and being not able to rely on Copilot or having a vendor lock-in with ChatGPT, all of the code of AutoGuardian is available on GitHub. It's a very rudimentary code, but there are a lot of open tasks here, so if anybody wants to contribute to one of the open source projects, feel free to do that. And finally, for any slides, talk, or any discussions around AI and writing test cases, please reach out. All of the slides and talk recording will be soon on my LinkedIn and Twitter. Thank you.
So thank you, Rajat Vijay, for the awesome talk. So we had two back-to-back talks on how you can write really good tests. So how many of you are actually now inspired to actually write good quality tests? Yeah? Yeah? Okay, great. So continuing with the AI theme, next we have two speakers from Freshworks who are going to deep dive into how you can actually build your own Copilot, and they'll be also diving into the engineering and the APIs and the decisions, all the decisions behind it. So, can we give them a huge, huge round of applause? Neeraj Kumar and Naveen Nagraj.
Hey, good afternoon, everyone. Thank you for the nice talk, Rajat. Talking about AI and Copilot challenges, we'll continue the theme, and we'll crank it up a notch by solving all these problems by building our own Copilot. So today, that's what we want to talk about, how we went ahead about building a Copilot for Freshworks developers that build apps for our marketplaces. Quick show of hands. How many of you have heard of this term called RAG, or Retrieval Augmented Generation? Amazing. And how many here are actually building LLM-powered products? Wow, nice. So I hope you like this talk. Just for intro, I'm Neeraj. I lead Freddy Copilot for Freshworks as a product lead and all their AI initiatives. And I have with me Naveen, who is, again, a lead software engineer with Freshworks Marketplace. The way I'm going to go about this talk is, first give you a quick bit of introduction about what our marketplace and developer platform is, and then let you experience the Copilot we have built that makes it very easy for any developer to go from an idea all the way to an app code in a very conversational manner. And then we'll go and talk about how exactly we built this Copilot and what was the engineering and science and the decisions we took behind it. A lot of it is about prompt engineering. A lot of it is about building our own knowledge base, and that prevents you a lot of challenges that my previous speaker talked about in terms of your LLM lock-in and building great prompts. A quick view about what Freshworks is. We have 65,000 plus customers, north of 600 million revenue, and we work with a lot of brands across industries. And the interesting thing is all these brands and companies, they not only use one or more of the Freshworks products, but they come with a lot of custom use cases, whether in the form of integrations that they want to do across their other products, or their specific long-tail use cases that we expect developers to come and build apps on a marketplace and be able to solve it. This is what, at a high level, Freshworks portfolio is. I'm sure you've heard of Freshdesk, which is a famous customer support software, and we have products across IT service management like Freshservice and so on. Behind the scenes, we have a marketplace which allows our developers to build and publish apps on this marketplace that have a ready audience of 65,000 plus and provides a very good opportunity for the developers to come and build and publish their apps and essentially let the customers use it. As you can see, a lot of these apps are like tier 1 integrations with tools like Google, Slack, and so on. But some interesting ones, for example, here we have Iris Agent, which basically uses this service desk software and AI to be able to automate a lot of customer service agent tasks and so on. So there are a lot of opportunities here, and the developers can use AI to essentially build on top of it. Now on to our main topic. When we heard about and when we were looking at how this AI innovation is happening and essentially how the development is becoming more conversational, we were very excited because I believe AI essentially unlocks developers to come with their creativity and not be challenged by their current knowledge or limitations. So we figured out how we are going to conceptualize building a Copilot that our developers can use to build apps and publish on marketplaces. So that was the vision we took, that how do we enable developers to build high quality apps in a very rapid fashion, in a very fast and iterative fashion. We started with a beta release, and we already have 1,000 plus installed as a VS Code plugin. Yeah. So the way we conceptualize this is, how do you as a developer come with an idea, and how can we take you in a very conversational, natural fashion transform the whole SDLC process, right? So it's a very natural process that you think about an idea, you gather, you understand the developer, APIs, platform, and then you go about designing the mockups and so on, and then you work, you implement, and you keep refactoring it to the point where you feel comfortable to hand it over to testing or test yourself and release it. So the way we conceptualized is we work backwards to this SDLC and looked at everything that developers do and how do we augment it using AI. Everything grounded in the Freshworks context. So I'm going to give you a quick overview of how the Copilot looks. So for example, if you are building an app, let's say a simple URL shortener app, and for Freshdesk or Freshservice, you simply come with your idea and you provide an instruction. The better the instruction that you provide to the Copilot, as we all know, the better the output will be. And essentially you talk about, hey, I want to build this app, and these are some of the features that we want to build in this particular app. What we do is, as Copilot, we take this use case and try to understand the construct behind the app. And these are some of the concepts you can use. So for example, a construct is essentially, here, as you can see, that Copilot has automatically understood that which kind of products, Freshworks products or product modules that this app needs, all from the use case, right? And we're going to talk about how we actually build this retrieval augmented or RAG pipeline to enable this. And one of the key principles we use in any AI-powered products is called developer in the loop and control. So any decisions we take on the behalf of developer, like choosing the products or choosing where the app will appear, all of it is in consultation with the developer. So I'm sure you are seeing like GitHub Copilot Workspace and so on. All of these AI products needs to be built in a fashion that developers are always in control and they're able to edit and review and so on. So here we have already selected some of the product modules auto-detected from the use case. And slowly from this, we next talk about, okay, where this app is going to appear, right? So for example, this app is going to appear in a Freshdesk ticket sidebar. And essentially, we also provide a complete design to front-end code automation. What it allows is we have created a pipeline that can take a simple image, and we understand the components, the layout, and the style of these components, and are able to build a complete front-end HTML, CSS code today. We use some of these vision models like Gemini and GPT are very good at understanding this image. And this is a very simple example, but we can build more and more complex UI using our Copilot. Once we understand the construct of the app, the platform features that it's going to use, then we essentially generate the complete app code. This is, you can say, up to 50, 60, 70% of the structure and the scaffolding of the code is generated. And then essentially you can just simply run this app or iterate on top of it. And we also provide features for debugging, for refactoring your code, and so on. So this is a quick overview of how you come with your idea, and we essentially, the Copilot works with you, and without even understanding in deeper fashion what Freshworks platform is or what are the intricacies of a developer platform, you can just go from an idea to an app code in a very simplified fashion and a very conversational fashion. So this is how the app would appear on a Freshdesk ticket sidebar and essentially work. So this is all AI generated, and obviously the more complex your use case is, the more you have to do iterations with the Copilot. Moving on, we talked about like some of the different features we provide going from an idea to code in a conversational manner. We also talked about how we build this whole design to code pipeline. So if you've not used some of the key vision models like Gemini and GPT, new vision models, please do. We built our pipeline in a way that it can take a mock-up image or a Figma URL, and essentially we are able to understand what components in style and layout. And these components are like Freshworks components. So again, all the Copilot that is generates, it is all grounded in the Freshworks developer platform context. And you can just replace it with like Apple platform or any other platform, right? So that's how this Copilot works. And when you generate app code, obviously there's going to be a lot of iterations, right? So we looked at that part of the SDLC also. So for example, if you're facing any error, you simply right click, paste it into the chat, and it'll give you, it will not only solve, it'll give you the root cause, but actually solve, understand your app context and solve the problem, and you can simply insert the code and work forward. All of this without, again, switching context to documentations or communities. You can just be right in your IDE and keep working on your app idea. Now, all of this is about what was built and how we conceptualize. I'll call upon Naveen to actually talk about how we built behind the scenes this RAG pipeline, this retrieval augmented generation pipeline, and I'll encourage everyone to explore yourselves as well.
Yeah, hi everyone. So, I guess now everyone has a basic understanding of what Freddy Copilot is and how it helps the app developers of Freshworks Marketplace to publish their apps in Marketplace in a more quicker manner, right? So now let's dive into the more interesting part of this discussion, wherein we will discuss the technology behind this Freddy Copilot and how we built it in the backend, right? Yeah. So the core problem which we are trying to solve here is, so for any user or developer query, right? So if you are able to get an accurate and proper response, so we will be able to implement all the features which we have discussed so far. Let it be the taking a use case and generating the app code, or let it be a conversation wherein we try to fix an app issue, right? So it's all a developer or a user query. So if you are able to take that developer or user query, and if you are able to generate a proper and accurate response in a quicker and cost-efficient manner, that is what we are trying to solve, right? That is our core problem. So how are we solving this? So the first and most obvious way would be to directly use the LLMs, some of the LLMs which are currently available in the market. For example, let's say the GPT or Facebook's Llama, all those LLMs, those are publicly available and those are well built. So why don't we directly use them and directly pass the developer query to the LLM model and get the response and give it back to the developer, right? So this works, but it has its own challenges, which we will discuss. So most of these LLM models which are available in the market, right? So these are trained with the older data. These are not trained with the newer data. So for example, let's say if I am releasing a feature today, and there are a lot of Freddy Copilot clients who are using our VS Code extension, right? So if they come tomorrow and query about this feature, it won't be able to answer because these LLMs will not be trained on that feature because we have released it yesterday and obviously it will not be trained on the data, right? So that is one of the problem which we will face if we use the models which are available in the open market. And the other is the complete lack of knowledge on Freshwork ecosystem. So the responses will be more accurate if we try to give more Freshworks context to the Freddy Copilot. So if your model is more and more generic, the responses will also be generic and it will not be tailor-made for Freshworks context. So that is one thing. And we also have something called as FDK. So FDK is nothing but Freshworks development kit, which helps in, which is used for development of Freshworks apps in your local. So it is just a command line tool. So don't get confused between Freddy Copilot and FDK. So FDK is a command line tool wherein Freddy Copilot is a AI assistant wherein which assists you in development. But FDK is compulsory and it is needed for your Freshworks apps development. So this FDK, right, it is in different versions. It has evolved over the period of time. And we have a lot of clients which are still using the older versions of FDKs. So for the clients who are using the older versions, we should be able to respond in their own context. So we should not suggest them the newer features which are there. we should only suggest the features which are supported by the older version. So the FTK context plays an important role in giving an accurate and proper responses to the client. So how do we solve these problems and give context to this pipeline, right? So this is how we solve it. So we introduce this FDK context into the pipeline. FDK context is nothing but a combination of Freshworks developer documents, documents about APIs, about Freshworks products, and a few common code snippets which are used to solve common issues, right? So the combination of all this, we call it as FDK context. What we do generally is, we take all this FDK context, we convert it to hundreds of articles, and each article, right, we pass through an embedding model. So while passing through this embedding model, what we essentially do is, we convert each of these articles into a vector. So all these hundreds of articles and these hundreds of vectors, this will be saved in the vector DB. So this is what we call as preloading. We have loaded all our FDK context into the vector DB and we have it ready to be queried, right? So now whenever a developer queries, so what we do is, we essentially take this developer query, we convert this developer query into the vector using the same embedding model which we used during the preloading phase. Now what we do is, out of this vector we got from the developer query, we try to find the matching vectors by scanning through the DB. So let's say we get top n results while scanning through the DB. So out of this top n vectors, we find the corresponding articles for those vectors. So essentially what we are doing here is, for a single, for any developer or user query, we are finding the related articles. So this is what we call as context augmentation for a particular developer query. So once we have this context augmented for a particular developer query, we build a prompt by using both the developer query and the context which we got for it. So a lot of iterations go in optimizing this prompt. A lot of engineering goes into it, where we have multiple iterations in tuning this prompt so that LLM will be able to give an accurate answer. So once we have that prompt ready, and we feed in the developer query and the context selected to it, and if we pass this prompt to LLM, it will be able to give more accurate and a deterministic answer for whatever the query which we feed in. So this looks fine, right? What are the challenges with it? So the most important and the challenge which we are facing is, we should always keep this vector DB updated. So let's say we are releasing a new feature today, and this release, along with, we should have an automated pipeline wherein we should also update this FDK context and vector DB with the new feature and the docs related to it, so that whenever a client comes and queries through Freddy Copilot, right, he will be able to get the context out of it, and Freddy Copilot will be able to answer out of it. So this all works fine. So this was all working fine for us for smaller queries, but when it came to larger queries, right, this was not performing good. So when we analyze deeper, so if you are wondering what a prompt is, this is how a prompt looks. Yeah. So coming back to larger queries problem, wherein we were not getting accurate answers. So when we analyzed deeper, we found out for larger queries, the embedding model is truncating the query, and it is only taking the first part of it, and it is ignoring the last part of it. So how we approached the problem is, we introduced something called as text processor in between developer query and the vector DB. So what it essentially does is, it uses NLP to segment the developer query into multiple segments. So let's say I have got a developer query of 300 words. It will divide it into 3 segments, let's say. It is all based on NLP, and it will divide it into appropriate number of segments. So for each segment, we will assign a score. And based on the score, we will augment the context for this segment. Earlier, we used to augment context directly based on the developer query, but here we divide the developer query into segments, and for each segment we will augment the context for each segment. So by combining all the context for these segments, right, that is what is essentially the developer query, right? Developer query context. So here, the advantage is even if there is some important information mentioned in the last part of the query, that will also be considered while we feed in the context to the LLM. So once we have the prompt ready, it again follows the same pipeline wherein we feed into LLM and we will be able to get an accurate response from the LLM. Yeah, by this, we will have accurate response than the earlier version which we discussed. So we were discussing a lot about embedding model during both the preloading phase and during the querying phase, right? So what is the embedding model which we are essentially using? So mini-LM is the embedding model which we are using. So the reasons are basically it does effective vectorization. So which essentially means it basically groups the related articles together. So whenever a developer query comes in, it is able to efficiently pick the related articles. So that's what we mean by efficient vectorization. And we have to give real-time responses to the user. So if you have gone through the demo of Ready Copilot, the user would be expecting the answers in the chat window, right? We can't make the users wait for very long. We should be giving the answers to the user in less than 5 seconds. So that is what we achieved with mini-LM. And also the cost effectiveness. It takes a very less amount of infra to get this mini-LM up and running. So which in turn translates to cost effectiveness, right? So that's what it is all about. And when we were going through the pipeline, I was explaining a lot about the preloading the data to VectorDB, right? So how we do it. So we will go a little deeper into it on how we do it. So whatever the FDK context I was mentioning is the left part, which is the docs, APIs, and the code snippets. So the docs are nothing but the Freshworks developer docs, and the APIs are nothing but Freshworks APIs, third-party APIs docs, and also mainly the platform APIs. And the code snippets are nothing but the common issues with which the developer faces, and also some of the snippets from the community which we have. All those things will be converted into articles using the text processor, and then these articles we will be passing through the embedding model as I explained earlier, and we will be converting that to vectors, and we will be saving that vectors in the VectorDB. So this is what we discussed in the preloading phase. I just wanted to dive a little deeper into it. Yeah, that's about the technical background of how we get accurate answers for developer queries in Freddy Copilot. Let me again hand it over back to Neeraj to wind up the talk. Thank you.
Thanks, Naveen. Thank you. I'll just wind it up. So quickly, take your prompts seriously. Build your data pipeline. Make sure your knowledge base is up to date. Being able to retrieve the right context from this knowledge base and able to create your prompts and pass it to LLM is what makes the difference of a lot of challenges that we were solving. We got a great traction from our developers. We've already burned 47 million plus tokens and a lot of thousands of dollars, and more than 330 plus apps have been built using Copilot. Yeah, thank you so much. If you want to, we have a booth. If you want to hear about more war stories from building our own Copilot, or if you're building LLM-powered products, please do come and talk to us. Here's a QR code for a quick quiz if you want to take it. Thank you. Thank you, everyone.
Thank you, Neeraj and Naveen. That was really a very deep dive into the inner workings of Copilot. So, are you all feeling hungry now? But we just have 2 more talks to go. Just kidding. We are going to have a break for lunch now, and grab your lunch, have networking. Also, there is a dedicated Q&A room if you want to, have a speaker's Q&A. And yeah, let's meet in 30 minutes. We have a memory game by Shweta Tanwar. So yeah, let's meet in 30 minutes. Have a great time. See you.
you pachango. Afere fumo chun, cabio sile pachango. Afere fumo chun, cabio sile pachango.
Hello. Hi, everyone. We'll be starting with the quiz very soon. So if your friends are outside, if you want to ping them. Mirror my display. Hello. Yeah. All right, everyone. How's the Josh? Can we hear that loud? How's the Josh? Once again, how's the Josh? Yeah. So we are here back again after lunch, and I'll be soon very soon handing over to my colleague, my co-host Sahil. But before that, I wanted to be your co-pilot, your host for this small segment, which we call the quiz. So how many of you have participated in this kind of quiz before? Maybe last year, React Nexus or GitHub Constellation. All right. Everyone, so please scan this QR code, or you can go to menti.com just menti.com and enter this number 460-84560. So this is the QR code. How many engineers does it take? This is not a prize question, by the way. This is not being marked, all right? So you'll have other questions which will be marked. So everyone, Very soon, we'll have questions on screen. And did you hear the KBC tune in the beginning? Yeah, so let's set the mood. All right, 11:29. How many engineers does it take to replace a light bulb? All right, how many of you think it's 1? Okay, how many of you think it's 0? And why it is 0? Anyone? Because it's a hardware problem. And we software engineers, we cannot deal with that. All right? I hope you get that. Okay, someone got it. So it's a hardware problem. We cannot change a light bulb. All right, so are you ready for the first question? Yes or no? No? All right, everyone. How many people have joined already? Anyone who is still joining? How many have still joined? How many have already joined? Okay, let's give 5 more seconds and we'll start with the first question on your screen. And disclaimer, everyone, this is a fun quiz for you to learn something new. These are intermediate level questions, so should be pretty easy for most of you. And also, just in case, we do ensure there are checks. In fact, just right before this, we had another test, another check by a speaker. But just in case, if there are any problems unknown which we couldn't find before, please understand that things happen. Even we have runtime errors, right? So please be kind to us. We hope nothing will happen. Yeah, just a heads up. All right. So the first question on your screen. Are you all ready? Yes or no? Yes. I want to see yes. How many of you are ready for the first question? All right. Okay. So on your screen, here it is, the first question. We have question number 1. All of you who are here, I can see your nice avatars. 120 players are ready. And here we go. Oops. Sorry. My bad. It's a UI I'm still getting used to. Here's the first question on your screen. What is the purpose of children prop in React components? You'll have 20 seconds. Fastest fingers first. Everyone, faster to answer, better the leaderboard score. Is it A, to pass data from parent to child components, to render child components within a parent component, to manage state within functional components, or to handle routing in React components, applications? So, time is up. And the correct answer is B. A round of applause for everyone who got that right. Yeah, can we hear that loud? All right. Here's the second question on your screen. Before that, let's see the leaderboard. Whoa, round of applause for E.T., Pallav, and Arpit. Can we have round of applause for all 3 of them? And all of you can claim these rankings change very fast. And I see some known names here as well, which is very good. All right, here's the second question on your screen right now. Which library is commonly used for routing in React applications? Is it React Router, Redux, Axios, or Express? Someone? All right. No calling, everyone. No prompting. This is not ChatGPT UI. You cannot do prompt engineering here. All right. So that is your right answer. Let's see the third question on your screen right now. What does the term state management refer to in React? Managing the state of a React component using this .state, handling global state using Redux or context API, managing the lifecycle methods of a component, or storing data in local storage. 7, 6, 5, 4, 3, 2, 1, and time is up. All right, that is a close one. How many of you got that right? Okay, amazing. Let's see. Here are fourth question of the day. And the question is, which of the following is true about React components? Look at your device, 19 seconds to answer. This can change the leaderboard. Functional components can have lifecycle methods. Class components can't use hooks. Components are building blocks of a React application. Components can't be reused. All right, the time is up. And 46 of you got it right. All right, how many of you have learned something new so far in this quiz? Anybody? All right. Here's the leaderboard. We have a shuffle here, and now we have Ronald, Manoj, and Thomas are leading the leaderboard. Here we are with the third last question, 5 out of 7. And the question on your screen, what is the purpose of React testing library? To test the performance of React components, to test behavior of React components from a user's perspective, internal implementation details of React components, or to test compatibility of components with different browsers. Okay, so when the Galaxy Fold came, how many of you had nightmares? More screen sizes to support. Anybody who had nightmares? Okay, all right. So 89 of you have got it right. We have the sixth question of the day on your screen. Oops, not right now. The sixth question of the day on your screen right now. All right, which method is used to create a user interface in React? This should be pretty easy. Something which you do day in, day out. Render UI, create. Please tell us what's the joke. Yeah? All right. 5, 4, 3, 2, 1. And whoa, claps for everyone who got that right. The last question of the day on your screen, everyone, is here. Which of the following is not a valid way to create a React component? 20 seconds to answer. Your options are using a class that extends React.component, using a functional component, using an arrow function, or using a plain JavaScript object. All right, 2, 1, 0. And round of applause for everyone who got that right. Yeah. Now let's see the leaderboard. Are you all excited to see who are the winners? Yes? Who is ET? All right, let's see how it changes. A huge round of applause for Rajat for 586 points. Where is Rajat? And we have the runner-up is Puffy. Where is Puffy? All right, please stand up. And Barefoot Contessa. All right. So please make sure you find our volunteers in the corner, and you can claim your prizes after the day ends. All right. So everyone, round of applause for all three of them for being on the top. So that is from our side, everyone. And now, are you all excited to see what we have in the lineup for the second half of the day? Yes? Yeah? All right.
Thanks, Yash. Can we have a huge round of applause for Yash? So you guys had lunch? Had desserts? Feeling sleepy? Wrong answer. Okay, I think I might have the perfect solution for your sleepiness to go away. I think. Maybe let's use this. I wanted to play the on-call tune, but then I thought, why bother people? Any on-calls this week? Any on-calls? So many. Did you get any tickets till now? No? Okay. Chalo, so next up we'll move to the fireside chat. We have Naman and Satya from Meta, and we have the moderator Tapas Adhikari, who is a demand stack developer. So I think this is quite a unique thing. We are either front-end developers, back-end developers, full-stack developers, but he's a demand stack developers. And we have already talked about Naman. He almost went into FTII. And we have Satya as well. So both of them are from the React Meta core team. And Naman is also a StyleX maintainer. And so Satya has helped build the React compiler, which was recently announced. So let's have a huge round of applause for our panel, who will be talking on React 19 and beyond.
Check. Hello.
That works.
This works. Okay, somebody can fix this?
Hello?
Working? Yeah, sure. Hello, yeah, it's working. All right, so I'm more than excited to do this. How many of you are excited about React 19? I need shouting, not hand raising. Excellent. So what we're going to do in next 40 to 45 minutes is like we want to explore things in and around and beyond React 19. And these two gentlemen beside me, you got their introduction, but however, I would like to start with Satya. If you want to tell a little bit more about your background first, like what you do in Meta. I know that you are doing in the compiler stuff, but a little bit more about it.
Yeah, for sure. So my name is Satya. I'm a software engineer at Meta. I'm part of the React core team. And like you said, I've been working on the React compiler for the last 3 years almost now. And we just open sourced it at ReactConf a couple of months ago. Yeah, that's me.
How about you, Naman?
Hi, I'm Naman. I've been at Meta for 7 years. I'm on the design system team. We make the components that go into Facebook.com and some other websites. And I've been working on StyleX for like 5 years. We open sourced it in December. It's our CSS and JS library. It's also compiler-based. It's a Babel plugin, but it's a much simpler project than the React compiler. It's just
Awesome, awesome. All right, so we'll get to StyleX, but before that, about React 19, because people are so excited. That's what we saw. My first question to you, so we are excited about React 19. How much excitement should we have? And what kind of preparation we need as a developer who have been doing on React for quite a while? Because since I started with React, it's probably the first time I'm seeing this amount of excitement. It's kind of phenomenal.
Yeah, definitely. This is the release where server components is going stable. So that's really exciting for us. We've been working on server components for a long time. And this is the first release that's stable. So that's the big talking point. Apart from server components, there's a bunch of other features that fit into the story of server components, like form actions, for example. They work really well with server components. And then there's optimistic UI that we added support for with a hook called user optimistic. And then there's a tiny little new operator called the use operator that we added. Not a lot of people know about it. It's very underrated, but I love it. And then for me, the most exciting part is the 19th release unlocks the React compiler. So the React compiler doesn't ship with 19, but the React compiler uses a hook. And that hook is provided by the 19 release. So with 19, you'll be able to use the React compiler once the React compiler goes stable. Yeah.
I want to mention one more thing because it goes under the radar a lot, which is ref is finally just a regular prop, and you don't need forward ref. That's probably the biggest DevX win in the short term.
That's kind of a relief, actually. That's something we are really waiting for to use. But a question that comes, are there any breaking changes that we need to be worried about or need to consider in React 19?
So we have a page with all of the things you need to do to update. I don't think it's a big update. There are some breaking changes. I think, yeah, I will refer back to the React release to look at the changes. But yeah, I don't think there's huge changes here.
Cool. Yeah, I think one thing I want to mention is if you've been using the modern patterns, there are no breaking changes. It's more like, yeah, refs are finally just a prop. So if you're using string refs in some class components from 10 years ago, yeah, that will stop working, but hopefully you're not doing that anymore.
That's cool. I'll go back to Stylex now. So you mentioned briefly about Stylex in your talk. If you could give more insight to it, I guess that is something that we use as a paradigm for Facebook, WhatsApp, and more other meta apps, right? So.
Yeah, okay, so Stylex started about 5 years ago when we were working on a big Facebook.com redesign and rewrite. It was actually when we rewrote all of Facebook.com to be built with React, and Stylex was the styling solution that was made for that. And for the first few years, we just like modified Stylex to fit our needs and to scale to Facebook scale. And then it was so successful and people liked it so much that my managers and others were like telling me to work on open sourcing it, and other products within Meta, such as Instagram and WhatsApp, started reaching out and like they started adopting Stylex as well. So as of today, pretty much all the desktop websites that we have at Meta are all running on Stylex for the styling. This even includes like threads and Meta AI. Like the new stuff is pretty much 100% Stylex. Some of the older screens have a mix of the old code and the new code. And what it is it's essentially a CSS and JS library from a developer point of view. It's similar to Emotion or stylesheet.create from React Native. But what makes it different is that unlike traditional CSS and JS that has all of these performance trade-offs where you have to rely on runtime injections of styles and things like that, Stylex is based on a compiler. So it generates a single static CSS file at build time. So you have the same performance as like handwriting CSS in a separate file, but you get all of the benefits of CSS and JS, including like composing styles, passing them around components, and just deterministic resolution.
So you mentioned about CSS and JS, and I have to ask this. So what's your own view about CSS and JS? Because when it came, right, CSS and JS, there were a lot of mixed view, like when CSS JS was there. What's your thought, and how you started with it, and how do you see it today?
Yeah, so I think CSS and JS was misunderstood a little bit because the whole point of putting CSS in JavaScript was never about the runtime characteristics of it. CSS, being a static file, is better for performance, and we've always known that. And the early CSS and JS libraries that actually inject CSS at runtime, they all have a performance bottleneck, and the fact that they were often fast enough kind of tricked us into using it more than we ever should have. And I think why I'm happy that Stylex is now open source, and also why I'm happy that things like Tailwind are getting lots of popularity in the community, is that it's finally what CSS and JS should have been, which is you get to write your styles in your JavaScript code with your components co-located in the same file. And you get all of these other benefits of having JavaScript as a language, where you have namespaces, you don't have like these, you don't have to deal with global namespaces, you don't have to deal with conflicts. These are the things we wanted by putting CSS in JavaScript. But we never wanted all of those performance problems, and the compiler with like Stylex is one way to fix that. There's some similar-ish solutions that are all build time. Like Tailwind is essentially a build time tool, and Panda CSS is a build time tool. So Yeah, I think it's the correct model if you have the right performance characteristics.
Got it, got it. So I'm sure that many of us would like to know about React compiler. And when I first about compiler, I always feel like compiler is something which take the source code, take out the bytecode. What is React compiler is about? What is inside?
Okay, yeah, let me actually give a background. Like, has everyone here heard of the React compiler? Okay, quite a lot of people. That's actually, yeah, that's great. For those of you who are not aware of the React compiler, so you know how in React we just work with regular JavaScript objects, they just plain values, and when state changes, the React component re-renders. That is the philosophy of React. It's a function. Your UI is a function of state, right? That's the fundamental idea, and everything just follows from that. But one of the problems with this is sometimes you could re-render your component more than necessary. So you could compute more values unnecessarily if your component re-renders. And to fix this, well, the computer science way to fix this is to cache the values, right? And React has a bunch of hooks for exactly this. So there's the use memo hook, there's the use callback hook, and there's react.memo. And they all help with memoization. So you don't have to recompute values that haven't changed and React memo will, or React.use memo will only recompute if the dependencies change. So there's a dependency graph that you build in. But the problem now is you have to think about memoization as a UI developer, right? You don't want to be thinking about all of this. You want to build your product. You want to build your UI. That's what React has been great for, right? Like you don't have to think about anything else. You just describe decorative UI, and React just makes it happen. And that was the selling point for the VDOM. And it's actually great. So with the compiler, we were thinking, okay, so we have this use memo hook. We have these hooks, and they provide some mental overhead for developers to think about. That's taking time away from the UI. What if we could automate this? What if the compiler could actually understand your React component code and understand the JavaScript specification, and then model a computation graph and know what is the dependency for each value that's in your component? So the compiler actually does all of this. So you don't have to think about use memo or any memoization. The compiler will just run ahead of time. It will take your React component code, lower it. It ships as a Babel plugin for now, but we actually do a fairly sophisticated compiler analysis. There's a lot of work done to make sure we follow the rules of React, for example. So the compiler then spits out a component, like the same component, but memoized. So with the compiler now, you don't have to think about re-renders, for example. So that's the idea behind the React compiler. And we've been thinking about the React compiler for a long time, almost 10 years now. In fact, the first attempt at building a compiler was on class components, 8 years ago, maybe more than that. That's when we actually built it and then tried to ship it. But we ran into a lot of issues with class components. For example, this keyword was too dynamic, and the compiler couldn't understand it. And that actually motivated the design for function components and hooks. So hooks and function components are not only great for developers, they actually help the compiler. So we've been thinking about this for a long time. And then the recent React compiler is the latest iteration of the compilers. And this is something that we have shipped at Meta, and we think we're at a state where we can open source and have people in the community try it and give us feedback. So it's it's been a long journey for the React compiler.
Great. So it means no more use memo, use callback for us once React 19 is coming up, right? We don't have to use probably, if you're writing a new code.
Yeah, so it is a bit tricky. The compiler is actually smart enough. So if you have code that already use memo and use callback, the compiler will compile that component without taking in the use memory use callback. It'll compile it as though it doesn't have the use memory use callback. But then once it compiles the code, it'll compare the compiled code with the original code, and it'll see, hey, is the use memos the same? Like, have I compiled correctly? Or has the user actually added more use memos? And it'll see if the user has added more use memos, then it won't compile that. It'll be like, hey, maybe the user knows more than me. I shouldn't be compiling it incorrectly. And then it will stop. So this helps with like correctness. We've seen some people depend on memoization for correctness as well. But then if you're using memoization just for performance, yeah, the compiler will just take care of all of that. You don't have to think about use memory use callback at all. The compiler can actually memorize more than developers can, because, for example, use memory use callback has to follow the rules of hooks. So it has to be at the statement level. So everything has to be, you can't cache a value inside a conditional or after like an early return, right? But the compiler actually doesn't compile to use memo. It compiles to something that's more lower level. So it doesn't need to follow the rules of hooks. So it actually memoizes more than what was previously even possible. The compiler also will memorize JSX elements, which previously no one did, because that was just, it gets too cumbersome if we have to memorize everything. And then some other pattern that we noticed was we actually shipped it on an app that was very heavily optimized. Like we had several engineers go in, optimize the app by adding use memory use callback. And then we were like, okay, there's not going to be any improvement. It's going to be the same. We actually saw a big improvement in that as well. So it turned out that the performance improvements were done, and then they saw improvements, and then they went away. Like the engineers went on to do other things. And then someone new joined the team, and then they just passed down a new prop without memorizing that prop. So all of the performance work the engineers had done was lost. Right? So this is the problem with memorization, is you have to constantly think about it. And with a compiler, you don't have to do that. The compiler is going to constantly run on every change. So the compiler can memorize more. So you don't have to definitely think about use memory use callback.
Right. So one thing extra that, like other than performance, that the compilers helped out a bunch, like building components for the design system, is we've noticed that the deep understanding of the code that the compiler has, it has discovered bugs in our components. So you may sometimes be breaking the rules of hooks and might not realize that you're doing that. And previously, to catch these subtle bugs would basically be impossible for an ESLint plugin or something. And the React compiler is so sophisticated that it's revealed a whole bunch of really subtle bugs where you won't see it in practice most of the times, but 1% of the time something is breaking in production. And it caught all of those, revealed them, and we were able to fix them.
Yeah, there's a ESLint plugin that we ship with a compiler. Is anyone using the ESLint plugin? Okay, some of you are. I would recommend more people to adopt the ESLint plugin. It helps you write better React code. It's not for the compiler. It's for developers to write React code. So the React compiler, like I said, understands React. So it understands the rules of React. For example, the component has to be pure. You can't modify props. You can't modify state directly, right? Things like that. And it has built-in analysis and validations to check if you're modifying props. And it will complain and be like, don't do this. This is breaking the rules. And the rules are not for the compiler. That's the best part, actually. I actually joined the team without knowing a lot of React. And when I learned the React programming model, that's when it clicked for me. It's oh, this paradigm is so good that it helps, the fact that the pure functions help with building better composable UI, that's the main part of it. And making it, this pure functions also make it really good target for compilers was just an additional benefit, right? So that's why this functional UI paradigm is so good.
Awesome, awesome. So I guess React compiles with a lot of promises, right? Are you guys happy? Yes. Let's clap.
So this was done by a team of 4 people, not just me, but I'll take all the credit.
Yeah.
great to, yeah, you and all of us who worked behind it. So, um, in this year ReactConf, I was watching the video on YouTube, and you mentioned about React Strict DOM. And today in your talk also, I saw a glimpse of it. So what is it about and what is empowering?
So there's this project that is widely used. I don't know how many people here use it. It's called React Native for Web. Can you raise your hands if you've used it or heard of it?
Oh,
okay. So React Native for Web basically lets you write React Native code and let you share that same code on the web. And the way that it does that is it has like a bunch of shims and like JavaScript code to run all the things that exist in React Native on the web. But over time, we basically realized that the web has more constraints than native in some ways. We need to be able to serve or render web apps, but not native apps for like good performance. And to be able to do something like that, we need to be able to use CSS features like media queries or like pseudo classes like hover. And so we realized that React Native for Web is like a great convenient tool to share code between web and native, but it causes some compromises on the web. And so React Strict DOM is like another attempt at the same problem, but from the other direction. So this time, we're starting from web code and trying to bring that to React Native. And you can see my talk at ReactConf for like the whole vision. Like the vision's actually much bigger than React Strict DOM. It's just like a small part of where React Native is trying to go, where basically in the past React Native was like fairly similar to the web, but like there were things that it was like just different for no reason. Like the CSS defaults were different and things were missing and features were missing. And so actually React Native itself is evolving to be much more aligned with the web and much more predictable in how everything works. But while we do that and like while React Native improves, React Strict DOM is like this shim layer for now, where we are able to bring way more features to React Native from the web on a JavaScript layer. So we, just to give you a few examples, we bring support for CSS variables, media queries. We are adding support for some like DOM APIs as well. Like there's support for get bounding client rect, things like that. And so the idea is that going forward, as long as you use a somewhat modern subset of CSS, so there's efforts on way to like add grid layout and stuff to React Native as well. But like over time, hopefully you can write your app once, run it on web and native, and you won't have to like rewrite all of the things that are basically the same anyway. There'll always be some amount of rewriting, just to tailor to each platform, but you should be able to share more and more code between web and native.
I think that's a dream that developers are living with, right? More code sharing between both web and native. That's awesome. So is it open source? Can anyone contribute to it?
So StyleX is open source in December. React Strict DOM was open sourced like 3 or 4 months ago. React Strict DOM is early, but it is functional. We are building with it today. And like there's a whole table there. So it's got a compatibility table that tells you what's supported, what's not supported, what's being worked on right now. So yeah, if it meets your needs, you can use it. And with a like web and native code base, it's always easy to like bail out and just make 2 separate versions of a component. So even if it doesn't fill all of the needs, it's easy to adopt incrementally.
Yeah, thanks. Okay, so let's move on to another topic. I think that's something changed the paradigm, the way we think about architecting the application, web application. I'm talking about React Server components. We had 2 amazing talks today. So my question to you is like, you would have seen React Server component very closely since the incubation, the design, and all these things. How should we think differently when React Server components come into picture for application architecture? Is like, people are thinking about like all in client, now things are going bit in server. There are a lot of memes also around about things going in server. Okay, let's not talk about those, but what's your view?
Okay, so there's like a long thing to think about here, but the first thing I want to say is, before you even like adopt server components, if you just read through like the architecture of how it's like telling you to architect your app, that's how most React apps should be anyway, which is that you should, there was like a controversy recently on Twitter, which is like, You can do render as you fetch or fetch as you render. And you should try to avoid fetch as you render. So fetch as you render is you render some components, then those components fetch some data, and then they re-render. So I don't think I need to even explain why that's wasteful, because like you're waiting to even starting to fetch your data, so obviously everything's going to be much slower. But React Server Components kind of takes it to the next logical step, where you can start fetching your data while you're still on the server. So your server rendering, you start fetching the data, and you render the things as they come along. And when you start, it's kind of similar to like Next.js's like loaders or like Remix's loaders. Like we've had some similar patterns in these full stack frameworks for a while now. So I would start with those. Like, do those make sense to you? And then React Server Components is like a huge optimization step after that. So if you're already fetching your data on the server, and a lot of your components are only there to just take the data that you fetched and render them into markup, and they don't have a bunch of behavior, it's like, why are we wasting bandwidth and time, like hydrating components that don't need hydration? Like, why are we spending time hydrating components that don't have any interactivity to begin with? And so React Server Components will be able to give you smaller JavaScript bundles, faster hydration times, and it's a huge improvement in like the architecture as well. But I don't want to speak too much on that specifically, because different frameworks actually are tackling that in different ways. So there's the Next.js flavor of React Server Components that's been out the longest, and React Server Components in Next.js is fairly automated. But it is also a big change from how Next.js used to work. So there's trade-offs. That was kind of going back to my talk. So here the trade-off was they try to give you the best possible model, but at the cost of more expensive migration. And then more recently, Remix has kind of shown a demo of what they are working on, where it doesn't give you like all of the like bells and whistles that you can get with React Server Components just from day one necessarily, but they have a really nice migration story where if you are using loaders, so Remix has a thing where you can have a component in a file, and in the same file you can have a loader. And in the past, the loader would fetch some data, return that data, and then that data would be used by the component in the same file. Now, the loader can just return JSX, because again, I like mentioned this in my talk, JSX is just data. So like the whole reason React Server Components work is because JSX is just data. And so Server Components decided that, hey, API calls can return JSON, but also JSX. And so that way you can just like move some of your code from your component into the loader and it just starts working. And so that will be a different architecture and one that is more easily adoptable in like incrementally. So there's many different things. The community is still figuring out like what will be the best architectures around it, but it does like fundamentally change a lot of things and removes a lot of burden.
Yeah, I think Naman covered a lot of it, but I want to give some historical context or like the background on the design for server components. Do folks here use GraphQL? Okay, quite a lot actually.
More than
do you use Relay as well? Does anyone use Relay? No, one hand, 2, 3. Okay, that's about it. So we use Relay at Facebook, and Relay is a client library for GraphQL. And honestly, like Server Components was like, what if we wanted to bring Relay to React? What would that look like? And that's how Server Components came to be. So the best thing about Relay is it's basically just a data fetching library, but it has a compile step. So it lets you co-locate your data query with your component. But then it will run a compile step. It will scan all your components. It will figure out what are all the data dependencies that you need to render a single page, and then do a single query for all of them. So you don't really have any waterfalls in this model, right? Because you just do one request, which is very different from like your other data fetching libraries. And this is the secret sauce that we use at Facebook. And we were like, we want to bring this architecture to React. And then we came up with server components. That's the right way to do this, where it is more composable, right? Components are composable. That's the number one thing about React is how does this, every time I go to a design discussion with the React team, the first question that comes up is it composable? That is the one question that everyone talks about before we decide on any API. And server components is the composable alternative to Relay. So it's the way to do data fetching. It's data fetching for suspense, basically. If you think about suspense and how it integrates with server components, then you have now you have a good cohesive model. I don't know if you saw Naman's talk from earlier today. He talks about how some decisions make sense in the future when more things ship. And this is a prime example of that. A lot of people were like, well, we have suspense, which lets you read a promise. But how do I create the promise? Where's the data fetch happening? We were like, well, you can use useEffect for now. And then with server components, we've completed the whole story. You do the data fetching in server components, and then stream a promise down that you can use with the use hook. And that integrates really well with the suspense API. So that's the background for why server components.
Yeah, thanks a lot for sharing the insight. So I think no React talk is complete without talking about the hooks, and we know about the use API. So is it really the dead end for useEffect?
No, the use API is not a replacement for useEffect. The use API is just for reading resources that have been created outside render. So like I said, if you create a promise outside render, like in your server component, and have it streamed down, you can use the use operator. We don't call it a hook, we call it an operator, because it doesn't follow the rules of hooks. You can call use conditionally, so it's not a hook.
It does replace use context. So use can read different kinds of values, and one of them is promises, as Satya mentioned, and if I'm not wrong, it also automatically suspends if you use a promise. So in the past, I know most of you probably haven't done this directly, but when frameworks implemented suspense, they worked by throwing a promise, which use the error catching in React, and uses the proper API to cause suspense. We know how to wait on things, but how do you cause suspense in the first place? If you use a promise, it causes suspense. The same way, if you do use a context, you can read the value of a context.
Cool. I think I see a time's up there. So the last question from my side is where do you see React going? I mean, you imagine that in 2025, we three are sitting here and folks are listening to us. What will we be talking about?
2025. Hopefully React compiler is stable and shipping by then. I think you can see more of compilation based improvements to React. So the compiler is actually not just for memorization. That's just step one, right? The other step is already the second part of the compiler is the ESLint plugin. It works, it gives you errors like warnings and linting. That's the second part. And as you can see, there's more to the compiler than just this. So it's like a platform. So rather than thinking about it as a memorizing compiler, the way to think about it as, that's exactly why we call it the React compiler, because we're going to use this as a platform to build on from this.
So adding on to what Satya is saying, I actually want to mention signals, which is one of the, a lot of other frameworks use signals. And people think that signals are used because they're fast or they're basically event emitters. So what makes them the thing that everybody's using? And it's basically an easy way for a framework author to figure out the data flow in an application. And to do that, there's other trade-offs that they have to make. The React compiler gives React the ability to understand the data flow in an entire React app. So we get that same capability that Signals gives you without losing all of the benefits of the React's functional model. And so for now, it's using memoization, but because we understand the entire data flow, I can imagine all sorts of really crazy features that are like nowhere else right now. So like we mentioned Relay, and we have server components. But if you see server components today, there's still a certain amount of being careful to use it correctly, where you have to hoist data fetching up to make sure that you're not like waiting on one data fetch to then trigger the next one. And with something like the compiler, more and more of that would become automatable, where you won't have to opt into a full system like Relay, although if you do that, it's probably still going to be a great system. But it'll give you the ability to compose functions together and maybe hoist them for you, or at least detect them. I see like an explosion of tooling coming in the next 5 years of React.
Awesome. I got many more questions to ask to these two gentlemen. I'm sure you also. So catch them anywhere outside in the break. And thanks a lot for giving all this insight. I hope you enjoyed. And if you did so, please give a clap for these two. Thank you very much.
Can we have a huge round of applause for our panel? Our moderator, Tapas, Naman, and Satya. Thank you so much. It was indeed a very insightful chat. Lot of features of React 19. Lot of key takeaways. So many concepts. Render to fetch, fetch to render, server components, memoization. Ref as a prop. I would like to tell one thing. Satya mentioned that we should use ESLint library. So not just users. I think we have a lot of users. Can we have a quick show of hands? How many ESLint users we have in the audience? Quite a lot. We have a ESLint core maintainer also in the audience. So yeah. We also talked about React Strict DOM, and the best line for me was by Tapas. Dream of every engineer is more and more code sharing. So yeah, a very great line, a t-shirt line probably, Tapas. Okay, so moving on to the next talk. We have Prateek, who's a full stack engineer at Fold. He'll be talking about the importance of client-side routers in modern web application and why TanStack router stands out. When he's not coding, he can be found playing Mortal Kombat and chess. That's a weird combination, but a good one. So yeah, please welcome our next speaker, Prateek, with a huge round of applause.
Hello. Yeah. In this talk, we'll be discussing about like how you can build more robust and type-safe application and elevate your routing game with TanStack router. So as you already introduced me, my name is Prateek. I'm currently working as a software engineer at Fold. So yeah, like before we begin, let's understand like why do we even need a client-side router in the first place? Like, can't browsers already handle like navigation with link tags? Well, the answer is yes, but client-side routers significantly improve the user experience and also the developer experience. So to understand that, let's first take a look at like how the basic default browser navigation works. So for example, whenever the user clicks on a link, the browser sends an HTTP request to the server for the new page. And as soon as the server processes the request, it sends the response with the new HTML page. And after that, like once the browser receives the response, the browser then has to unload the current page, discarding all the associated DOM, CSS OM, and or any associated resources like JavaScript, CSS, etc. And then the browser paints and then paints the page, passes the HTML, paints the new page, and constructs a new HTML document from scratch, and also like fetches any JavaScript or CSS or any other images, assets like that from scratch. So let's like Wikipedia would be a great example where like if you see every time you click on a link, there's a full page reload. I mean, it still feels pretty fast, but like as JavaScript evolved, we got like single page applications that take advantage of client-side routers that improve this user experience, that can improve this user experience even further. So let's see how client-side routers work. So basically, whenever you click on a link, like on an app that is using client-side routers, instead of like doing the full page reload like we saw before, client-side routers intercept the navigation and prevent the default behavior of full page reload, and then the router passes the current URL, and instead like it itself updates the UI and also updates the history stack accordingly, so that the back and forward navigation work as expected. And then finally, if like the page might have some data fetching requirement, which it can fetch via making any additional client-side network calls if needed. So again, like this has allowed us to build web apps that not only need to reload with every subsequent navigation, they can also persist UI and state across navigations and make only the network requests that are actually needed. And overall, like we get a feel of a desktop app from today's web applications. And also client-side routers have come a long way now. Like they not only help with just basic navigation, they also have stuff like code split based on route. Like they'll only fetch data for a particular route based on the route you're currently on. And they can also restore scroll position when you are moving back and forward between pages. And they can also like prefetch any assets when you are hovering over a link. So yeah, and modern frameworks like Next.js, Remix, etc. Integrate really powerful client-side routers that help you build really performant applications. Like Next.js and Remix, for example, like have like for the first page load, they render and stream the response from the server, and for the subsequent request, they use a client-side router, which then again only updates the part of the UI that is needed. And like if the JavaScript is not loaded, it can also fall back to the default navigation. So they have like really good routers, and you also have like standalone routers like React routers, etc. So which can be used if you are building static client-side applications. But in this talk, we'll be focusing on one of the routers in particular called the TanStack router. So the TanStack router is created by the creators of TanStack Query, formerly known as React Query. It not only has all the features that the modern frameworks have, but what makes it really stand out is its huge focus on TypeScript. So TypeScript is embedded in like every part of the router is fully type safe. So that's what makes it so special. And without any further ado, like let's get into the demo. Okay, so I'll increase the font size. Okay, so here I have set up a basic dashboard app, which we'll be building for the rest of the talk to understand how the router works. So this is just a basic Vite app, and I'm using Tailwind CSS and Chat.cn UI for the UI. So right now it's just in main.tsx, we just have added this div, that's it. So if I go to let's go to the next commit. So with this, so with this commit, I have installed all the dependencies needed for the router, and I have also added the Vite plugin. The TanStack router has a Vite plugin, which I'll get to in a minute, like why is it needed. And we'll be using like file-based routing for this, which is the recommended way for navigating with TanStack router. And what I've done is like I've created a root component which just contains some UI, and we create root component via create root route, and like you can consider it like it's the top level root route and the only required route in this router. So you can consider it similar to what we say like the root layout in Next.js or the equivalent root.tsx in Remix as well. So yeah, and also I will not be going too deep into how the file name convention for the routing works. So here is a screenshot from the documentation. So basically we use, for flat file-based routing, we use the path name as the, it uses the path name as the URL, and like you can use the dollar prefix for any dynamic params you have. Yeah, so, okay. So let's go on to the next commit. Okay, so in this next commit, I have like updated the main.tsx file to use the router provider. So router provider would basically take care of rendering all our routes, and it's and we import it from TanStack React router, and we create it via the create router. One thing you'll notice is that it expects a route tree, which is like undefined right now. We don't have a route tree right now, and this is where the Vite plugin that I showed you earlier come into play. So if I run the dev server again, you'll see that it generates this file called routetree.gen.ts. So this is where like all your routes would, like it contains the config and the whole tree for your route. And let me just like import it. Yeah, so it basically would contain all the routes and the route tree for your app. And you'll also see this block. So this block is basically how you get the magical type safety across your app. So we register this router inside the TanStack module. So wherever you would import this module, you'll get all the types that are generated via here. Okay, so again, so if I run this again, so yeah, like this root.tsx that we saw earlier is visible now. And let's create the index route. So what you'll see is that it immediately, like that the router plugin automatically adds an export for the route inside the file. But and like this component property is where we define our component. That's how we added it in the root route as well. But what you will notice is that it also has this path which specifies like which route this file is currently rendering. Now you might ask like, can't it just figure out from the file name itself? Well, yes, it can, but like the thing is like without this path, TypeScript would have no idea which file you are in. So this is a bit redundant, but this is required. And anyways, like the Vite plugin takes care of updating it for you. So even if you update it to something random and save the file, it would automatically change it to the correct path again. Okay, so now I think like we are not still seeing the hello that we added here. That is because like we haven't told the root route like where to render this. So basically I'll add like I have to tell the root route, like where to render the child routes. So I'll use the outlet component. You can consider it similar to the children plop that we use in layout in Next.js, or similar the outlet component in Remix as well. And now, yeah, like it renders this. Okay, so yeah, like let's move on to the next commit. If we go to the next commit, I'll go to this. So with this commit, I have added some static UI for the dashboard. And I've also created another page called the sales page. Again, this is completely static. I've created a similar sales.tsx route. So again, like let's start by adding the links for navigating between these pages in this route. So I've already added this comment for a link component, and I'll just uncomment this. And this is where you see the first glimpses of type safety of this router. So as soon as I add toProp, you'll see the TypeScript autocomplete, like giving you the suggestions of what paths are available here. So as you can see, like we have only added the slash path and slash sales path. And you can also do relative navigation, so you can go to the sibling route or go back via the link tag. So I'll add the slash page. And I'll also do one more thing is I'll add active props. And I'll add maybe a class name of So this would be applied when the link is active. So if I save this, yeah, you'll see the dashboard link appearing here. And when it's active, it will show the active link. And similarly, like I'll create another component, like I'll create another thing for the sales tab. And yeah, we have the router working. And again, like it's completely type safe. If I type something random, it would throw an error and your code won't compile. So yeah, that's it about the routes. Now, again, let's see how it handles data fetching next. So I'll go to this. So again, I haven't made any changes yet. So I'll go to the the index.tsx route. And the way that TanStack router handles data fetching is via the loader prop. So all I need to do is just add a loader, and I've already created a function that makes an API call and returns a promise with the dashboard stats. So you'll see like it returns promise of dashboard stats, and I can just directly use the data using route.use loader data. And then, yeah, then I can just like update these static values to use the dynamic, the data we get from the API. So I'll just quickly update these. So again, like I get full type safety here as well. And yeah, like now if you see this, all of this data gets loaded from the API. So again, the React router, the TanStack router uses render as you fetch pattern. So with render as you fetch pattern, you don't wait for your component to render, then start fetching the data. You start the fetching before, and then it uses suspense to like suspend the component while the data is being fetched, and then renders the component. So it's pretty fast. And then, like what if now we wanted to add a pending state while the component is loading? So I'll add a pending component. You can do that via the pending component. And I have already created a pending component. So what this was do is like this pending component would be used as a suspense fallback while the data is being loaded. So right now, if you see, you won't see the spinner yet because by default, like TanStack router avoids showing the spinner unless the data takes more than 1 second to load, which is again, like you can configure that. But that is done to avoid any weird layout shift. So like let's just increase the delay. So I have the API code here and I'll like increase the delay to maybe 800 milliseconds. And now if I reload, yeah, you'll see the loader that we just added. Like that's all we had to do and it takes care of everything else. No if else conditions for rendering the loader, etc. And the last thing I would also like to show is like you'll see this TanStack router logo at the bottom. So what I've done here is like I've added like TanStack router also comes with its own dedicated dev tools similar to React Query. So again, like this lets you visualize all of your route state, and you can see all the available routes and the currently matched routes. And you'll also be able to see like the cached matches. So again, since this was created by the creators of TanStack router, it also borrows from the TanStack queries. It also borrows some of the stale while revalidate caching that React Query has. So by default, whenever you fetch data, the TanStack router caches the data. And then by default, the stale time is 0. So what that means is like whenever you go back to the dashboard page, it would show you the stale data and then fetch the data in the background. So yeah, and this like actively shows you the current age, the stale time, which is 0 second by default, and last is the GC time, which is the garbage collection time. So if within 30 minutes the data is not being used, it would just garbage collect it. And yeah, so let's see that. So since it is cached, there's no loading spinner. Like, let me show you the network tab. So it shows you the stale data while it makes the request for the data and then like updates the page if there's any new data. So you don't have to worry about like showing stale data to users. Yeah, and this stale time again can be modified like at a global level or at per route level. So I'll add a stale time of let's say 10 seconds. So now if I reload the page and if I go back to sale, yeah, so it won't like fetch immediately. So if like I'm on sales page and I go back to like the dashboard page after 10 seconds, so yeah, so it would make the request after those 10 seconds because the data is considered stale. Yeah. So that's mainly about how data fetching works. Like there's a lot more other things as well. So let's see those as well. Again, I'll go to the next commit. So with this commit, what I have done is like I've integrated the API in the sales page as well. So this is being fetched from the API as well using another invoices/all. And if I go to the sales page, it's like very similar to what we did for the dashboard tab. Now you'll also see like I've also added one more page which is supposed to show the invoices you click here. So if I go to sales/2, so it shows me the second page. But currently the link tags here, these are supposed to be link tags, they are not working. So let's start by integrating them. So what I'll do is I'll add, you get like immediate autocomplete, like this is the sales/invoice ID page. And now since like, again, this throws error because you need to add params, like you need to tell what the invoice ID is. So you have to add the invoice ID. And again, you get full type safety here as well. So I'll add the invoice ID. And yeah. Yeah, so this works now. So again, and one more thing is that like, since all of this, like all of the routes are fetched in parallel, so what you will see is that straight, like there are no waterfalls, like both of the routes are fetched in parallel and are then rendered immediately as soon using suspense. Okay, so like, again, we'll also add this so that we get which route is currently active right now. And I'll also add like, maybe we can like improve this performance even further. So I'll add preload intent. So what this would do is like, it would automatically like, preload the relevant data for the route as soon as I hover on it. So for example, let me reload to clear the cache. So if I hover over this, you'll see it already preloads it, and then it opens this page immediately without any loading state. So that works because like it preloads the data, and by default, like similar to stale time, you also have preload stale time, which is 30 seconds by default, and again configurable. And the preload, you also have the preload delay, which is like how long should a user hover over a link before it starts getting like preloaded. So yeah, like again, this significantly improves the UX. So maybe we don't want like 50 millisecond delay. Maybe we want to increase the delay. So again, it's pretty straightforward. I'll make this 500. So the preload. So now like, instead of immediately loading, I'll have to hover on it for a bit to for the request to be made. And lastly, one last thing I would like to show with data fetching is request cancellation. So I'll go to the invoice ID route. So basically, TanStack router also supports like automatic request cancellation via bot controller API. So in the loader, you get a bot controller. And also, I forgot to mention this, but like you also get the param. So since we are on the invoice ID page, we get the invoice ID param. So again, it's completely type safe as well here. So yeah, like, and I've already added this abort controller to my Axios. So I'll just pass this abort controller here. And then what you will see is that if I like quickly fetch between links, so the router automatically cancels the requests that are not needed anymore. Okay, so now coming to my last and the most favorite part of this router, which is like it's a huge focus on like type safety with search params. So TanStack router like already takes care of like search param validation, serialization, and deserialization for you. So if I run this, like I've already written the code for this. So what you will see in the sales page, all I've done is like I'm using Zod to specify the search param object. So these are the search params that I want my page to have. And again, like I get complete type safety for search params as well. So I've defined these via Zord enum. So like filters is an array of an enum, and like sort would be an enum, and search is just a string. So yeah, like you get, and you just need to pass this to validate search, and then that's it. Like you get complete type safety for these search params across your router while updating and getting them. So you use them via router.useSearch. So as you can see, you get these here. And then what I've also done is like, since our invoices would be like the data we fetch would be dependent on this. So I've also added like the TanStack router also has this thing called loader dependencies. So this tells the router that, hey, these are the search params that that this route is dependent on. So whenever they change, you need to fetch the data again and then re-render the component with the new data. And again, like whatever the dependencies you specify here is what you get here, and you can pass it to your invoices. So if I remove sort, you'll see sort is no longer here. Okay, so yeah, and you'll also see like it adds the default values for search params. So also one more thing is like I'm using catch instead of default for Zord. That's because we don't want our app to break if a search param is invalid. For example, what if this was like this? So like TanStack router will automatically take care of correcting it based on whatever value you have provided in catch. And based on that, so yeah, that's basically all I've done, is that I have updated, I am using the search params and updating them. That's all I am doing. All the data fetching is being taken care of by the router. So basically, if I apply a filter, it automatically works. Like whenever the URL change, whenever the search params change, the router knows, and it automatically adds it to the cache as well. So you'll see like all of these with the filters are added to the cache. And yeah, and again, like as like I think TanStack router, like they recommend using this approach because it's like the OG state manager. So instead of doing the data fetching manually using useState, by managing the filters manually using useState, we use the query search params, because this has many benefits. Like I can command click on a link and it would have the same things applied, and I can share this link with anyone and they would see the same state. And yeah, so, and I can also do search, so it immediately updates the URL as well, and like I can also reload and the state never goes away. So yeah, like that's the main part. And also it also does all the serialization and deserialization for you. So you can have like really complex nested objects inside your search params, and TanStack router will take care of serializing and deserializing those for you and give you complete type safety across your loaders and your route. Yeah, so that's mainly it about the demo. So coming back to the slide, and yeah, there were a lot of other features as well. Like, trust me when I say that, we have barely scratched the surface of what this router can do. There are a lot of things like route masking. You can like render another route, render a route and then render another path on it. And it also has support for streaming SSR and data fetching with external libraries. So it integrates really well with React query or like TanStack query. And since we saw like it has the data fetching support, it doesn't have very good mutation support. So if you are mutating the data a lot, they recommend using external libraries like TanStack query. And you also have deferred data loading and many more things. You can check out their docs for more things. And they're also building this framework, this full stack framework, which they call TanStack Start, which uses TanStack router underneath, and it has all the modern features like server functions, bundling and etc. are all integrated inside the framework, similar to how we see with Next.js and Remix. And yeah, so you can check them out at tanstack.com/start. So the question remains like, when should you actually use the TanStack router? And I think like Tanner Lensley, like the creator of the router, very well summarized in this tweet. Like right now, like modern frameworks like Next.js, Remix, and everyone is like optimized for load performance. So like they are optimized for like you ship as less JavaScript as possible, and your page loads as fast as possible, which is good. But like this, what TanStack router and TanStack Start would be focusing on would not be like this, would not be like e-commerce things, but instead it would be for those who want to build like highly interactive and scalable client-first JavaScript applications. Thank you.
Hello. Can we have a huge round of applause for Prateek? So it's time for some fun activity. Goodies? Yes, no, maybe? Are you guys tired? Are you guys feeling lethargic? Let's do something to boost you up. So we'll play a very quick game. We'll test your reflexes. So I'll call out right, you need to raise your right hand. I'll call out left, you need to raise your left hand. I'll call out both, you need to raise both your hands. Are you guys ready? Okay? Clear? Okay. Right. I can't see all the hands. High. Or a little more. Left. Right. Left. Right. Left. Right. Both. Left. Left. A few people changed. Right. Both. Both. A few hands went down. You guys aren't paying attention. Right. Is that your right hand? Are you sure? Left. Both. Okay. Can we play a clapping game now? Okay. We'll clap in a pattern. 1, 2, 3. 1, 2, 3. 1. 1, 2. 1, 2, 3. 1, 2. 1. 2. I said 2. I didn't say 1, 2. That was a trick question. All of you failed. 1, 2, 3. 1, 2. Okay. Now can we try cheering, hooting from the back? Only the last 4 or 5 rows. Can we have a huge round of applause? Can we cheer? Can we hoot? Woo! Last 5 rows. Only the last 5 rows. Both the sides. Once again. the middle benchers, the front benchers. Oh my God, the front benchers are loud. Interesting. Okay, so now I'll just say middle, back, or front, and you guys have to cheer. Ready? Let's see who wins. Then we can do a left versus right as well. Okay? Front. You guys are also front benchers, not just them. Right? Back. Why are back benches so low? Middle. These are the real backbenchers. Everyone. Why is it low? Everyone. Okay, so I think we are back in the Josh and we can move ahead for the next talk. So we have the next talk by a first-time speaker. So can we have a huge round of applause first for that? So for an introduction, she's a senior front-end developer at a company called Deserve. And one interesting thing about her is that once she got hammered and broke prod. She pushed something when she was drunk, so never do that. That's a tip coming from someone who has done that, not me, her. So yeah, and she'll be going and telling you about image optimization techniques and how beginners and seniors alike can use these techniques and image formats and intricacies to elevate your web experience. So can we have a huge round of applause for our next speaker, Palak Bansal.
Hello, am I audible? Is everyone awake now? Thank you. Cool. As we all know, a picture is worth 1,000 words, right? A human brain is able to interpret images much faster than text and helps user engagement, when we develop websites. And high quality images often help increase in conversions and like a better user overall user experience. Well, in the web world, sometimes gorgeous, beautiful and huge images are worth a few seconds of load time as well, right? And Google's research shows us that when websites meet the Google page speeds insight thresholds, users are 24% less likely to leave a page before any content has been painted. Hey everyone, my name is Palak, and in today's talk, I'm going to be covering image optimization techniques for making websites faster, get best scores on Google, and just have a better overall user experience. And in the short span of my career, I have seen many web developers, be it juniors, seniors, struggling to navigate through these techniques, leading to bloated web pages that hurt performance. And I too had a hard time solving this. I even face that now, because I feel performance. It's not moving. Slide is not moving. Yeah. It's not moving. Yeah. Sorry for that interruption. Yeah. So as I was saying, I feel performance is a journey and has been a very difficult one for me. The reasons were best practices were always changing and new formats were released constantly, and it became very difficult for me to keep myself updated from time to time. And who are we kidding? We have to achieve all this at scale, right? And I feel most of us developers don't fully understand compression techniques and mechanisms and the different image decoding techniques that web has to offer. Okay, so let's go back in time. And I think everyone is familiar with this tag, and it does not need any introduction. We all know that the image tag has long played a simple but powerful role within the web platform. All of us know how to misuse an image tag, right? And from there, the browser had only one job: get the image data, then render it as quickly as possible. For most of the web development history, working with images didn't get much more complicated than that. And despite the modern web's complexity, the fundamentals of working with image tags haven't changed much. So let's go through the couple of points that we think about whenever we use an image tag for our web development techniques. We use a web-friendly image for compatibility. We use a sensible compression mechanism to conserve bandwidth. And then we figure out all the dimensions that suit, when the image is going to occupy the page's layout, right? Everything was going fine and for certain, but the image tag wasn't up to the task of accommodating the radical shifts that the browser was facing over the years. While responsive web design became a mainstream development practice, browsers optimized the performance of image tag for nearly 20 years. But for most users, the image content of pages was inefficient from the outset. No matter how quickly the browser managed to request, pass, and render an image source, the asset would likely be far bigger than the user needed. And as it stands now, images are the web's biggest assets in terms of total transfer size and number of requests per page. Web pages are getting larger every year, and the reason for it to matter is because people today have grown to expect good performance from the web. It's no exaggeration to say that optimizing image requests may be the single biggest performance optimization you can make today. While you're about to learn a number of ways to ensure your image requests are as small and efficient as possible, the fastest image request will always be the one that never gets made. And this is where lazy loading comes into picture. Yeah. So I hope everyone is aware about how lazy loading works. I'll just go briefly into that. So lazy loading ensures that requests for images aren't made fully until they fall close to the user's viewport, deferring them from the initial page load, the time when the browser is at its busiest, and removing those requests from the critical rendering path. Simple as may it be in practice, using this attribute can have a huge positive impact on performance. An image that never falls within the user's viewport will never be requested, and no bandwidth will be wasted on images that the user will never see. Luckily, there are plenty of JS libraries available for lazy loading to your web pages today. Things like Lazy Sizes or React Lazy Load. But our very own image tag has gained some superpower over the years by adding an additional attribute natively. Moving on, if we were to talk about Netflix, which has a huge catalog of recommendations to watch, it became quite difficult for them to provide users with all the data at first load. They had this goal of creating a rich and enjoyable video preview experience so that members had a deeper idea on what was to offer. Netflix wanted to optimize their homepage to reduce CPU load and network traffic to keep the UX intuitive. The technical goal was to enable fast vertical scrolling through 30+ rows of titles. The older version of their homepage would render all the titles of the highest priority, and that would include data fetching from the server, creating all the DOM, fetching all their images. And they wanted the new version to load much faster, minimize memory overhead, and enable smoother playback. So here's where they ended up. When the page now loads, they first render billboard images at the very top 3 rows on the server. Once they are on the client, they make a call for the rest of the page and then render rest of the rows with all the images in. So they are effectively simply rendering the first 3 rows of the DOM and lazy loading the rest as needed. The biggest impact for this was decreased load time for members who don't scroll quite as far, unlike me. I love to scroll Netflix a lot. Moving on. And this is effectively a summary where they ended up. Overall, faster startup times for video previews and full screen playback. So before, there was a CPU load required to generate all their DOM nodes and get images to load. and now they don't saturate quite as much as member bandwidth, and they pull in 4 times fewer images on initial load. So their video previews now have faster load times, they have got less bandwidth consumption and lower memory overall. And Google's research tells that image lazy loading has helped many brands shave an average of 76% of their image bytes on initial load as a result of using this optimization. This includes companies like Spotify, Target, and of course, Deserve. In addition to the image lazy loading, this capability is also applicable to iframes. The exact same loading attribute is possible to use on iframes and is a huge opportunity for us to optimize how we address loading third-party content. Moving on, the modern user now expects images to look good and be performant across a wide variety of devices. This is why making images responsive is considered as an important technique. Responsive images are the practice of serving multiple versions of an image so that the browser can choose the version that works best for the user's device. We'll go in detail. So as you can see, responsive images can either be based on serving different widths of an image or based on different densities of an image. Density refers to the device pixel ratio or pixel density of the device that the image is intended for. For example, traditional CRT monitors have a pixel density of 1, whereas Retina displays have a pixel density of 2. However, these are only just 2 of the many pixel densities that like in use of devices today. Now let's consider one more case study related to pixel density usage. And what X realized that it was unnecessary to serve images beyond a retina density. This is because the human eye cannot distinguish between images beyond that density. And this is an important realization because it decreased image size by 33%. The one exception to this is that they do continue to serve higher image densities in situations where the image is displayed full screen and the user can pinch zoom on the image. Now I'll move on to the very last technique that I have in store for you. I think you may already be familiar with the core concept of a content delivery network. Basically, it's a network of distributed but interconnected servers that quickly and efficiently deliver assets to the users. When a file is uploaded to a CDN provider, a duplicate will be created to other nodes and basically a CDN network around the world. And when a user requests a file, the data will be sent by the node geographically closest to that user, and which helps in reducing latencies. Now, image CDNs are an excellent way to optimize images on the web, and switching your website images to a CDN network can help you yield 40 to 80% savings in image file sizes, and in most cases, they can optimize your images better than a build-time image optimization script. You can think of image CDNs as an basically image optimization as a service. They provide a level of sophistication and functionality that can be often difficult to replicate on your own local script-based optimization. For images loaded from an image CDN, an image URL indicates not only which image to load, but also parameters like size, format, and quality. This lets you create variations of an image for different use cases. The computing power image CDNs have at their disposal means they are able to offer an incredibly powerful feature, analyzing the content of an image to algorithmically determine its ideal compression level and encoding settings, just as you or I would manually fine-tune compression for each one of our images. These algorithms automate the decisions you might make, balancing file size and quality, analyzing image content for measurable signs of degradation, and fine-tuning compression settings, like I mentioned earlier. So this frequently means huge reductions in file size compared to the one-size-fits-all manual approach to compression settings. I'll show you an example. So I would like to mention that there are two types of image CDNs. One, self-managed CDNs, and like basically they are good choice for websites with engineering staff who are comfortable maintaining their own infrastructure. And third-party image CDNs, for example, Cloudinary in this case, it's kind of like a cloud service provider which provides infrastructure for a fee, and image CDNs provide image optimization and delivery for a fee. And I know it must be sounding a bit complex. Implementation couldn't be like much simpler, as you can see. For example, the Q auto you can see in the URL, second URL, will help in generating a bigger file with a high visual quality through a lesser aggressive algorithm. And I feel this is a good way for engineers to not worry about image performance and focus mainly on the business logic. And I think I've come to the end of my very short talk, and that was all I wanted to share about images. And I feel and I think by now you have learned a lot about how images work on the web and the part that they and you can play in building a faster, more efficient and experience for users everywhere. And before I wrap up, I want you all to think about all these points before introducing an image in your front-end application next time. First is, always remember that websites that load fast prioritize images a user needs when they need it. Users with slow connections also deserve a beautiful experience. For best performance results, remember that less is more. And the most important thing to remember is the fastest request is the one that isn't made. And on that note, thank you so much. And if you have any questions, I'm happy to take them backstage. Thank you.
Can we have a huge round of applause for Palak? Very interesting takeaways. I think we discovered a lot of image optimization techniques that probably a lot of us will be applying to our side projects. Hopefully thinking that we'll finish them someday. And some of the points at the end really hit me, Palak. Less is more. Reminds me of my manager, tells me that every performance cycle. Some of you got the joke. Okay, so next up, we have a speaker who was an in-house DJ before in his school. Cool, right? DJs aren't cool these days. Who are? Stand-up comics? Okay, so next up, we would like to introduce Gerard Ratnam, who's the technical lead at WSO2. Currently, he is working at a project called Asgardeo, which is a cloud-based identity access management project. Today, he'll be talking with us about the application on how to boost the GTM strategy, which is go-to-market strategy. So, can we have a huge round of applause for him?
All right. I hope you guys can hear me. So yeah, I'm here to talk about this. So basically, how we can simplify React login using Asgardeo. So next. Sorry, guys. Can I do manually?
Yes, you can use the laptop.
Oh, okay, I'll do that.
Yeah, just use the laptop.
Okay, sorry about it. Okay, I wanted to introduce myself, but I think Sahil already did, so I'm not going to bore you with all those stuff. So skipping to this, so first thing, why we need app login? Okay, so I took these two main use cases. So the first thing is access control, right? So when you have an application which is secured and you want to which you can't expose to everybody, but the limited set of people, you need to have sort of access control level in that application, right? Let's take an HR application. So HR application, you can't allow anybody, like everybody to log in, right? So you need to make sure that only the required people or the people who have authorized, it's supposed to log into that application. So there, what we can do is, so once we allow them to identify themselves and log into the application, then you have to think about the authorization level. Because like in admin application, you have there will be people who has different level of authorization. Like some senior managers will have their level of operations and the junior level of managers will have their level of operation. So you can't allow everybody who logs into the application to just mess around with all the operations. So you need to control the access as well as the authorization level of the features that you are going to provide it with that application. So it's pretty straightforward. So the next thing I took is the personalization. So someone can say not all the applications required a login, right? For an example, if we take a cricket information application, you just show some scores and highlights and things like that. Of course, you don't need an login for that particular application, right? But imagine now, every day there will be one or more application comes into online that will compete to the products that you will do. So what happens is eventually we need to think about the user experience stuff. So, and then what happens is in order for you to cater a better user experience with your application, you need to personalize the content for that particular user that user will have based on their likes and dislikes, they will have a better experience. So one thing we can do is, of course, as we are React developers who's working on front end, we can utilize our local storage or session storage in the browser and save some metadata and get this thing done, right? But imagine now this same user logs in with a different device, and you need to sync the whatever the meta information that you used to personalize the content for that particular user in the other device as well. So in that case, you need to store this in a backend or a separate different system in order for you to get back the same metadata and provide them the same experience when they log in from a different device. So in order to do that, again, you need to identify the user. Now you need a login to do that because then only you can sync the data in order to personalize. So like I said, even if we think by start it's not required a login for that particular application, but eventually going forward, you might end up having a login in order to give a better user experience or do personalization related stuff. So of course, this is two main things I took it as highlights, but there are more other things like analytics, monetization, data integrity, things like that, which you require more and more going forward with your whatever the application that you develop. Okay, so I took this image basically to ask what is an app login. In simple terms, people looking at this as, okay, it's just, simple username, password, credential, login you required, or maybe just a social login you just need to integrate to your application, and that's all. But actually, when you start, maybe you will start implementing that part, and going forward, you will find out that there are more things you need to consider in order for you to have a proper authentication system for your application. So for an example, you will end up, like I said, also social login and stuff, but then again, you have to think about the password reset stuff, user registration, and how to make your authentication more stronger using multi-factor authentication. And of course, when your application goes into maybe a globalized level, then you have to think about the compliance stuff and things like that. So basically, you might think, okay, implementing app login is a very small part of a regular application, but ultimately you will end up developing or maybe investing on the app login part, same as you investing on your app business logic part. Yeah, so I took this quote from the internet. So it is by Carl Sandburg. So Carl Sandburg is an American journalist who actually wrote about Abraham Lincoln's biology and several other readings. So, so this simple quote, it says like, time is the coin of your life, right? And it is the only coin you have, and only you can determine how it will be spent. So, I mean, when we are developing something and when we are investing on something, it's all about time. And we need to think what, I mean, the ROI of the investment you do, like for an example, you invest on something on the business side, it is always, that is the end goal that you want to give to your customers or the users that you are going to, you are developing that application for. But imagine, apart from that, you have to invest on the application login stuff as well, which is a common thing for many of the application, and you don't have to reinvent anything and or redevelop anything there. So think wisely when you are developing an application, as we are React developers, for the things that you invest, is it actually worth investing on that, and what you need to actually focus on. So this is from Asgardeo. So basically what we wanted to say is, why die when you can fly, right? So basically, I mean, when we develop an application, the main goal is for us to like make it publicly available as soon as possible. So if you can boost up your GTM or like the go-to-market strategy of your application, that is the ideal thing, and that is what we need. We don't want to like spend like maybe years and years developing the application with all the components and delay your application to go to market. So we, from the Asgardeo team, developed this Asgardeo React Auth SDK to help out with this. And of course, the Asgardeo product is there, which is an identity and access management solution, which provide not just authentication, like I mentioned in the iceberg image. All the components are there and much more. It's just like few things I picked up just to like show what are the additional things that you have to think of when we developing an IAM solution or an identity and access management solution. So let's talk about the React Auth SDK that we develop. Why we say to use this. So one thing is this React Auth SDK doesn't have any vendor locks, and it's completely open source. And it is built on top of the OpenID Connect standard protocol, which means you can bring your own identity provider. It doesn't mean that since you use Asgardeo React Auth SDK that you need to stick with Asgardeo product. It's not that. You can bring, if you have any other vendors, you can just configure it and use it for your application. It just, you need to make sure that you like get rid of all this OpenID Connect protocol implementation part through the SDK. And of course, it is secured by design, so which has an inbuilt secure storage mechanism that we have done it to prevent XSS attacks. I mean, one of the challenges we have is how to protect the access token when we deal with OpenID Connect. So what we have done is using Web Worker, we have implemented solution within the SDK itself to protect the access token and, I mean, prevent from the XSS attacks. Then, of course, it supports all the React latest versions. As we also using the same SDK, we are not just asking everybody to use it because all our application we are using React SDK. So we are making sure that it is up to the date, and also it covers all the security stuff much as possible. And yeah, the other point, like I said, since we have developed this proxy within the SDK itself, which is running on the client side, it's not necessary for you to have a BFF or a backend for frontend, just to save the access token, right? Of course, if you have other requirement, you might have to have a backend to run on the services, etc. But if you have a simple application, just need a login, you don't have to worry about at all. You just simply use the SDK and it will cover up whatever the requirement you want there. And yeah, so it also has out-of-the-box features like sign in, sign out, and state management stuff. And also it provides all the authentication hooks for for you to utilize all the operations. And of course, it has the extensibility where you can have you can bring in any identity provider or configure all the operations which is there. Like I said, so to simplify, so SDK configuration is simple as this. You just need to install it through NPM and just import the auth provider and wrap your application, and that's all. You just need to then go to the identity provider, your preferred identity provider, and register your application and configure, just pass the configuration to the SDK, and just manage all your login flows, like the user registration stuff, your users, the authorization things, whether you have organization structures like B2B, B2C, everything you can just do at the identity access management solution, and without worrying about implementing any of those. Oh yeah, so that's all you need. So it's very simple. So the takeaway I wanted to give you is just make sure, with my experience I'm telling, to being in the industry for so long, don't just waste your time. I know we as developers, we love to code, but when you go into an industry to sell your application, you can't just waste your time on just investing on investing on stuff that's not actually gain anything for your whatever the business. So be smart on that, and whatever the stuff you can delegate, if there are tools and utilities out there, just utilize it and move forward with your application and boost up your application's GTM strategy. Yeah, so okay, stop, gone. Oh, okay, sorry. Yeah, so if you want to learn more about this, how to integrate the SDK as well as configuring identity provider and all. So we'll be be joining this workshop, and anybody who likes can come and join with us. It will be 3-hour session maybe. Yeah, so that one, this is in Bangalore, and also we will be going to Delhi as well. If someone is from Delhi, want to join there. So this is by JS Lovers, so we'll be there as well. Yeah, of course, I know a lot of people who visited us today at this booth, so if you still want to have a chat with us and want to learn more, we'll be there. We love to have a chat with everybody and maybe talk about what we can do, or maybe help the React community more with whatever the products and supporting we are giving here. All right, so that's all. Thank you very much.
Thank you, Gerard. Can we have a huge round of applause? So we'll take a short break right now. Let's have some tea, coffee, and come back stronger. And we have much more exciting talks and one event also, some goodies waiting for you on the other side of the break. So please be back soon in 15 minutes. Thank you.
Hello. Attention everyone, we are going to start shortly. Please take your seats. Hello. All right, everyone. How's the Josh? All right, we need that energy again. How's the Josh? Yeah, so we have a fun game for you all, and the name of the game is Logo Loco, in which you have to identify the brands and win some goodies. So who is excited to win some prizes? Can we see some hands? All right. Can you give me a cheer? Yes? All right. So we have our fellow participants, we have our fellow team members who are going to run this quiz, and all of you, please give your best and let's see who wins.
Hello, everyone. Okay, so now time for some fun activity. What we are going to do is, I'll be showing you a slide with a lot of logos on it. And I'll be needing some volunteers to come up on the stage. And your task will be to identify those logos. So any 5 volunteers, please come on the stage. Yeah. I can see 3, 4. Okay. Cool, cool, cool. That will work. आ जाओ, आ जाओ. चलेगा, आ जाओ. चलो, 5. No, that's fine. Okay. So, अभी हाँ. Just see these logos. Now, one by one, you all have to identify the logos, and the one who will identify the maximum will be the winner, basically. Guys, please, it will come once like these guys fail, it will all come to you. Okay, you start.
React, HTML, CSS, Justin, ESLint, TypeScript, and this is what? Electron, IntelliJ. This is White, and this is VS Code, Vercel, Android, Java, GitHub, Swift, Tailwind, and this is, I don't know, 2. Okay, I lost 3.
So Keshav answered 15 of these logos. Now let's see what the next person can do.
First one is React, HTML5, CSS, Zustand. Then I don't know, next one, IntelliJ IDEA. This is Webpack, Nuxt.js, Electron.js, TypeScript, GitHub, Java, Android, Visual Studio Code, Vercel, Vite. This one I don't know, that is Tailwind, CSS, and Svelte.js.
17, nice.
React, HTML, CSS, React, HTML, CSS, Zustand, ESLint, Nuxt, Babel, Redux, TypeScript, GitHub, Java, Swift, Tailwind, Android, React Router, VS Code, Prisma, React Query, Vite, IntelliJ. Yeah, all done.
17 again.
I probably won't do as good. So React, HTML5, CSS3, Zustand. I don't know what that one is, so I'll just guess it is Redux. Forgive me if I'm wrong. IntelliJ, and this is Vercel. This is Webpack, Nuxt, Electron, TypeScript, VS Code, Android, Java, GitHub, Swift, Tailwind. This is React Router, and this is This is TanStack, right?
Another 17.
This is wheat.
He did that.
React, HTML, CSS, Juststand, Webpack, Nust, Electron, TypeScript, IntelliJ IDEA, Wheat,
Please
Vercel,
start once
Electron.
again. Please start once again.
React, HTML, CSS, Juststand. I don't know about that. TypeScript, Electron, Nust.js, Webpack, IntelliJ IDEA, Wheat, Vercel, VS Code, Android, Java, GitHub, Swift, Selenium, CSS, React Router, and Stack. Oh, I don't know about that.
18, not bad.
Yeah, done. I have already done.
Oh, so we have a winner with us, Chirag, who got 18 right answers.
99.
Yeah. So that is ESLint, the corner one. Yeah. Okay, thank you. And you can collect your goodies from there. The Chirag. Okay. Here it is. So now for the next slide, next 5 volunteers. I want to have a female participation as well. Can we have some female on the stage? Great. I'll give you the mic. We'll start. All of them? No, next. We'll have a next slide now. Wait.
Oh my God.
So, let's start.
Okay.
You want to give it a try?
Okay, hold on. Hold on. Okay.
How many?
It's working, right?
Guys, please. Let them think. Yeah.
From the sequence, or I can...
Anyone, pick anyone.
Okay, this is Nike.
1.
Fast Track.
2.
Not sure. I think Louis Vuitton.
3.
Adidas.
4.
Crocs.
5.
Van Heusen.
6. Yes.
Wild guess, but Tanishq.
7.
Not sure what this is.
Let me know, then we can pass on to next person.
Yeah, you can.
So we got 7 answers from Keyur. Next. Anyone?
Adidas, YSL, yes, Saint Laurent.
YSL I can read. You have to tell the name.
Yes, Saint Laurent. Then this is Crocs, Nike, Giorgio Armani, Fast Track, Louis Vuitton, Under Armour, Tanishq, and what is
Hey, you don't have to help him.
Venice, that one, and CNTO, I think.
And let's pass on to next guy. So he got 8 answers right. Next. The one who had done, please, can you come over here? Start.
First one, I guess, Volvo.
Keep the mic close.
Volvo.
No, you can continue.
Yeah. Adidas. Actually, this is Nike.
2.
Giorgio Armani.
3.
Fast Track.
4.
Tanishq.
5.
And Audi.
No. Okay.
Yes.
Done?
And yeah.
Let's pass on. He got 5 answers. Next.
It was very better.
Hard to 6, but it's fine, yeah. Start.
Right. Van Heusen, Adidas, Nike, Tanishq, Fast Track. That's all.
5. Next.
Adidas, Nike, Fast Track, Tanishq.
4. Next. I'm expecting something more than from you.
I think the first one has to be Versace or Virgo. I'm not sure. Jockey, Adidas, Chanel, Saint Laurent, Gucci, and Crocs, Nike, Fast Track, Louis Vuitton. That is, I'm not sure. That is Tanish. But yeah, I'm not sure about this one.
She got 10 answers right. So I'd like to call another one, another lady. Kenny, any one of you guys, please come. Come now. Come, please. Aa jao. Yeah.
Okay. Yeah. Okay, so that's Van Heusen, Jockey, Adidas, Chanel, Saint Laurent, Gucci, Dior, Tiffany, Crocs, Nike, Tanishq, Under Armour, Louis Vuitton, Fast Track, and Armani.
Please give her a huge round of applause.
All right. A round of applause for team member from our AV team. Yes. A round of applause, everyone. That was clues.
Thank you so much.
All right. So that was something different, right? And in the beginning, when there were tech logos, I was like, okay, it's all going to be about tech. But then the game changed. And I said, Zindagi badal di, jazbaat badal diya, right? So that happened. All right. So some of the reelers and memers got it, I guess. We have an interesting last 2 talks of the day, everyone. And these are going to be really to the point, in-depth, something which you can connect with, and a lot of takeaways. So please make sure you pay attention. And yeah, so as we move forward, we have Apoorv. He has been a teacher. Like, he's a teacher at heart. He proudly says that he has taught more than 1,000 people to become developers. And a round of applause for him for mentoring 1,000 people. Also, he says that he teaches what he knows, and what he doesn't know, he learns, right? And very interesting thing that he has been featured in many dance cover videos. Yeah, award shows, events. He has acted in a theatrical play. So I guess anyone who is involved in theaters, dance shows, anyone, I guess you know, Apoorv will be also your guy. Apart from the tech, he can also do that. And very interesting conversation we are going to have, how to optimize the first load of the web app and a lot of performance things and going under the hood. So everyone pay attention. A huge round of applause for Apoorv Khare.
Hello. I have a question for everyone. Who here has lied during an interview for having a skill that you didn't have? Okay, some of you. So this context is for you. So let's consider this scenario that you have a web app which is getting a couple of complaints from the top paying customers, okay, regarding slow performance. Now, you get this task assigned by your manager to improve the performance. Why? Because you lied during your interview to your manager that you were the go-to person for the performance in your previous company. So now you have to do this task. What do? You do the normal research. You do Google, you do ChatGPT, right? And you find out all the latest and greatest tricks. You do lazy loading, server-side rendering, code splitting. You do, incremental static regeneration and whatnot. But you barely see any improvement in the performance, right? Now you understand and you realize that you need to understand how the browser renders the UI so that you can measure the relevant metrics and put the relevant optimization. Okay, it's time to go back in time. Hi all, I welcome you all to my talk, Flashpoint Performance. I'm Apoorv. I work as a software engineer at Adobe as SD4. I have 8 years of experience building large-scale front-end application. I teach what I know and I learn what I don't. Agenda for today's talk is that how to measure the performance, understanding the critical rendering path, and optimizing the first load of your performance. As a wise man once said, always measure first and optimize later. So in order to measure, you need metrics. No, not this matrix. You need different kind of metrics. So there are 3 metrics which you can use to measure your web app performance. The first one is browser-centric metrics. Basically, this tells the browser the state of your website. Okay, so when did the page load? How long did the server take to respond? Okay, so we'll be talking about those metrics. The next one is user-centric metrics. Okay, so this gives information like, did the navigation start successfully? Has enough content rendered so the user can interact? And we'll be talking about the famous core web vitals in this. And the last one is the custom metrics. Here, basically, if any of the pre-existing metrics do not satisfy your unique performance needs, then you can create your own metrics. A scenario can be like, how long does it take for a server-side rendered app to hydrate, right? So you can create your own metrics using any of these APIs, okay? And FYI, I'll be sharing a QR code to these slides, so you can check these links on your own. Now let's talk about the first slide, first matrix, which is time to first byte. Let's understand this from a diagram, not from the definition. So whenever a user enters a website in the URL bar, what first thing happens is redirection, then the browser checks in the cache, then if it's not there, it does the DNS resolution, then it does the TCP connection with the server, then it makes the request, and then the response starts. So the time difference between the user entering the URL in the URL bar till the response start, that is your time to first byte. And obviously, we need to have this as less as possible. Now let's talk about the next matrix, which is speed index. Basically, this talks about how quickly the contents of your page are visibly rendered. Again, let's understand this from a diagram. So on the x-axis, you can see it's time in seconds, actually milliseconds. And on y-axis, you can see the percentage of visual progress. So let's say it takes 5 seconds for your entire website to load, including event listeners and all the stuff. But within 2.5 seconds or near to that, visually it is rendered. This is comparatively a good speed index. Let's consider a scenario where it just renders 40% at that time, and the rest all visual progress happens like near to 4.5 seconds. That's not a good speed index. Okay, so these were the browser-centric metrics. Let's talk about the user-centric metrics. Here we'll talk about core web vitals. It is an initiative by Google to provide unified guidance over web app performance. And core web vitals are a subset of them. The first one is LCP, which is largest contentful paint. It relates to your initial load. Okay. When exactly did the most important part of your website render? Usually that's the largest part of your website. And it can be different for different screen sizes. So let's understand this from an example. So during the rendering, the browser considers multiple components as your LCP. So while it was rendering, when the image was not there, it considered the header as the LCP. And eventually, when the entire page loaded, it understood it's not the header, it's the image, right? So the time taken to render this image is your LCP. And there are standard scores for having a good core web vital metrics, similarly for other metrics also. The actual score is not important. We'll see the demo in page speed insight. But you need to be in the good score of that. The next one is INP. This was recently introduced, and it replaces FID. Now let's first talk about INP. It is interaction to next paint. It corresponds to interactivity. Okay. It assesses a page's overall responsiveness to user interactions like click, touch, keyboard, and the final INP value is the longest, barring the outliers. Okay, so again, let's understand from the diagram. On the left-hand side, you can see the user is clicking, but the first click is not registered, and then he clicks again. What happens, both the clicks are now processed together, and the accordion closes like in a fraction of a second. So that's not a good INP score. On the right-hand side, if you see, it's working as expected. The user clicks, the accordion opens, user clicks, it closes. Okay, so that's about INP. It was replaced instead of FID. Now, FID is the first input delay. Again, let's see from the diagram. Like browser receives the first user input, and the browser can respond to the first user input. So, but it was only measuring the first input delay. It was not measuring the overall user's visit, what other interaction it is dealing. Hence, it was replaced. Okay, and it was replaced recently in March. And the next one is the CLS, which is cumulative layout shift. It corresponds to visual stability. Again, let's understand from the diagram. Let's say you want to order, but you have a change of mind, you want to go back. But oops, there was a banner, and now you clicked it. And now you ordered something, 14 items, maybe 14 iPhones, I don't know. But you didn't want to do it. You were just playing around Amazon website, trying to get a large cart value, and it's gone. And you would have seen websites where there are banners popping left, right, and center, right? It's not a user experience, good user experience, right? You are frustrated with that. So I know who am I looking to, who are downloading tutorials from websites where they are like clicks, 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 and then at the end you get the link, hopefully, right? Now that we know the metrics, let's understand on what kind of data do we measure it. So there are two types of data. One is lab data, one is field data. Let's talk about lab data. Lab data meaning you measured your performance in a control environment where you had control over the connectivity, let's say 2G, 3G, 4G, whatever you want, and over the device specification, like 8 GB RAM, 16 GB RAM, 4 GB RAM. Okay, so that is a lab environment. When do we use such data? When we have to ship a feature. It is not in production, but before shipping, we need to measure the performance. At that time, we will use such data. And tools for lab data is Lighthouse. How many of you know Lighthouse? Good. So for those who don't know, it's in the Chrome DevTools, right? And there is one more, web page speed test. How many of you know this? Good. We'll be seeing a demo of this. Second one is field data. Basically, these are real user visits. Okay. So once the app is in production, you want to measure actual performance. There are many ways, but let's discuss about two. One is page speed insights. Okay. And another is web vitals package. Page speed insights underneath uses Chrome UX. Chrome UX report is a large data collected by Google of many websites over years to track performance details. Okay, and we'll be seeing about it. And Web Vitals is an NPM package which you can use in your own app to measure. Now I know what you're saying. I understand, but show me how these metrics are practically measured. So let's do that. Web page test demo. I already opened it here. I took this test on 19th of September 2023 on netflix.com. The environment conditions are Chrome version, cable. I can even show you like what kbps and latency it is, how many test runs, from which region, okay, and first view only. So these are the criteria that I had given. And if you go down, you can see the details. Is it? Yeah, good. You can see the TTFB. There are other metrics also, but you can see TTFB, you can see speed index, you can see LCP, almost everything seems good. Now here, there is one more good insight. You click on film strip video, scroll. What you see here, this scroll bar, this is very amazing scroll bar. Below is the network waterfall. Okay, who knows what is a network waterfall? Okay, so for those who don't know, basically any request that you make when your website is loading, it is captured in your network bar in your DevTools. Okay, and this is a snapshot of that. So you can scroll this and see exactly at which second what request was being made, what type of, if you see legends over here, it's a JS is for this color, font is this color, HTML is this color. So you can even scroll and check what it was, what type of content it was, what was the domain, what was the origin. And if you scroll, you can see at that particular request, what was the state of your UI. Okay, so this is a very insightful report that this web page test gives. And there is an API also available, which you can use. Other than that, also it gives other insights like visual progress. You can use this for which browser metrics? Can someone tell me? This one. Speed index, visual progress over time. We saw it, right? And then there are other metrics, okay. Now let's go to the next one. And web page test we just saw. This is lab data or field data? Lab data. I told you, right, I gave conditions. I gave conditions like which version of Chrome, what cable from where and all. That's the condition given by me. Okay. Now let's see the demo of page speed insights. I will already open up. I took this report yesterday because page speed insight doesn't store reports for long. It gives a report of phone and desktop, both. Okay, and if you just quickly see here, it's a report of mobile, and this is for phone. Core Web Vitals all passed, okay, and you can exactly see what is a good score and what is their score in particular. Here, if you see Chrome UX report, which I was talking about, right, the large data set created by Google, and various desktops, last 28-day collection period. So Google had collected last 28-day data of Netflix.com, okay, and this report is based on that user's visit in that time, okay. It gives you all performance details, accessibility details, and one most important part it gives is hints to improve the performance, like serve images in next-gen format, right? Then efficiently encode images. You can go through each of them, see what you can implement, and improve the performance, okay? Now, this was for field data, means actual production data, for website which Chrome UX has. But not necessarily your app will be there in that Google, because your app might be a B2B application which is behind a login, right? So Google can't index that. So what you do is you use a Web Vitals NPM package, okay? It is created by Google again. What you do is you see this code. It exports 3 functions on CLS, on INP, on LCP. And then you have a callback function, okay? A normal function basically which you will pass as a callback. This function will report this data to your analytics service. In this example, I have taken example of Google tag. Okay, so you write this function, whatever you want to do, however you want to send the data, and then you pass that function as a callback to on CLS, on INP, on LCP. And that's it, and that's how you collect data, okay, of your own websites for performance needs. Now, you might be thinking after knowing this that, okay, you're ready for performance optimization. But wait, don't be impatient. You still don't know what you're optimizing for. By the way, if by this point you're not understanding why the talk name is Flashpoint Performance, you might want to ask your comic nerd friends. Okay. Let's talk about critical rendering path. It is the steps between getting the HTML, CSS, and JavaScript, and the process to turn them into pixels. And there are 5 steps to this. First one is HTML DOM creation. Second one is CSS object model creation. Yes, there is an object model for CSS also. DOM, I think most of you would have heard, but there's an object model for CSS also. Then there is a render tree construction. Then there is a layout, and then there is a paint phase. So let's talk about each of these. The DOM tree construction starts. So let me tell you one more thing. So whenever you request for any website, the first file that the server sends is most likely to be an HTML file. As soon as the browser receives the HTML file, it starts parsing it. And it has characters, right? The characters are then converted into tokens and then converted into nodes. And then we construct the DOM tree, which is document object model. Okay. And one more thing, HTML DOM can be constructed in chunks. What does this mean is that if your server is responding the HTML file in chunks, let's say first 50 lines, then 100 lines, then next 100 lines, the HTML DOM can still be constructed in this way. Next part, the next phase is the CSS object model construction. As with HTML, same process, okay, no difference. The difference that is there is that CSS object model cannot be constructed in chunks. Would anyone like to say why? Any guess? Okay, let me tell you this. Let's say in your website, there's a paragraph tag, p tag, which has a class and an ID. In your style sheet, you give some style, some font to your paragraph tag. Going down in your file, you give some font size, different font size to the class. And going down, you give a different font size to the ID. So what is happening is, if it was being constructed in chunks, the CSS object model has to be reconstructed again and again. And hence, CSS object model cannot be constructed in chunks. It has to do in one go. Okay? And hence, CSS is render blocking. Okay? Now let's understand the third phase, which is render tree construction. Very simple phase. Whatever is visible DOM content from your HTML DOM and CSS object model, that turns out to be your render tree. Okay? So let's see, understand from the diagram. If you see, there is DOM, there is CSS DOM, and this is a render tree. Head, meta, link did not come into render tree. Why? Because it has nothing to do with visibly, right? And if you see the web performance span, which is display none, that also didn't come into render tree, right? So this is a render tree. Whatever is supposed to be visible, a tree of that. The fourth phase is layout. Basically, based on the screen size on which you are accessing your website, where exactly everything is to be rendered, the X and Y axis. That is the layout phase, the calculation of that. And then the last phase, once you know what is the DOM content, what are the computed styles, where exactly do I have to put that, then the browser paints. Again, this is a complex process, but we are not going to in depth of that. So let's see the demo of this, okay, in the performance tab. So I had taken this reference of this website, Hacker News, very simple website. Okay, let me play the video. What I do is I go to the DevTools, I go to the performance tab, then there's this reload icon in the DevTools, right? That means it will reload your website and start recording. Okay, so I will do that, reloads, I'll click reloads, I stop, and then I get a detailed performance report. If I go to the event log, okay, here I can find the details of the critical rendering path. So first I will search for the HTML DOM construction. So if I do parse HTML, I see all the logs for HTML parsing. Let's see that. See here, if you see that 3 to ... 166, those are line numbers. Okay, so let me play again. And similarly, it's 0 to 1. Okay, so and even if you click there, it will take you to that particular line in HTML. Okay, so again, if I click here, it takes me to the line. Okay, so this is regarding your HTML parsing. Now, I will be showing the parsing of CSS. So if I play again, style sheet. Now can you relate why it's only one parse style sheet, not multiple? Because CSS object model cannot be constructed in chunks. Okay, so it's only one. Now let me play again. Let's check. A render tree is not shown in this log, so we'll go to the next phase, which is layout. So if I go to search layout, there are multiple layout logs. Okay, and you can click and check what exactly did that in layout. And then the last one, which is paint. And with paint, there is pre-paint. Okay, again, I'm not going to depth of it, but I hope you get the idea of all the 5 steps. Okay, so that was the demo part. Okay, now you know what are the metrics you need to measure, and you know what are you optimizing for. So let's do the optimization. But before that, let's understand what is first load and what is repeat view. So a user access your website on a desktop or any device on a browser for the first time, that is your first load, okay, and subsequent visits by that user on the same browser are the repeat view. Both have different performance optimizing technique. So we'll only be talking about first load. Otherwise, it will be like whole day. Okay. So let's talk about that. The first and most basic thing you can do is enable gzip in your text-based files. Okay. Or you can use broadly compression. What this will do is like what amount of data that has to be transferred over network reduces that. Simple, right? Its performance optimization is simple. It's just you have to understand what you have to optimize for. Second, use CDN for static content. In a previous talk by Palak, right, she mentioned using image CDNs, right? So let me explain CDN in a very non-official documentation. Your usual servers, when you hit it, it has to do some business logic, and then it has to return the HTML or whatever file or whatever data it is. CDN you can consider as a dumb servers. Whatever you ask, it returns. Whatever you ask, it returns. And they are comparatively cheap, so you can deploy it at multiple places. Okay, so any static data, okay, it can be your image, it can be your HTML file, it can even be your JavaScript bundles. Okay, so it can deploy them to CDN. The next is optimizing JavaScript. So JavaScript is parse blocking, and you should defer it as much as possible. Let's understand what do I mean by this. And the next section will also explain you a good question which is asked in interview. Let's see. So consider a React app, okay, which is client-side rendered. So actually, at the end, it's just an HTML file which has a script tag with your source app.js, right? With me here. Now, what happens is, when the HTML parsing starts, and it encounters the script tag, it pauses the parsing. It downloads the script, meaning the JavaScript, it executes the JavaScript, and then it continues the HTML parsing. Okay. And this is required because our client-side React app, we use JSX to update the HTML. We can't avoid that. But you can do still some optimization using the async attribute. Okay. When you use async attribute, what happens is the HTML parsing continues when the script is downloading. But as soon as the script downloads, it will execute and pause the HTML parsing. And once the script is executed, then HTML parsing continues. Still better, right? But if you have any JavaScript which is not relevant to your first load view, okay, your web page view, like analytics, okay, then you can defer it. You don't need it in the CRP. So what you do is, what this defer attribute does, the HTML parsing continues, script downloaded parallelly, and only when the HTML parsing completes, the JavaScript code is executed, right? The best case scenario. We can't do this always because in client-side rendered React app, we need HTML, but if for any analytics sort of JavaScript, you can use this. So I hope now you know this question, what is async and what is defer, a very important interview question. Let's talk about optimizing CSS. Okay. So as we all know, CSS is render blocking. We already established that. Get it to the client as soon as possible. Using what? Using resource hints and other techniques. We'll be talking about that, don't worry. So, but there is one more thing. So when you are serving to multiple devices, your website is able to access, user can access your website in multiple devices, you will have different media queries for them, right? Different style for making your website responsive. What you can do is, you can separate out that CSS in separate CSS files and use media type to link it separately. Okay, so this one, the third one, is orientation portrait. It is for phone. Then in some cases, it's important to print in your website. Let's say Indigo. You want to print a ticket, right? Then there's a separate CSS for that also, right? So what you will do is, you will separate it out so that based on which device the user accessed that website, only those CSS will be downloaded. No unnecessary CSS download. Okay, this is a very basic sort of optimization you can do. Next, we'll talk about resource hints. So basically, it is done using the link tag. It has 3 attributes: href, very common one, just where exactly your file is; as, which tells which type of content it is; and rel, which is relationship. And we'll be talking about 4 of them over here: preload, preconnect, prefetch, DNS prefetch. Let's talk about preload. Okay, so for that I need to take a page out. Assume this is your entire website, okay, entire web page. This page is your entire web page. And this is your web page without the user scrolling it. Now this is known as above the fold content. And this is known as below the fold content. You might have heard this, but now you know what it is. Okay, so whatever is above the fold content, be it images, CSS, whatever it is, you should get it as soon as possible. So you can preload that even before the critical running path begins. Okay, and you can do that using this preload relationship in the link tag. Okay, next one is prefetch. So preemptively fetch and cache the target resource as it will be likely required in the next navigation. Let me give you an example. So you know from lots of research done in your app that whenever a user visits the cart page in your app, he is 90% likely to go to the checkout page. Okay. So what do? Whenever you are done loading all the content for cart page, you preemptively fetch the content required for the checkout page. And here is where prefetch helps you. Okay. The next 2 are preconnect and DNS prefetch. So usually in a website, you are trying to access lots of different domains for different purposes. Some is CDN, some are different API backend servers. Let me even show you. If I go over here, this one. This is netflix.com, then there is NFLXX, cookie law. So there are different domains, right? So in order to connect to them, what you can do is you can preempt, you already know what are the domains that it requires to connect. So what you can do is you can use preconnect, which does the TCP connection preemptively, and then there is DNS prefetch, which does the DNS resolution preemptively. Okay, so this was about the resource hints. Now let's consider one more scenario. This is regarding, let me give you an example. In your above the fold content, okay, there you have an image carousel. Now, it's obviously important to load all the images in that image carousel, but what you need is the first image to come first. What you will do is you will give it a fetch priority of high, so that even though all of them are required, all of them you give the relationship as preload, but the first one will be given the highest priority and it will load the first. Okay, I hope it makes sense. Now, let's talk about optimizing the core web vitals. It is using the knowledge that we gained till now. Use resource hints and fetch priority to eliminate resource load delay. Okay, common, right? Nothing new. Reduce the size of your style sheet or inline CSS required only for above the fold UI. I know inlining CSS, bad practice, right? But at least for above the fold UI, you can do that so that it gets rendered fast. Use optimized image format like WebP. Okay, it gives you high resolution image in less size. Okay, and serve different size of images for different devices. Like for desktop, you would use like 1 MB or something. I don't know, 250 KBs, and for phone, you can use even lower. Optimizing INP, that is interaction to next paint. Memoize long task or offload long-running task to a web worker. So web worker, if you are not aware, you can create a separate thread which runs separately to your main thread, and you can offload JavaScript tasks to it, okay, so that it can be executed parallelly. And they can communicate with each other using post message API. But one important thing, you cannot offload DOM-related tasks to your web worker, okay? Only JavaScript tasks, okay? The last one, which is optimizing CLS. Here, it's very basic. Add height and width to all of your content, okay? Be it images, ad banners, whatever it is. So that even if it loads later, right, it doesn't cause layout shift, okay? So now, after this talk, you're ready to go back to present and fix the web performance the right way. Thank you all for attending my talk, and I hope you learned something new from this today.
All right. What a power-packed talk, right? Yes? How many of you learned something new? How many of you learned something which you can apply in your projects right now? Amazing. Apurv, that's the impact you have created. And a huge round of applause for Apurv for that amazing, insightful talk. For the next session, we have a very interesting speaker, yet again. And just like Apurv, so I wanted to say a few words that it's been, I think, 6 months or about 1 year ago when I invited, when he submitted CFP in some other event which I was hosting, and we invited him, and he totally killed it. And fast forward to today, we are happy to have him, and that was a very detailed and great conversation. Just a heads up, everyone. So we have a special, I would say, reward for everyone who is staying, who has stayed until the end for the last talk. So how many of you would like to have these exclusive GitHub and Copilot stickers? Can I have show of hands? All right, amazing. So you can find these as you exit the gates, right? So on all 3 gates, we will have our volunteers, and you can ask which sticker you want, and then they will be happy to give it to you. Now, something about Saurabh. So he and I connected during COVID time when everything was locked up and we were doing some open source events, and I reached out to him to feature because it was an open source conversation, and he was one of the youngest speakers we had ever invited in our sessions back then. I was working for a coding learning platform from Japan. And fast forward to today, he's at Razorpay. So round of applause for him for coming so far. And why? You might be wondering why. Because he has created his own static site generator, Able. And yes, everyone. Yeah. How many of you can actually remember people who have done that? That's something which others can utilize, right? And at this age, he has done that, and he's absolutely killing it. And he's now a senior front-end engineer, I just noticed. Great job. Yeah? All right. And another thing that in his free time, he usually just chills and sleeps, right? So nothing much. Yeah, so, yeah. Right. So, an interesting topic, we have debugging performance issues on your website. So you must have noticed when your website is slowing, you don't know why it is slowing. Something like, it is one of those scenarios when your app works, when your app doesn't work, you don't know why, and your app works and you don't know why. Can you relate to that? Yeah, when your code works and you don't know why. So something like that. But yeah, here, when your website slows down and you don't know the reason, and it can't be just easy way out, just looking at the insights from the, Saurabh will be diving deep into more details. With a huge round of applause, please join me in welcoming Saurabh. Yeah.
Thank you, Yashraj. So I know it's the last talk, so I'll be pretty quick. The thing is with performance, fixing performance is really easy. You just go to PageSpeed Insights, you put down your URL, click the Analyze button, you get this, and then Google will just tell you that you should do these things, and the performance will be improved. And yeah, that's it. Thank you for coming to my talk. Bye. So yeah, it wasn't going to be this quick, but 3 years back, we started working on the performance for our landing page. And one remarkable discovery we made was it's pretty difficult. There's no straightforward way. There are indicators, but there's no do this and your performance is improved. I can explain that in meme than words. So it's kind of like this, where you start with Lighthouse, but then you still have to understand the concepts and what is loading, what is not loading, when are things loading. So there are a few more things that you have to understand more than Lighthouse and the tools that we use. Performance issues are like any other bugs. It's, let's say you have a bug in your code. First thing you would do is debug. Like normal people would put console logs, weird people put breakpoints, but essentially how to debug. So that's my talk. We're going to debug. We're going to learn how to debug the performance issues. This is like step 0 of solving the performance issues. Before I start, I want to talk about how websites load. You type in the URL in your browser. The first thing that happens is your domain will resolve to an IP address. So there's DNS lookup, connections, SSL, and a few more steps. I'm not going to details of this, but it's mostly the connecting to the domain part. Then your index HTML is requested. So the browser will request for the index HTML. The dark blue part is the part where your browser starts loading the HTML, starts executing the HTML, or passing the HTML. When it's passing the HTML, it will come across your link rel style sheet, and that's when your style sheet will start loading. Apur, in a talk before me, talked about how CSS is render blocking, and that's why we don't see anything on your screen until this point. And after this, you'll probably start seeing some layout and some paint on your browser. This diagram is probably going to be the most important one. This is something that we're going to talk about a lot. You'll probably see this in my every slide from now. And we call this diagram as something called as network waterfall. It's a waterfall of requests that happen when you're loading the website. Let's see what are some red flags in the network waterfall. So one is when let's say you're loading a CSR app. With CSR app, what happens is you initially just load the div root, you load the empty root, and then you start loading the JavaScript. And then the JavaScript goes and adds things to your HTML. So initial HTML doesn't really have the information on what all the website has, but the JavaScript adds that information. So you see this network waterfall where the JavaScript is now deciding when your site is loading. This can go bad pretty quickly. For example, let's say you're lazy loading that CSR application, then your homepage.js is loaded by the index.js, and your actual paint is happening after the homepage.js. That is about JavaScript. Let's talk about images. So we load the index.html, JS, and your JS has, let's say, the image. In this case, you will see things on your screen. So you are seeing that middle stage where it's an empty content, but it doesn't have an image. And eventually, it loads the image. The first marker is FCP. Again, something that Apu talked about, so I'm not going to details of the definitions of FCP, but it's essentially the first time the content is painted on your screen. The second point is LCP. That's when the largest content on the page is being loaded. In this case, the largest content is the image. We talked about JavaScript, we talked about images. Let's talk about fonts. With fonts, let's say you're loading with Google Fonts or any third-party font library. What will happen is your HTML, in your HTML, you're probably putting this link rel style shit to the Google's fonts.css. So it'll load the Google's font.css first, and then it'll load the actual font. Here you're seeing this purple line, which we talked about, how it's DNS lookup or connecting to domain part. You're loading third-party libraries, so it has to connect to this third-party domain. It's a new domain for your browser. It doesn't know what this domain is. So you see this extra additional time in between where you have to connect to the domain before you actually start loading the site, start loading the CSS files or font files. So this is another network waterfall red flag that you can see with Google Fonts. And yeah, it's our demo time. So what we'll do is, I just showed you how there's a network waterfall red flags with JavaScript, with an image, and with fonts. We'll go and try to fix these and see how it works. So first thing I showed was how in CSR, your rendering is happening after the JS loads. So let's see that once in code. So in Chrome, you have this performance tab, which is probably the tab that you would want to use a lot when you're trying to debug something or trying to figure out what is wrong. Here you get this reload button, so you can go and reload the site, and it will record the network waterfall and all the other things. First thing I want to do is just slow down my network a bit so that it's more distinct to see. Fast 3G is usually a good speed to test things out. So I'll just go and reload this page, and we'll see how the network waterfall looks like. Now, here you see that this first part is the HTML. That's when the HTML is loading. Like I showed in the diagram, this first thing is HTML. Then you see a few other things loading. The thing that I want to show first is, if you see, a lot of the code is actually loading after this JavaScript part. For example, this hero image, this image, is loading pretty late in the waterfall because it's your JavaScript that knows what this image is, but your actual source code, if you go to view source, wait. If you go to actual view source, your hero PNG or your style sheets are there, but your hero image or a lot of your HTML content is not really here, so your browser doesn't know what to load. So it's kind of relying on this client.tsx file, which eventually goes and loads the images. So you see that waterfall with the CSR. Let's actually fix that. I kind of have this setup where I just have this flag where I can turn this into true, and it will be an SSR. So I'm not going to explain the setup, but we'll just see how, what difference we see in the network waterfall. Yeah, I'm just reloading again. This is a SSR website now, so we'll see what difference we see in the network waterfall. Now, if you see, like last time, a lot of your content was relying on JavaScript to eventually load. But now, you see these things shifted this side. And if you look at the view source, You see all the content is here. So if I look for hero PNG in this, you'll see that hero PNG is actually being loaded. So your browser can actually go and figure out that it wants to load hero PNG first, and it will go and make that request, and things will load faster. So this was about fixing the JS parts. Let's actually fix the image parts as well. In this, you're probably seeing that this image is still loading fairly late. Like, this is an important image. We want to show that first. This is an important thing for user. So it should load a bit earlier as well, right? What I can do is, if I go to my code, here you're seeing this loading lazy thing. This is the issue we faced at razorpay.com as well, where we had one common image component, and it had loading lazy as default. And a lot of time, it just ended up lazy loading the hero image. What we'll do is, first, we'll just remove this loading lazy. Another thing that we can do is, because we know that it's an important image, we can also start preloading it. So it'll be one of the first things that start loading. Now let's try this and reload. Now if you see, the hero image is loading pretty fast. It's almost loading as immediately as the HTML is there. So if you see, your LCP also gets closer because your hero image is now loading earlier, and FCP almost got fixed because of the CSR change that we made for JavaScript. Another thing was fonts. We talked about how when you're loading a third-party font, it just creates this network waterfall where you're calling a third-party domain, it's calling the font file. So let's try and fix the fonts. If you go to Google Fonts, in this web, you'll see that there are these two extra things called pre-connects. There is obviously this link style sheet, which is for styling. But there's also pre-connect that Google usually recommends. I had commented out this, but let's actually remove this and see how it works. One thing about pre-connections is it's kind of difficult to figure this out in this performance panel. A better tool for figuring this out is a web page speed test. So I had kind of tried this out on the actual webpage test.org, and we can see the difference once. So first one is, this one is without the pre-connect. Here if you see, the Google Fonts file is loading. Yeah, it's this request, which is the first CSS request from Google Fonts. And then after that, you see this another request, which is going to the actual font file, which is coming from gstatic.com, the two domains that we are actually pre-connecting. Here, if you see, the connection itself starts after the Google Fonts CSS is loaded. But when you actually add those pre-connects, the difference you'd see is here, you see this font CSS loads, the Google CSS loads the way it did. But here you see this another pre-connect request, another connection request, which happens a lot earlier. It happens at the start itself. So eventually, when you're loading the font, actual font file, you don't have to pre-connect again because it's already connected at this point. So this is kind of how you can fix the font issues as well. So we saw the JS issues, the font issues, and the image issues. So let's move to next things. Next thing I want to talk about is interactions. So far, we've only talked about the loading part of performance, where how your website is loading. But another important part is how does the interactions happen? You might see yourself at such situations a lot of times where you're clicking buttons, you're hovering over things, but nothing is happening, your website is stuck. How do you fix these issues? So let's do that demo as well. So on this website, if I hover over these items, they load pretty fast. But if I hover over these payments, there's some weird laggy things that are happening, it's not pretty fast. So how do you figure out what is happening, what is the issue? So you can again go to inspect, performance. This time we don't want to reload the page, we just want to test that interaction itself. So here there's another button called record. So you can just start recording at that point itself. So yeah, that's what I'll do. I just started creating. Do I have another tab open? Oh, this is still loading. OK, this should work. Yeah, the recording started. So now we can actually hover over and see the interaction, just interact with things so that it's being recorded in the DevTools. So here we see that things are getting blocked. You can stop and just see the things. Here you see these tasks, the blocking task, a lot of blocking tasks here. You can actually scroll down and see what is the problem. So if you scroll down here, it says that there's some function called block main thread please, which is just blocking the main thread for a lot of time. So we'll see, we'll go and find what is this function. Here I see there's some function that is being called when I'm trying to open the menu. What if I just remove this? And I can clear this, record again. Here if you see the interaction issues are fixed, it's interacting pretty fast now. And you probably wouldn't see those blocking things anymore. So if you want to figure out your interaction issues, you can actually use this main thread tab where you can see the blocking issues. Now, this is great, but realistically speaking, nobody probably has block main thread please function in their code unless they hate their jobs. So it's very, very rare that the verdict would be so easy, the issue would be so easy to find. A lot of INP issues are fairly difficult and not so obvious. What often happens is, for example, when we were working on Razorpay.com, one issue that we faced was we were loading a lot of JavaScript in general. So there was no particular function that was blocking the main thread, but just the amount of JavaScript we had, which was blocking the main thread. And which is weird, because Razorpay.com is a static web page. It's mostly just content. It doesn't need to have JavaScript. But the way React loads is even when you're doing SSR, it will still load all the JavaScript code that you're writing in your JavaScript bundle. It won't skip that. So because of that, a lot of JavaScript was being loaded, and main thread was getting blocked. And because main thread was getting blocked, the initial interactions, when people were trying to interact with navbar while things are loading, were very laggy. And that is kind of something that we wanted to fix. Back then, Divyanshu, who was my tech lead, we kind of discussed on how we can fix that. And Divyanshu mentioned that Astro does something called selective hydration, where you can mark a certain part as just non-static and certain part as static. And that can fix the issue. And I jokingly said that if we actually end up fixing that in our code base, because it's a custom code base, it might be worth just releasing a new SSR library out of it. So drum rolls. Presenting a new framework, no, it's just React Server Components. React Server Components kind of fixes this problem where it lets you mark certain things as just static. We'll see that demo. Yeah, I built this demo at like 2 a.m. at night, so it's really just default looking application. There's no effort that I put, but yeah, this should work. So what I said was, by default, React will load even the things that are just non-static. So for example, if I go to, I'll just copy this get started by editing. This is a static part, so it's not really interactive. It doesn't need any JavaScript logically. So we'll just go and search this. There's this sources panel where you can actually see all the source code that is being loaded in your browser. You can go to top, search in all files. Pretend it was like this. You didn't see that. It was supposed to be this. Yeah, I just reload. Yeah, that didn't happen. So when you type get started and just search it on your code base, you see that there are multiple references of get started. One is the index.html part, the index part, which is obvious. It has to be in the HTML index, first index. But you also see its reference in page.tsx, which is the JavaScript file. But it shouldn't be there. It's just the static code, right? And this is still a small demo, but when you do this on your landing pages or large code bases, a lot of code is being loaded, which is not really needed for interactions. With React Server Components, I missed this, but you can skip this. And by default, Next.js will turn this into a server component. So now if I go and search this, let me just refresh. Search this again, I just see one reference, which is the index.html. There's no reference in the JavaScript parts. So what React Server Components is doing is, because there's no directive mentioned, it will by default treat it as server component, and it will just skip adding this part into a JavaScript bundle totally. So there won't be any JavaScript when you're loading this with RSC. So far, so good. We have talked about network waterfalls. We have talked about interactions. This was the title of my talk, Debugging Performance Issues of Website. But while working on it, I realized that performance is still a scoped down term. What you're essentially trying to fix is the user experience for the user. You want your user to feel good when they're loading website, to just make it look like it's loading fast. There's a term for this, which deals with the user experience and performance together. It's called perceived performance. This is something that we don't talk about it often, but we'll just go through this a bit. So let's go with definition. Perceived performance is a subjective measure of website performance. In other words, how fast website seems to user. There's a difference between loading website fast versus making it look like it's loading fast. And the problem with this is it's harder to quantify. There's no tool that says that your perceived performance score is 100 or perceived performance score is 70. It's harder to measure as well. There's no direct way to say that this is a bad perceived performance and this is a good without really contextually dealing with which application you're talking about. I didn't make this up. This definition comes from MDN. MDN has a different page for perceived performance, which goes into details, so you can check that out as well. But let's see what I mean by perceived performance and what is exactly perceived performance. I have this demo where I'm loading a site. Now, if you see it, the one site loaded faster. It loaded a lot earlier, but it had this janky experience where it just feels like a lot of things are jumping around, whereas the second site is just loading straight up, and there's no jankiness in that. So in this case, the second thing is technically more performant. Although it's showing content slower, but it also has a better experience when it's trying to show the content. Let's see the other example. In dashboard, on one side, I have a loader. On the other side, I have skeleton loaders, and I'm just rendering some static things already. For example, this navigation bar that you see. This navigation bar that you see and top nav you see, it's already loaded because it might be static for a lot of you. It also has some animations. So if you look at the second one, you see things are loading with some animations and it's giving a better user experience to consumers. So although the first one might load a bit faster, the second one feels faster. I kind of do this on my portfolio. So this is how my portfolio loads. So you see nothing, then you see the name, and then you see the stars popping up, and then you see the shooting star. Now, technically, I'm loading the stars slower, but it gives a better experience to consumers when you're loading things this way. Fun fact about this particular example is if I go to the page speed score of this, you actually see the speed index is in yellow, it's not green. The thing is, because stars are loading slower, it thinks that things are still loading, and it kind of punishes me for that. But even though the score is low, the loading experience is better in this case. So there might be few scenarios where your performance score might give you some different hint, but you just have to take a call based on what your user experience, what is the user experience that you want to provide. One more example I had was something that I do at my documentation site for Abel. I have this live code editor. So far we talked about, even perceived performance, we talked about more in the context of the loading experience. But it is also experience of, in general, using things, using interactive things. Here, you see that I have an example, which is a live code editor. But if I refresh this page, you see the output is loading immediately. How is it loading immediately? It didn't even run the code. It didn't install the dependencies. How does it know what to output? But if I click here, you see this initiating web container, installing dependencies, starting dev server. I had another one open. Just open an incognito. Here you saw a flash of content. Now if I go and edit, it actually becomes a live code editor. Now, how do I magically know what is the output? The answer is I define it. In code, I am the one who's defining the examples code, so I also know what is the output. So when I'm defining the actual code, I also define the output, which acts as a placeholder until the time your actual code runs and installs dependencies and actually shows the output. And this is what I do with all the examples. So even the larger examples you see, it shows some content, but I can't really go and edit it. When I try to edit, it just starts initiating the web container. And I kind of handle some of these cases where, let's say I'm typing here. It's not changing, but once it loads. Yeah, once it loads, it just starts from there itself. So it's not just about loading experience, it's just about experience in general when people are interactive with things. I showed this definition of perceived performance. There are some issues. One thing is perceived performance is subjective. So there's no objective way to measure and score the perceived performance. It's also harder to quantify and measure. So there's no tool that just measures the perceived performance as such. There are tools that gives you hints on what might be the issue. For example, you might see LCP in the page speed, which will give you a hint that the largest image is loading slow. But that's a hint. That's not the source of truth. So how do you debug perceived performance if it's subjective and if it's not measurable? The answer is there's a mental model for debugging. You have to think of it from perspective of user. For example, first question that you should ask yourself is, what do you want to load in the first render? In a landing page context, I want to load my title, my CTS, and some of the initial important things. In dashboard, I want to load the side nav and the top nav. The content can actually go and make an API call, get the user data, but side nav and top nav, if it's static, it should load at the first render itself. In the code editor, the mark that I had for myself was I want to load the output as soon as possible. I don't want to show the loading and installing dependencies if someone is landing on the landing page, because a lot of people might not even wait till then. People would just scroll through and want to see the output and inputs. Second question you ask is, where is it in the network waterfall? The thing that you want to load first, where exactly is it in the network waterfall? For example, in this live code editor, if I had not statically defined the output, it would load this way, where initially it will just show a loading screen, and then eventually it will show the output. But if I want to show the output, you have to understand that it's part of the network waterfall, so I can't really show the output first. So one advice of perceived performance is fake it until you make it. It's a horrible life advice, but it really works with perceived performance in a way, where you just pretend your site has loaded, or you pretend your site is loading, but you don't really load it, or you do some hacky things around depending on your context, and just make it look like it works. We did this with razorpay.com a few years back, and this was kind of the result. You obviously see that it's loading fast, but loading fast was not just the case. It loads better. You see a lot of jankiness in the first one, where a lot of things are just moving around. The first top bar is just coming from in between, and then it shifts, it loads a bit slower. And in this case, everything is just placed where it is, and it also loads fast. These were some of the network waterfall issues, and some perceived performance issues, some CLS issues, which we fixed. And yeah, that's it. Thank you. I'm Saurabh, so you can check out my GitHub and Twitter.
Huge round of applause for Saurabh. Yes.
Right. With that, we conclude the last talk of the evening. So, would like to remind you a few points about the talks. You guys might be taking notes. I saw a lot of you writing down, scribbling down in notepads, in your phones, on your laptops. So make sure when you go back home tonight or tomorrow also, you revisit these points, the keywords that the speakers mentioned, and try to research, do your research on those keywords. Try to learn about those things so that you can make the most out of this experience. Try to recollect what kind of conversations you had with people, who did you meet, make sure you network well, and so you never know. Today's conversations can be tomorrow's CFPs. So you can be here on this stage, probably next year, or in some other conference, utilizing the knowledge you gained today and delivering a speech for some other people.
Yes.
I really like that line. Today's knowledge can be tomorrow's CFP.
Absolutely.
I really, really like it.
So we asked earlier how many of you would like to be, like your aspiring speakers, you would like to speak. So how many of you would raise your hands that you would like to speak at conferences? Amazing. Or meetups, developer meetups. You can always start small. So that's amazing. Just to add what was said here is, another thing is about one of the key takeaways, which were the three. One was technology, knowledge, what we have gained, and all the keywords. Make sure you note down that, and the networking. How many of you were able to meet at least 5 new individuals today? A round of applause for each one of you for doing that. Can we have a round of applause for coming out of your comfort zone and expanding your network? And hopefully, you have not just connected on Instagram, you have also connected on LinkedIn and Twitter, and hopefully GitHub, right? So follow each other on GitHub so that you can keep track of each other's contributions. So everyone, round of applause for everyone who have done that networking, meaningful networking. Yeah.
Round of applause, please. Come on.
Everyone.
Woo!
Thank you.
So with that,
One last thing I wanted to share, which is very close to our heart, because we are at a such prestigious stage where everyone is coming from across the country. People from across different countries have come together, and some people have come from Electronic City, which is a contribution in itself. So that means that all of you, we would love that if someone is looking for a job or if someone is hiring, I would like to just see a quick show of hands. How many of you are hiring? You're actively hiring for your teams. If you can just stand up, everyone. If you can just stand up if you're actively hiring for your teams. Everyone, please look at their faces. These are the ones you should reach out to if you are actively looking for jobs. How many of you are actively looking for jobs, or you're open to opportunities? So we just wanted to make this bridge, this connection, wanted to utilize this stage for you all to connect. As you are moving outside in this hallway, please make sure you connect with these individuals.
okay, so with that, can we have a huge, really huge shout out to all the amazing speakers who have shared their insightful talks today? Really huge. Yes.
Louder. Yes.
Louder.
At the back, people, I still feel you are not participating. Can we have a really huge shout out? Woo! Secondly, huge shout out to all the volunteers who have helped us today to make this conference run so smoothly.
Everyone, all the volunteers.
Everyone!
Yes, they are in the red.
Give it your full energy, folks. And a huge shout out to the entire AV team. They were consistently standing there to help us out and make sure that there are no technical glitches. So huge shout out to the entire
That's
AV
the most
team.
important.
Woo.
They are the behind the scene heroes.
And the most important, huge shout out to the entire amazing audience. You.
Yes, everyone.
We really appreciate that you have stayed with us till the end. I can still see the auditorium is really houseful. That's really amazing to see. So huge shout out to the entire audience.
Thank you for that.
So yeah, with that, me Akansha Doshi.
Me Sahil Kalyani.
Me Yashraj Nayak. Signing off as your host and co-pilots for the day. Thank you all for joining us for the day one. Day two is yet to come. Thank you. Good evening. Have a great evening.
See you tomorrow. Pose करना है. अभी तक तो कर ही रहे थे अब.